Close your eyes. Imagine standing at the edge of the ocean. The water stretches out before you, vast and dark and endless, disappearing into a horizon that feels less like a boundary and more like a doorway. The surface catches the light, shimmering, restless, alive. And somewhere beneath that surface, somewhere beneath the glittering skin of the sea, a world begins. A world larger than all the continents combined. A world so deep that the tallest mountain on Earth could be dropped into it and disappear without a trace. A world so dark that light has never touched most of it, not once, in the entire 4.5 billion year history of this planet. A world populated by creatures so strange, so alien, so perfectly adapted to conditions of crushing pressure and absolute cold and total darkness, that they seem to belong not to Earth but to some other planet entirely. And beneath that world, beneath the creatures and the darkness and the crushing depths, lie the ruins of civilizations. Entire cities swallowed by the sea, ships from every era of human history, resting on the ocean floor with their cargoes and their secrets intact. Archaeological sites of staggering importance, hidden under hundreds of meters of water, waiting for the technology and the courage to find them. We know more about the surface of Mars than we know about the bottom of our own ocean. We have mapped less than 20% of the ocean floor in any meaningful detail. The deep sea remains, in the most literal sense, the last great unexplored frontier on Earth. A frontier that covers more than 70% of our planet's surface and reaches depths that make space exploration look straightforward by comparison. This is 100 facts about the deep ocean. Over 100 extraordinary facts we are going to descend together, from the sunlit surface waters where the ocean teems with familiar life, down through the twilight zone where light fades and strange creatures begin, through the midnight zone of total darkness and alien biology, past the abyssal plains and hadal trenches where pressure would crush a submarine, all the way to the deepest point on Earth, a place so remote, so extreme, so utterly beyond ordinary human experience that visiting it is harder than walking on the moon. And along the way, we will explore the ruins and the relics, the lost ships and the sunken cities, the underwater archaeological sites that are rewriting the history of human civilization, the ocean's astonishing creatures, its terrifying power, and its incomprehensible beauty. Lie down, close your eyes, and let's dive. Fact 1. The ocean covers 71% of Earth's surface and contains 97% of all water. Begin with scale. Before we can understand the deep ocean, before we can appreciate its mysteries, its creatures, its archaeological treasures, we need to understand just how enormous it actually is. Because no matter how many times you have heard the statistics, the true scale of the ocean is almost impossible for the human mind to fully grasp. The ocean covers approximately 71% of Earth's surface, an area of roughly 361 million square kilometers. If you were to spread all of Earth's dry land across a flat surface, you would need the equivalent of 2.5 Earths to match the area of the ocean. The ocean is not just a feature of our planet. It is in the most fundamental sense what our planet is. Earth is an ocean world with islands of land, not a land world with seas. The ocean contains approximately 1.335 billion cubic kilometers of water, roughly 97% of all the water on Earth. The remaining 3% is freshwater, and of that 3%, about 2/3 is locked in glaciers and ice caps, leaving less than 1% of Earth's total water as the freshwater that humans, animals, and plants depend on for survival. When you turn on a tap or drink from a river, you are accessing a tiny, precious fraction of the water on this planet. The vast, overwhelming majority of Earth's water, 97 out of every 100 cups, is the cold, salty, deep water of the ocean. The ocean is also extraordinarily deep. The average depth of the ocean is approximately 3,688 meters, nearly 3.7 kilometers from surface to floor. The deepest point, the Challenger Deep in the Mariana Trench of the Western Pacific, reaches a depth of approximately 10,935 meters, or nearly 11 kilometers. To put that in perspective, if you placed Mount Everest, the tallest mountain on Earth, at 8,849 meters, at the bottom of the Challenger Deep, its summit would still be more than 2 kilometers below the ocean's surface. The ocean is not just wide, it is staggeringly, almost incomprehensibly deep. And yet, for all its immensity, for all its depth, for all its importance to life on Earth, we have explored less of it than we have explored the surface of Mars. The deep ocean remains, in every meaningful sense, the most unknown place on our own planet. What lives down there? What history is preserved down there? What secrets the deep ocean holds? These are questions that science is only beginning to answer. Fact 2. Less than 20% of the ocean floor has been mapped in detail. Here is a fact that should stop you in your tracks. We live on a planet that is more than 70% covered by ocean. We have been a seafaring species for tens of thousands of years. We have sent robotic spacecraft to the outer edges of the solar system, landed probes on Mars and Venus and Titan, and mapped the surfaces of planets billions of kilometers away with extraordinary precision. And yet less than 20% of the ocean floor has been mapped with the kind of high-resolution detail that would allow us to see features smaller than about 5 kilometers across. The reason is both simple and deeply frustrating. Mapping the ocean floor requires sonar sound waves sent downward from ships, bouncing off the seafloor and returning to sensors at the surface. The time taken for the sound to travel down and back tells us the depth at that point. But ocean sonar mapping is slow, expensive, and limited by the simple geometry of the problem. A ship can only map the seafloor directly beneath it, and the ocean is enormous. To map the entire ocean floor at high resolution using current technology would require ships to sail every kilometer of every ocean, covering an area of 361 million square kilometers of water, in a process that would take decades and cost hundreds of billions of dollars. By contrast, we have mapped the entire surface of Mars at a resolution of around 100 meters per pixel, better than most of our ocean floor maps. We have mapped the Moon in extraordinary detail. We have mapped Venus through its dense cloud cover using radar. But the bottom of our own ocean, a place on our own planet, in some cases only a few kilometers beneath our ships, remains largely terra incognita, or rather aqua incognita, unknown water. The Seabed 2030 project, an international collaboration between the Nippon Foundation and the General Bathymetric Chart of the Oceans, has set an ambitious goal of mapping the entire ocean floor by 2030. As of the mid-2020s, they have made significant progress, but the task remains enormous. Every year, new mapping expeditions reveal features, underwater mountain ranges, deep canyons, vast plains, volcanic fields that were completely unknown before. The ocean floor is not a featureless expanse of mud. It is a landscape of extraordinary geological diversity and drama, and most of it has never been seen by human eyes. Fact 3: the ocean has 5 distinct depth zones, each with its own ecosystem. To understand the deep ocean, you need to understand that it is not a single, uniform environment. It is a series of worlds stacked on top of each other, 5 distinct depth zones, each defined by the amount of light that penetrates to that depth, each with its own temperature, pressure, and chemistry, and each home to its own extraordinary community of life. The first and most familiar zone is the sunlight zone, or epipelagic zone, the top 200 meters of the ocean, where sunlight penetrates strongly enough to support photosynthesis. This is the ocean most people know, the bright blue water of tropical reefs and temperate seas, teeming with fish, marine mammals, sea turtles, and the photosynthetic phytoplankton that produce approximately half of all the oxygen in Earth's atmosphere. Despite containing the most visible ocean life, the sunlight zone represents only a tiny fraction of the ocean's total volume. Below 200 meters, the light begins to fade. From 200 to 1,000 meters lies the twilight zone, or mesopelagic zone, a realm of dim blue-green light, where photosynthesis is no longer possible, but where some light still filters down from above. The creatures of the twilight zone have adapted to their dim world in extraordinary ways. Many have evolved enormous eyes to capture every available photon, while others produce their own light through bioluminescence, the biological generation of light that makes this zone glow with ghostly flickers in the darkness. The twilight zone is estimated to contain more fish biomass than all the world's fisheries combined, a vast, largely unexploited resource whose ecological importance is only beginning to be understood. Below 1,000 meters, light disappears entirely. From 1,000 to 4,000 meters lies the midnight zone, or bathypelagic zone, a realm of absolute darkness, near-freezing temperatures and pressures that would crush an unprotected human body in an instant. No sunlight has ever touched the midnight zone. No photosynthesis occurs here. Life in this zone depends almost entirely on marine snow, the continuous shower of organic particles, dead organisms, and fecal pellets that drift down from the sunlit waters above, providing the only source of energy in the permanent darkness. Below 4,000 meters lie the abyssal zone, 4,000 to 6,000 meters, and the hadal zone below 6,000 meters, found only in the deepest ocean trenches. These are the most extreme environments on Earth, places of crushing pressure. At 10,000 meters, the pressure is over 1,000 times greater than at the surface, near freezing temperatures barely above zero, and a silence and darkness so total that they defy imagination. And yet, life exists even here. Adapted over millions of years to conditions that seem impossibly hostile, the creatures of the abyss and the hadal zone are among the most extraordinary organisms on Earth. Fact 4: the ocean produces half of Earth's oxygen. Here is a fact that most people find genuinely surprising. When we think about the oxygen we breathe, we tend to think of forests, the Amazon, the boreal forests of Canada and Russia, the great woodlands of the world. Forests are our lungs, the popular narrative goes. Cut down the trees and we run out of air. The truth is considerably more oceanic. Approximately 50 to 80% of the oxygen in Earth's atmosphere is produced not by trees and forests, but by microscopic marine organisms living in the sunlit surface waters of the ocean. These organisms, phytoplankton, a diverse group including diatoms, cyanobacteria and dinoflagellates, are the true lungs of the Earth, and they live not in the Amazon but in the top layer of every ocean on the planet. Phytoplankton are single-celled or simple multicellular organisms that use photosynthesis to convert sunlight, water, and carbon dioxide into organic compounds and oxygen, just as plants do on land. But because they are microscopic and exist in astronomically large numbers, the ocean contains an estimated 100 octillion phytoplankton cells at any given time. Their collective photosynthetic output is staggering. Every breath you take, roughly 1 in every 2 oxygen molecules, was produced not by a tree, but by a microscopic ocean organism. Phytoplankton also play a critical role in the global carbon cycle, absorbing enormous quantities of carbon dioxide from the atmosphere and incorporating it into their bodies. When phytoplankton die, they sink toward the ocean floor, carrying their carbon with them in a process called the biological pump, one of the most important mechanisms by which carbon is removed from the atmosphere and stored in the deep ocean on geological timescales. The health of the ocean's phytoplankton communities is therefore not just an ecological concern. It is a matter of profound importance for the stability of Earth's climate and the composition of its atmosphere. And the phytoplankton are under threat. Ocean warming driven by climate change is reducing the mixing of ocean waters, the process by which cold, nutrient-rich deep water rises to the surface to feed phytoplankton growth. Satellite observations have detected a measurable decline in global phytoplankton abundance over the past several decades. The implications of this trend for ocean ecosystems, for the global carbon cycle, for the very oxygen content of the atmosphere, are a matter of serious scientific concern. Fact 5. The Mariana Trench is the deepest place on Earth. In the western Pacific Ocean, approximately 320 kilometers southwest of the island of Guam, the ocean floor drops away into a long, crescent-shaped gash in the Earth's crust that represents the deepest place on our planet. The Mariana Trench, formed where the Pacific tectonic plate dives beneath the Mariana Plate in a process called subduction, stretches approximately 2,550 kilometers in length and reaches depths that strain the imagination. At its deepest point, a section called the Challenger Deep, named after HMS Challenger, the British survey ship whose crew first sounded its depths in 1875, the ocean floor lies approximately 10,935 meters below the surface, nearly 11 kilometers, more than 10 times the height of the Empire State Building. The distance from the surface to the bottom of the Challenger Deep is greater than the cruising altitude of a commercial airliner. The conditions at the bottom of the Mariana Trench are almost beyond human comprehension. The pressure at 11 kilometers depth is approximately 1,086 bars, over 1,000 times the atmospheric pressure at sea level. This pressure is equivalent to having 50 jumbo jets stacked on top of you. The temperature is just above freezing, around 1 to 4 degrees Celsius. There is no light whatsoever, and yet life exists there. Researchers who have sent cameras and collection devices to the bottom of the Challenger Deep have found single-celled organisms called foraminifera living in the sediment, crustaceans called amphipods scavenging organic material, and various other organisms adapted to the crushing pressure and permanent darkness. The Challenger Deep has been visited by humans only a handful of times. The first was in 1960, when the bathyscaphe Trieste, piloted by Jacques Piccard and Don Walsh, made the first crewed descent to the bottom, a journey of nearly 5 hours each way. The second crewed visit came in 2012, when the filmmaker James Cameron descended solo in his specially designed submersible deep-sea Challenger, spending approximately 3 hours on the bottom filming and collecting samples. A third era of exploration began in 2019, when explorer Victor Vescovo descended in the submersible DSV limiting factor and reached a new record depth of 10,928 meters, becoming the first person to visit the deepest points of all 5 of the world's oceans. What Vescovo and his team found at the bottom of the Challenger Deep was extraordinary and sobering. Among the sediment and the alien creatures of the Hadal Zone, they found plastic waste, a plastic bag, candy wrappers. The pollution of human civilization had reached the most remote, most extreme, most inaccessible place on Earth. The ocean's deepest secret, when finally fully revealed, turned out to include a reflection of our own carelessness. Fact 6. The ocean floor has mountain ranges taller than the Himalayas. When most people imagine the ocean floor, they picture a flat, featureless plain of mud, a dark, empty expanse stretching away into the distance beneath the crushing weight of the deep sea. This image could not be further from the truth. The ocean floor is one of the most geologically dramatic landscapes on Earth, a world of enormous mountain ranges, deep canyons, vast volcanic plains, hydrothermal vent fields, and abyssal trenches that rival or surpass any geological feature on the surface. If the oceans were suddenly drained of water, the landscape revealed would be more dramatic, more varied, and more spectacular than anything visible from space today. The most extraordinary geological feature of the ocean floor is the mid-ocean ridge system, a continuous underwater mountain range that winds its way through every ocean basin on Earth, stretching for approximately 65,000 kilometers in total length. This makes the mid-ocean ridge the longest mountain range on the planet by a vast margin, more than 16 times the length of the Andes, the longest mountain range on land. In the Atlantic Ocean, the mid-Atlantic ridge rises to heights of up to 2,700 meters above the surrounding ocean floor, and in Iceland, it breaches the surface entirely, making Iceland one of the few places on Earth where the mid-ocean ridge can be walked on and directly observed. The mid-ocean ridge is not just a geological curiosity. It is the engine of plate tectonics, the mechanism by which new ocean floor is continuously created. At the ridge, magma from the Earth's interior rises to the surface, cools, and solidifies into new oceanic crust, pushing the existing ocean floor outward on both sides. This process, seafloor spreading, is the primary driver of the movement of Earth's tectonic plates, and it means that the ocean floor is geologically young. No ocean floor anywhere on Earth is more than about 200 million years old, a tiny fraction of Earth's 4.5 billion year age. Individual seamounts, underwater volcanoes that rise from the ocean floor but do not reach the surface, are even more dramatic. There are estimated to be 100,000 or more seamounts in the world's oceans, some rising to heights of several kilometers above the surrounding seafloor. Mauna Kea in Hawaii, which rises from the ocean floor of the Pacific, is, measured from its base on the ocean floor to its summit, approximately 10,210 meters tall, taller than Mount Everest measured from sea level, making it the tallest mountain on Earth by this measure. The ocean does not lack for grandeur. It simply hides its grandeur beneath 11 kilometers of water. Fact 7. Hydrothermal vents are among the most extraordinary ecosystems on Earth. In 1977, a team of marine geologists aboard the research vessel Noor was exploring the ocean floor near the Galapagos Rift in the eastern Pacific, a section of the mid-ocean ridge system where the oceanic crust is being pulled apart by tectonic forces. They were looking for evidence of hydrothermal activity, places where seawater seeps into cracks in the ocean floor, is heated by the hot rock below, and emerges back into the ocean carrying dissolved minerals. What they found was one of the most extraordinary discoveries in the history of biology. At a depth of approximately 2,500 meters, in a place where no sunlight had ever penetrated, and where the near-freezing water of the deep Pacific had reigned since the ocean formed, the scientists found life, and not just life, but an entire thriving ecosystem of a richness and density that seemed impossible at that depth. Around the hydrothermal vents, cracks in the ocean floor from which superheated water rich in hydrogen sulfide and other chemicals poured at temperatures up to 400 degrees Celsius, clustered extraordinary communities of organisms. Giant tube worms up to 2 meters long, their white tubes clustered around the vents like a ghostly forest, mats of white bacteria covering the seafloor, clams and mussels the size of dinner plates. Crabs, shrimps, fish, an entire food web thriving in complete darkness, far from any sunlight. The discovery of hydrothermal vent ecosystems was revolutionary because it demonstrated for the first time that life does not require sunlight. Every ecosystem previously known on Earth was ultimately dependent on photosynthesis, on the conversion of sunlight into chemical energy by plants or algae, which then fed everything else. The hydrothermal vent ecosystems run on an entirely different energy source. Chemosynthesis, the conversion of chemical energy, derived from the hydrogen sulfide pouring out of the vents, into organic compounds by bacteria that form the base of the food web. The bacteria that live around hydrothermal vents extract energy from the chemical reaction between hydrogen sulfide and oxygen, a process that releases enough energy to fuel the synthesis of organic compounds, just as photosynthesis does. These bacteria are then consumed by larger organisms. The tube worms harbor chemosynthetic bacteria in specialized organs called trophosomes that occupy most of their body cavity, essentially running a bacterial farm inside themselves. The clams and mussels harbor similar bacteria in their gills. The entire ecosystem is powered not by the sun, but by the chemistry of the Earth's interior. The discovery of chemosynthetic life at hydrothermal vents has had profound implications beyond marine biology. It has dramatically expanded our understanding of the conditions under which life is possible, suggesting that life might exist in environments previously considered completely hostile, including the subsurface oceans of Europa, Enceladus, and other icy moons of the outer solar system, where hydrothermal activity may occur beneath kilometers of ice. The deep sea vents of Earth have become, in a sense, a window into the possibility of life elsewhere in the universe. Fact 8. The deep sea contains the largest migration on Earth. Every day without fail in every ocean on the planet, the largest migration on Earth takes place. It is not the migration of wildebeest across the Serengeti, or of monarch butterflies across North America, or of Arctic terns from pole to pole. It happens entirely underwater, in the darkness of the deep ocean, and it involves trillions upon trillions of individual animals. Most people have never heard of it. It is called the Deal vertical migration, and it is the daily movement of an enormous biomass of deep-sea creatures up from the depths toward the surface at night, and back down to the depths before dawn. The animals involved are extraordinarily diverse: fish, squid, shrimp, jellyfish, krill, copepods, and many others, but they share a common strategy. During the day, they hide in the deep, dark, cold waters of the mesopelagic zone, the twilight zone between 200 and 1,000 meters, where the darkness protects them from visual predators. As the sun sets and the surface waters darken, they migrate upward, sometimes traveling hundreds of meters vertically in a matter of hours, to feed on the phytoplankton and zooplankton that bloom in the rich, productive surface waters. Before dawn, they descend again to the safety of the deep. The scale of this migration is almost beyond comprehension. The total biomass of animals participating in the Deal vertical migration is estimated at 10 billion tons, 10 times the entire annual global fish catch. Every night, this vast mass of life rises toward the surface, feeds, and descends again, carrying with it, as it sinks, enormous quantities of carbon absorbed from the surface waters, contributing significantly to the biological pump that transfers carbon from the atmosphere to the deep ocean. The Deal vertical migration is one of the ocean's great mysteries as much as it is one of its great wonders. Despite its enormous scale, we understand it incompletely. The precise mechanisms by which individual animals navigate the vertical journey, how they know when to go up and when to come down, how they orient themselves in absolute darkness, how they survive the enormous pressure changes involved in traveling hundreds of meters, vertically twice a day, remain active areas of research. The deep ocean keeps its secrets well. Fact 9. Bioluminescence is the most common form of communication on Earth. Imagine floating in the midnight zone of the deep ocean, 1,000 meters below the surface, in absolute darkness, surrounded by water so cold it is barely above freezing, under pressure that would crush your chest. You cannot see your hand in front of your face. No light has ever reached this place, and yet all around you the darkness is alive with light. Flashes of blue-green light, slow, pulsing glows, sudden bright bursts that illuminate strange shapes before fading back into the dark, trails of luminescence left by passing creatures, points of light moving through the blackness like living stars. This is bioluminescence, the biological production of light by living organisms, and it is one of the most widespread and extraordinary phenomena in the natural world. Approximately 76% of deep-sea creatures are capable of producing their own light, making bioluminescence the most common form of communication on Earth by number of species involved, even though most humans have never witnessed it in the deep-sea context where it is most prevalent. Bioluminescence is produced through a chemical reaction involving a light-emitting molecule called luciferin and an enzyme called luciferase. When luciferin is oxidized in the presence of luciferase, it releases energy in the form of light, a process that is extraordinarily efficient, producing almost no heat, unlike the burning of a flame. The specific chemistry varies between species. There are multiple independent evolutionary origins of bioluminescence across the tree of life, but the basic principle is the same. Deep-sea creatures use bioluminescence for an astonishing variety of purposes. The anglerfish, one of the most iconic deep-sea creatures, uses a bioluminescent lure dangling from a modified fin spine above its mouth to attract prey in the absolute darkness of the deep sea. The light draws curious fish and invertebrates toward the anglerfish's enormous, fang-filled mouth. Firefly squid in the waters of Japan use bioluminescent patterns to communicate with potential mates. Dinoflagellates, microscopic marine plankton, produce the eerie blue bioluminescent glow that sometimes illuminates breaking waves on beaches at night, each tiny organism flashing as it is disturbed by the water's movement. Some creatures use bioluminescence defensively, squirting clouds of luminescent fluid to confuse predators, or producing flashes of light to startle or temporarily blind an attacker. Others use counterillumination, producing light on their undersides to match the faint glow of sunlight filtering down from above, making themselves invisible to predators looking upward. The diversity of bioluminescent strategies in the deep sea reflects millions of years of evolutionary innovation in an environment where light, self-generated light, is both a weapon and a means of survival. Fact 10. The ocean is home to the largest animal that has ever lived. Think of the largest animal you can imagine. A dinosaur, perhaps one of the great sauropods, Brachiosaurus or Argentinosaurus, the titans of the Mesozoic, or perhaps a mammoth or a giant shark or one of the great whales. Whatever animal you are picturing, the answer to the question of the largest animal that has ever lived on Earth is almost certainly the same: the blue whale. The blue whale, Balænoptera musculus, is not just the largest animal alive today. It is the largest animal that has ever lived in the entire 4.5 billion year history of life on Earth. Larger than any dinosaur, larger than any prehistoric sea creature, larger than anything that has ever walked, swum, or flown on this planet. Adult blue whales can reach lengths of up to 33 meters, longer than 2 standard school buses placed end to end. They can weigh up to 190 tons, heavier than the largest known dinosaur by a substantial margin. A blue whale's heart is approximately the size of a small car, weighing up to 180 kilograms, and can be heard beating from 3 kilometers away. Its aorta, the main artery carrying blood away from the heart, is wide enough for a human child to crawl through. A blue whale's tongue weighs approximately 2.7 tons, as much as a large elephant. Blue whales feed almost exclusively on krill, tiny shrimp-like crustaceans only a few centimeters long. During feeding season in polar waters, a blue whale may consume up to 4 tons of krill per day, approximately 40 million individual krill, filtering them from enormous mouthfuls of water through the baleen plates in its jaw. The contrast between the immensity of the animal and the tininess of its prey is one of the ocean's great paradoxes. The largest creature that has ever lived sustains itself by eating some of the smallest. Blue whales also produce the loudest sounds of any animal on Earth. Their low-frequency calls, deep pulses and moans that travel at frequencies below the range of human hearing, can reach up to 188 decibels in intensity and can travel for distances of up to 1,600 kilometers through the ocean. In the pre-industrial ocean, before the introduction of engine noise from ships, blue whale calls may have traveled across entire ocean basins, a form of communication operating at a scale we can barely imagine. Blue whales were hunted almost to extinction during the 20th century, their population reduced from an estimated 250,000 to 350,000 individuals, before whaling to perhaps 10,000 to 25,000 today. They remain endangered, a reminder that even the largest creature on Earth is not immune to the destructive power of human technology. Fact 11. The ocean has its own weather system. The ocean is not passive. It is not simply a vast container of water that sits quietly beneath the atmosphere while weather happens above it. The ocean is an active, dynamic system, one that generates its own circulation patterns, drives much of the world's weather, and regulates the global climate in ways that make human civilization possible. The key mechanism is the thermohaline circulation, a global system of ocean currents driven by differences in the temperature, therma, and salinity, haline of seawater in different parts of the world. Cold water is denser than warm water. Salty water is denser than fresh water. In the North Atlantic, warm surface water carried northward by the Gulf Stream loses heat to the atmosphere and becomes saltier through evaporation, becoming so dense that it sinks to the ocean floor and flows southward as a deep, cold bottom current. This sinking drives a circulation pattern that draws more warm surface water northward to replace it, perpetuating a continuous global loop of ocean circulation. This global ocean conveyor belt, also called the Atlantic Meridional Overturning Circulation, AMOC, transports an enormous amount of heat from the tropics toward the poles, moderating the climates of Western Europe and the eastern coast of North America. Without the warmth transporting northward by the Gulf Stream, the climate of Northern Europe would be dramatically colder. London and Paris would have climates similar to those of Newfoundland or Alaska. The ocean's circulation is the reason Northern Europe is habitable in the way it is. The thermohaline circulation also operates on timescales of hundreds to thousands of years, so slowly that a drop of water entering the deep Atlantic circulation might not return to the surface for 1,000 years or more. The deep ocean therefore acts as a vast reservoir of heat and carbon, absorbing both from the atmosphere and storing them on geological timescales, playing a critical role in regulating Earth's long-term climate. Today, scientists are monitoring the thermohaline circulation with concern. Climate change is adding enormous quantities of freshwater to the North Atlantic, from the melting of the Greenland ice sheet and Arctic sea ice, diluting the salty surface water whose density drives the circulation. Studies published in the 2020s have found evidence that the AMOC has been weakening over the past several decades and may be approaching a tipping point, a threshold beyond which the circulation could slow dramatically or even collapse, with potentially catastrophic consequences for European and North American climates. The ocean's weather system, once thought stable on human timescales, may be more vulnerable than we imagined. Fact 12. The ocean floor is covered in sediment millions of years old. The ocean floor is not rock. Most of it is covered by a thick blanket of sediment, a mixture of clay minerals, the remains of dead organisms, particles of volcanic ash, and cosmic dust that has been accumulating on the seafloor for hundreds of millions of years. In some parts of the deep ocean, this sediment layer is up to 2 kilometers thick, a geological archive of extraordinary depth and richness, recording the history of Earth's climate, its ecosystems, and its chemical composition across timescales that dwarf all of human history. The sediment on the ocean floor accumulates with extraordinary slowness. In the deepest, most remote parts of the abyssal Pacific, the red clay that covers the seafloor accumulates at a rate of only about 1 millimeter per 1,000 years. A layer of sediment just 1 centimeter thick represents 10,000 years of geological time. This means that sediment cores drilled from the deep ocean floor can contain records of Earth's climate and environment going back tens of millions of years, records of past ice ages, past warm periods, past mass extinctions, and past changes in ocean chemistry that are preserved in astonishing detail. But the deep-sea sediment holds more than geological history. It also preserves biological history. The microscopic remains of the organisms that lived in the surface waters above sank to the bottom when they died and were incorporated into the sediment layer. The silica shells of diatoms and radiolarians, the calcium carbonate shells of foraminifera and coccolithophores. These tiny, intricate structures are preserved in the sediment for millions of years, providing a detailed record of the evolution and extinction of ocean life across geological time. And the sediment contains something else, something of profound practical importance. Certain areas of the deep ocean floor are covered with polymetallic nodules, potato-sized lumps of mineral-rich material that grow slowly around a nucleus, often a shark tooth or a piece of volcanic rock, at rates of a few millimeters per million years. These nodules are extraordinarily rich in manganese, nickel, cobalt, and copper, metals that are critical components of the batteries and electronic devices that power the modern world. The total quantity of polymetallic nodules on the ocean floor may contain more of these critical metals than all the known land-based deposits combined. The deep ocean floor is not just a geological archive. It may also be the largest untapped mineral deposit on Earth, and the question of whether and how to mine it is one of the most contentious issues in ocean policy today. Fact 13. The deep sea contains more historical shipwrecks than all the world's museums combined. Somewhere in the depths of the world's oceans, an extraordinary library of human history lies waiting. Ships from every era, every civilization. Every chapter of human seafaring, from ancient Phoenician trading vessels and Roman grain ships to Second World War battleships and modern container vessels, rest on the ocean floor in a state of preservation that, in the cold, dark, oxygen-poor environment of the deep sea, can be almost miraculous. The numbers are staggering. UNESCO estimates that there are approximately 3 million shipwrecks on the ocean floor worldwide, a number that almost certainly underestimates the true total, given how little of the seafloor has been systematically surveyed. These wrecks represent an archaeological resource of incalculable value, physical evidence of trade routes and technologies, of wars and disasters, of the goods and cultures that were exchanged across the seas for thousands of years. Some of the most significant shipwreck discoveries in history have completely rewritten our understanding of ancient seafaring and trade. The Uluburun shipwreck, discovered off the coast of Turkey in 1982 and dated to approximately 1300 BCE, carried a cargo of extraordinary diversity: copper and tin ingots from Cyprus and Afghanistan, ebony logs from Egypt, glass ingots of multiple colors, jars of terebinth resin, pomegranates, figs, spices, and luxury goods from cultures across the eastern Mediterranean. The ship itself was probably Canaanite, but its cargo represented the trading networks of at least 7 different ancient cultures. A single ship, sunk over 3,000 years ago, provides a snapshot of Bronze Age international trade of extraordinary richness. The Antikythera shipwreck, discovered near the Greek island of Antikythera in 1900 and dated to approximately 65 BCE, yielded what is arguably the most extraordinary artifact ever recovered from the sea, the Antikythera mechanism, a remarkably sophisticated bronze device with at least 30 interlocking gears that functioned as an astronomical calculator, tracking the positions of the sun and moon, predicting eclipses, and calculating the dates of the Panhellenic Games. Nothing of comparable mechanical sophistication was known to exist in the ancient world, and the Antikythera mechanism has fundamentally changed our understanding of ancient Greek technological capability. It was, in essence, the world's first known analog computer, and it was lying on the ocean floor for 2,000 years before we found it. The deep ocean is not just a graveyard for ships. It is the world's greatest archive of human history, and maritime archaeology, the science of studying this underwater heritage, is one of the most exciting and rapidly developing fields in all of archaeology. Fact 14. Some shipwrecks are preserved almost perfectly in the deep sea. The preservation of shipwrecks in the deep ocean is one of the most extraordinary phenomena in all of archaeology. On land, wooden structures rot within decades, metal rusts and corrodes, organic materials, rope, cloth, leather, food disappear within years. The archaeological record of the past is therefore always fragmentary, a collection of the most durable materials, stone, fired clay, metal, with everything else lost to time. The deep ocean is different. In the cold, dark, oxygen-poor waters of the abyssal zone, below 3,000 to 4,000 meters, the processes of biological decomposition that destroy organic materials on land operate with extreme slowness or not at all. The wood-boring organisms that devastate wooden shipwrecks in shallow water, particularly the infamous shipworm, Teredo navalis, cannot survive at abyssal depths. The bacteria that break down organic materials in shallow water are far less active in the cold, low-oxygen environment of the deep sea, and the cold itself slows all chemical reactions, including the corrosion of metal. The result is that deep-sea shipwrecks can be preserved in a state of almost miraculous completeness. The wreck of the RMS Titanic, resting at approximately 3,800 meters in the North Atlantic, was discovered in 1985 by Robert Ballard and has been extensively documented since. Despite sinking in 1912, the wreck still contains recognizable features: staircases, portholes, bath fixtures, personal belongings scattered across the seafloor, frozen in time at the moment of sinking, over a century ago. But it is much older wrecks that have produced the most historically significant preservation. In the Black Sea, whose deep waters, below about 150 meters, are anoxic, meaning they contain no oxygen, due to a lack of vertical water mixing, wooden shipwrecks have been found in extraordinary states of preservation. A 2017 expedition by the Black Sea Maritime Archaeology Project discovered a Greek merchant vessel, dating to approximately 400 BCE, resting at a depth of over 2,000 meters in near-perfect condition. Its mast still standing, its rudder in place, its hull intact. This 2,400-year-old ship is the oldest intact shipwreck ever found, preserved by the unique anoxic conditions of the Black Sea deep water in a state that no land-based archaeological site could match. Ropes, storage jars, and the remains of the ship's equipment were visible in extraordinary detail, a time capsule from the ancient Mediterranean world, perfectly sealed by the deep sea for over 2 millennia. Fact 15. The ocean has swallowed entire civilizations. The ships on the ocean floor are extraordinary, but they are in a sense just the beginning, because beneath the waves in the shallow coastal waters and continental shelves of the world's oceans lie the ruins not just of individual vessels but of entire landscapes, ancient coastlines, prehistoric settlements, submerged ports, and in some cases the remnants of entire civilizations that were swallowed by the sea as ocean levels rose at the end of the last ice age. The story begins approximately 20,000 years ago, at the height of the last glacial maximum, the peak of the most recent ice age, when enormous ice sheets covered much of North America, Europe, and Asia. So much of Earth's water was locked in these ice sheets that global sea levels were approximately 120 to 130 meters lower than today. The continental shelves of the world, the shallow underwater platforms that surround the continents, were largely dry land. Areas that are now underwater were then forest, grassland, coastal plain, and river valley, inhabited by the humans and animals of the Pleistocene. As the Ice Age ended and the great ice sheets melted, sea levels rose, not suddenly, but relentlessly, over thousands of years. The land that had been home to hunter-gatherer populations for tens of thousands of years was progressively inundated. Coastal settlements were abandoned as the sea advanced. Low-lying river valleys flooded. The shallow seas of today, the North Sea, the Persian Gulf, the Gulf of Thailand, the South China Sea, were once partly or entirely dry land, inhabited by ancient people whose settlements now lie beneath dozens or hundreds of meters of water. The scale of this inundation was staggering. More than 27 million square kilometers of previously dry land was submerged as sea levels rose to their current levels, an area roughly the size of Africa. All of that land was potentially inhabited. All of those coastal settlements, those river valleys, those hunting grounds, submerged, their archaeological record lost beneath the sea. The coastal archaeology of the Pleistocene and early Holocene is the most underexplored frontier in human prehistory, and what lies beneath the shallow coastal waters of the world may completely transform our understanding of early human history. Fact 16. Dwarka, the mythological city found beneath the sea. In Hindu mythology, Dwarka is one of the most sacred cities in the world. According to the ancient texts, including the Mahabharata and the Bhagavata Purana, Dwarka was the legendary kingdom of Krishna, the great city he built on the western coast of India, a city of extraordinary beauty and prosperity. And according to the same texts, when Krishna departed from the world, Dwarka was swallowed by the sea, consumed by the ocean in a single catastrophic event, disappearing beneath the waves forever. For centuries, this was understood as mythology, a beautiful story, not a historical account. Then in 2001, the National Institute of Ocean Technology, NIOT of India, was conducting pollution surveys in the Gulf of Kambat, also known as the Gulf of Cambay, off the northwestern coast of India when their sonar equipment detected something unexpected on the seafloor. At a depth of approximately 30 to 40 meters, they found what appeared to be geometric structures, regular shapes that natural geological formations do not produce, rectangular outlines, grid patterns, the suggestion of walls and streets. Subsequent dives and investigations recovered numerous artifacts from the site, including pottery, sculpture fragments, construction materials, and what appeared to be beads, hearth materials. And human bones. Carbon dating of some of the retrieved materials produced dates of approximately 7,500 to 9,500 years ago, making the site potentially one of the oldest urban settlements ever discovered, predating the earliest known cities of Mesopotamia by several thousand years. The Dwarka discovery remains deeply controversial. Some researchers believe the geometric structures are natural geological formations, formed by the erosion of ancient sediment beds into regular patterns. Others argue that the evidence for a human settlement is compelling, and that the site represents a genuine ancient city, submerged as sea levels rose in the Gulf of Kambat following the end of the last ice age. The controversy has not been resolved, partly because the site lies in waters with very poor visibility and strong currents that make detailed investigation extremely difficult. Whether or not the Gulf of Kambat site is the legendary Dwarka, it illustrates something important. The myths and legends of ancient coastal peoples, stories of cities and civilizations swallowed by the sea, may contain genuine historical memory of real events. The ocean rose, the land was swallowed, people remembered, and their memories became myths that survived thousands of years, waiting for the technology to confirm what the storytellers already knew. Fact 17. Pavloptri is the world's oldest known submerged city. While the Dwarka controversy continues, there is another submerged city whose existence is beyond dispute, and whose extraordinary preservation has made it one of the most important archaeological discoveries of recent decades. Pavloptri lies just off the southern coast of Laconia in Greece, in the shallow waters between the mainland and the island of Elafonizos. The water here is only 3 to 4 meters deep, shallow enough to swim to, close enough to shore to walk to at very low tide, and the ruins of the ancient city are spread across an area of approximately 8 hectares of seafloor. Stone walls, courtyards, streets, building foundations, and the remnants of what appear to be public spaces and cemeteries lie in the shallow water, in a state of preservation remarkable for a site that has been submerged for approximately 5,000 years. Pavloptri is believed to date primarily to the Bronze Age, approximately 3000 to 1100 BCE, making it contemporary with the great civilizations of ancient Greece, Egypt, and Mesopotamia. Pottery recovered from the site has been dated to as early as 2800 BCE, suggesting that the city was inhabited throughout the Bronze Age and possibly into the later periods of Greek history. The city's layout, with its streets and building plots preserved in extraordinary detail on the shallow seafloor, has provided archaeologists with a uniquely complete picture of a Bronze Age urban settlement, a level of preservation that no land-based site of comparable age can match. Story of how Pavloptri was submerged is not one of catastrophic flooding, but of gradual coastal subsidence. The slow sinking of the land as tectonic forces caused the region to settle over thousands of years, allowing the sea to creep progressively inland and eventually swallow the city. The inhabitants would not have experienced a sudden disaster, they would have watched over generations as the sea gradually advanced, eventually abandoning their homes as the water rose to make them uninhabitable. Pavloptry is being studied using cutting-edge underwater archaeological techniques, including multi-beam sonar mapping that has produced detailed three-dimensional models of the entire site, and underwater excavation by divers using suction tubes to carefully remove sediment and expose buried features. What the ongoing research is revealing is a complete, coherent ancient city, not just a scatter of ruins, but an intelligible urban landscape that has been preserved by its submersion in a way that no equivalent land site could have been. Fact 18. The Black Sea was once a freshwater lake. The Black Sea, the large inland sea bounded by Ukraine, Russia, Turkey, Bulgaria, and Romania, is today a saltwater sea connected to the Mediterranean through the narrow Bosphorus Strait. But approximately 8,000 years ago, it was something very different. A large, isolated freshwater lake, lying well below the level of the Mediterranean, separated from the salt water of the Aegean by the natural land barrier that is now the Bosphorus. Then, according to a hypothesis proposed in 1997 by marine geologists William Ryan and Walter Pittman of Columbia University, something catastrophic happened. The Mediterranean Sea, swollen by melting glacial ice, rose to a level at which it breached the Bosphorus barrier, and salt water began to pour through the narrow channel into the Black Sea basin below. Ryan and Pittman estimated that at its peak, the inflow may have been equivalent to 200 Niagara Falls, an enormous torrent of salt water cascading into the freshwater lake below, raising its level by as much as 15 centimeters per day and expanding its shoreline by up to 1.6 kilometers per day. If this Black Sea flood hypothesis is correct, the flooding of the Black Sea basin was one of the most dramatic geological events of the Holocene, and it may have had profound consequences for the human populations living on its shores. The Black Sea coastline was inhabited by Neolithic farming communities in the period before the proposed flood. If the flood was as sudden and catastrophic as Ryan and Pittman suggest, these populations would have been driven from their homes by a rapidly advancing sea, forced to migrate in large numbers into surrounding regions. Some researchers have proposed that the Black Sea flood may be the historical basis for the flood myths found in multiple ancient Near Eastern traditions, including the story of Noah's Ark in the Hebrew Bible, the Epic of Gilgamesh in the Sumerian tradition, and flood narratives in Greek, Hindu, and other mythological traditions. The universality of flood myths across cultures that border or descend from populations near the Black Sea region is striking. And while the connection between the Black Sea flood and ancient flood myths remains speculative and controversial, it is a hypothesis that continues to generate significant research and debate. The Black Sea's anoxic deep waters, which, as we discussed in Fact 14, preserve shipwrecks in extraordinary condition, may also preserve the flooded landscapes of the pre-flood shoreline. Surveys of the Black Sea floor have found evidence of ancient river valleys, shorelines, and possibly structures that date to the period before the proposed flooding, tantalizing hints of the human world that may have been swallowed by the advancing sea. Fact 19. Yonaguni, the mysterious underwater monument of Japan. In 1987, a diving instructor named Kihikaro Aratake was exploring the waters off the coast of Yonaguni Island, the westernmost island of Japan, lying in the East China Sea closer to Taiwan than to the Japanese mainland, when he discovered something that would ignite one of the most heated controversies in underwater archaeology. At a depth of approximately 5 to 15 meters, Aratake found what appeared to be the remains of a massive stone structure, a series of terraced platforms, right-angle cuts, straight edges, and geometric shapes carved or arranged in the solid rock of the seafloor. The largest feature, sometimes called the Yonaguni Monument, is approximately 50 meters long, 25 meters wide, and 15 meters tall, with what appear to be steps, ramps, platforms, and at least one feature that looks remarkably like a road or pathway. The discovery attracted immediate international attention and quickly divided the archaeological and geological community into two camps. On one side were those who argued that the Yonaguni Monument was entirely natural, the product of geological processes acting on the layered sandstone of the seafloor, which naturally tends to fracture along straight lines and right angles, producing features that can look deceptively artificial. On the other side were those who argued that the structures were man-made, carved by human hands, possibly as long as 8,000 to 10,000 years ago when the site was above water, before rising sea levels submerged it. The Japanese geologist Masaki Kimura of the University of the Ryukyus spent years studying the Yonaguni Monument and became its most prominent advocate. arguing that the structures bore the hallmarks of human construction, not just the geometric shapes, but what he interpreted as carved faces, animal figures, and writing-like marks on some of the surfaces. Others examined the same features and saw only the natural products of geological erosion and fracturing. The controversy remains unresolved to this day. What is clear is that the Yonaguni area was above water approximately 8,000 to 12,000 years ago. During the period of lower sea levels following the last ice age, whether the structures were created by a human civilization at that time, which would make them among the oldest known architectural works on Earth, or whether they are entirely natural formations that happen to look artificial, is a question that continues to fascinate researchers and explorers. Fact 20. The ocean tells us where ancient humans lived. Perhaps the most profound implication of everything we have discussed in this first section is this: the ocean has not just swallowed history. It has preserved it, in a way that the land, with its erosion and its agriculture and its building and rebuilding, cannot. The submerged continental shelves of the world are the best preserved archaeological landscapes on Earth, precisely because they have been underwater and therefore largely undisturbed for thousands of years. As sea levels rose at the end of the last ice age, they did not just cover the land. They covered the evidence, the campsites, the shell middens, the hearths, the stone tools, the burials of the people who lived on that land for tens of thousands of years. These people lived on the coasts, as humans have always preferentially done, because the coasts offered the richest and most reliable food resources: fish, shellfish, marine mammals, seabirds, and the diverse ecosystems of coastal wetlands and estuaries. The coastal populations of the Pleistocene were likely among the most numerous and technologically sophisticated of their time, and their entire archaeological record is now submerged. Modern maritime archaeology is only beginning to develop the tools and techniques needed to systematically survey and excavate these submerged landscapes. Remote-operated vehicles, ROVs, autonomous underwater vehicles, AUVs, and advanced sonar mapping technologies are making it increasingly possible to identify and study sites on the shallow continental shelves, sites that were beyond reach just a decade ago. What they are finding is transforming our understanding of human prehistory. In the North Sea, now a shallow sea between Britain and continental Europe that was dry land during the last ice age, researchers have recovered stone tools, animal bones, and other evidence of a rich Mesolithic landscape they call Doggerland, which was progressively flooded as sea levels rose between approximately 18,000 and 5,000 years ago. In the Persian Gulf, another shallow sea that was largely dry during the Ice Age, surveys have found evidence of ancient river systems and potentially habitation sites that were submerged as the Gulf filled with water approximately 6,000 to 8,000 years ago. The ocean is not the enemy of archaeology. Properly understood, properly explored, it is archaeology's greatest ally, a vast, cold, dark, perfectly preserving archive of the human past, waiting patiently beneath the waves for the tools and the will to reveal its secrets. 20 facts, and we have only just broken the surface. We have learned that the ocean is not just big, it is the defining feature of our planet, covering 71% of its surface and containing 97% of its water. We have descended through its 5 distinct zones, from the sunlit surface to the crushing darkness of the Hadal Trench. We have met the creatures that live in permanent darkness, making their own light in the abyss. We have stood at the rim of the Mariana Trench and looked down into the deepest place on Earth. And we have begun to understand that beneath the waves lies not just biology and geology, but history, the preserved remains of ships and cities and entire civilizations, swallowed by the rising sea at the end of the last ice age, waiting in the cold and dark for the technology and the curiosity to find them. This is only the beginning. In part 2, we go deeper. We meet the most extraordinary creatures in the ocean, the giants, the hunters, the bioluminescent wonders of the Midnight Zone. We explore more of the ocean's submerged archaeological treasures, and we begin to understand the forces that shape the ocean and the forces that are now threatening to reshape it beyond recognition. In part 1, we broke the surface. We descended through the 5 zones of the ocean, stood at the rim of the deepest place on Earth, and began to understand that beneath the waves lies not just biology and geology, but history. Entire cities and civilizations swallowed by the rising sea, preserved in the cold and dark for thousands of years. Now we go deeper. In part 2, we enter the realm of the ocean's most extraordinary creatures, the giants that patrol the open water, the hunters that have not changed in hundreds of millions of years, the bioluminescent wonders of the Midnight Zone that science is only beginning to understand. We explore more of the ocean's submerged archaeological treasures, ancient ports, flooded temples, the ruins of worlds that vanished beneath the waves while human memory was still young. And we confront some of the ocean's deepest mysteries, phenomena that science has documented but not yet fully explained, patterns in the deep sea that suggest the ocean is stranger and richer and more alive than we have ever imagined. Lie down, close your eyes, the ocean is waiting. Fact 21. The giant squid was a legend for centuries before science confirmed it. For as long as human beings have sailed the sea, they have told stories of monsters. Enormous creatures lurking in the deep, rising from the darkness to drag ships and sailors beneath the waves. The Kraken of Norse mythology, a beast so vast that sailors sometimes mistook it for an island and made camp on its back, was described in medieval texts as capable of creating whirlpools large enough to swallow entire fleets. For centuries, these stories were dismissed as the fantasies of frightened sailors, the inevitable mythology of people who spent their lives on a vast and terrifying ocean they could not fully understand. Then science caught up with the legend, and what it found was, in its own way, even stranger than the myth. The giant squid Architeuthis dux is real. It is the largest invertebrate on Earth, a creature of the deep ocean that can grow to lengths of up to 13 meters for females, with eyes up to 30 centimeters in diameter, the largest eyes of any living animal, designed to gather every available photon of light in the permanent darkness of the deep sea. Its arms are lined with suckers ringed with sharp, tooth-like serrations that can grip prey with extraordinary force. Its beak, the hard, parrot-like mouthpart hidden at the center of its arms, is capable of cutting through flesh and bone with surgical precision. For most of the history of science, the giant squid was known only from fragmentary evidence, pieces of arms and tentacles found in the stomachs of sperm whales, chunks of skin and tissue occasionally washed ashore on beaches, and complete but dead specimens found floating at the surface. Living giant squid in their natural deep-sea habitat had never been observed or filmed. The creature remained, despite its enormous size, essentially invisible to science. That changed in 2004, when Japanese researchers Tsunemi Kubodra and Kaiichi Mori deployed a baited camera array in the deep Pacific near the Ogasawara Islands and captured the first-ever photographs of a living giant squid in its natural habitat, at a depth of approximately 900 meters. The images showed a creature actively attacking the bait, its arms wrapped around it, its enormous body visible in the flash of the camera. It was one of the most significant wildlife photography achievements in history. Then in 2012, a team including Kubodra and NHK filmmaker Hiroki Abe deployed a specially designed low-light camera system and captured the first-ever video footage of a living giant squid in the deep ocean, a luminous, silver-white creature of extraordinary beauty, gliding through the absolute darkness of the deep Pacific at a depth of approximately 630 meters. The footage, broadcast around the world, revealed a creature very different from the aggressive monster of legend, graceful, almost ethereal, moving through its deep-sea world with a fluid, unhurried elegance that the word monster cannot capture. The giant squid is a reminder that the deep ocean still holds creatures of extraordinary size and strangeness that science is only beginning to observe. If a 13-meter invertebrate could remain essentially invisible to science until the 21st century, what else might be down there? Fact 22. Sperm whales dive deeper than almost any other air-breathing animal. The sperm whale, Physta macrocephalus, is one of the most extraordinary animals on Earth. The largest toothed predator that has ever lived, males can reach lengths of 18 to 20 meters and weights of up to 57 tons. Its head is enormous and distinctive, a massive, squared-off structure that occupies up to 1/3 of its total body length and houses the spermaceti organ, a structure filled with a waxy substance that may function in echolocation and buoyancy control, and which was the primary target of the whaling industry that nearly drove the species to extinction. But what makes the sperm whale most extraordinary, from a biological perspective, is its capacity for deep diving. Sperm whales routinely dive to depths of 1,000 to 2,000 meters in search of their primary prey, squid, including the giant squid, and have been recorded at depths of over 3,000 meters. They can remain submerged for up to 90 minutes on a single breath, holding more oxygen in their blood and muscles, which are extraordinarily rich in oxygen-binding myoglobin, giving sperm whale muscle its characteristic dark red-black color than almost any other diving animal. The physics of a sperm whale's dive are extraordinary. As it descends, the pressure of the water compresses its lungs, which are designed to collapse entirely at depth, allowing the whale to avoid the nitrogen narcosis and decompression sickness that would kill a human diver under the same conditions. Its ribcage is flexible, allowing this compression to occur without injury. Its blood circulation shunts oxygen away from non-essential organs and to the brain and heart, extending the period of useful submersion. Its heart rate slows dramatically, a form of physiological diving reflex that conserves oxygen. Every aspect of the sperm whale's biology is an extraordinary adaptation to a life spent hunting in the crushing darkness of the deep. The evidence of the sperm whale's encounters with giant squid is written on its skin, circular scars left by the toothed suckers of giant squid arms, sometimes covering large areas of the whale's body. These scars tell a story of epic struggles in the darkness, hundreds of meters below the surface, between the ocean's largest predator and its largest prey, battles that no human has ever witnessed and that we may never be able to directly observe. The deep ocean is not just a place of stillness and silence. It is a place of conflict on a scale we can barely imagine. Fact 23. The colossal squid is even larger than the giant squid. If the giant squid is remarkable, its relative, the colossal squid, Mesonychoteuthis hamiltoni, is something else entirely. While the giant squid is longer, the colossal squid is more massive, the largest invertebrate on Earth by weight, estimated to reach weights of up to 750 kilograms and mantle lengths, body length excluding tentacles, of up to 4 meters. Its tentacles are equipped not just with toothed suckers, but with rotating hooks, sharp, swiveling claws that can grip prey with a mechanical force that the suckers of the giant squid cannot match. The colossal squid lives in the deep waters of the Southern Ocean around Antarctica, one of the most remote and least explored regions of the deep sea, and is known primarily from specimens recovered from the stomachs of sperm whales and from the occasional complete specimen accidentally caught in fishing nets. A complete adult specimen was captured by New Zealand fishermen in 2007 and is now preserved at the Museum of New Zealand Te Papa Tongawa in Wellington. It remains the largest colossal squid specimen ever recovered and has been the subject of extensive scientific study. What the study of this specimen revealed was extraordinary. The colossal squid's eyes, examined after preservation, were found to be approximately 27 centimeters in diameter, with a lens approximately 12 centimeters across. These are the largest eyes of any animal ever recorded, biological light-gathering instruments of extraordinary sensitivity, designed for hunting in the near-complete darkness of the deep Southern Ocean. And the colossal squid's eyes have a feature that the giant squids do not, a light-emitting photophore on the eye itself, which may function as a headlight, illuminating the area in front of the squid as it hunts in the darkness. The colossal squid, like the giant squid, remained essentially unknown to science until the 20th century, and is still so poorly understood that basic aspects of its biology, including its lifespan, reproductive behavior, and population size, are completely unknown. It is in every sense a creature of mystery, a massive predator of the deep Southern Ocean that has been glimpsed only in fragments, whose full story has never been told. Fact 24. The Greenland shark is the longest-lived vertebrate on Earth. In the cold, dark waters of the North Atlantic and Arctic Ocean, moving with almost imperceptible slowness through the permanent twilight of the deep, lives an animal of extraordinary antiquity. The Greenland shark, Somniosus microcephalus, is the longest-lived vertebrate on Earth. Not the longest-lived animal, that distinction belongs to certain invertebrates, including the ocean quahog clam, which can live over 500 years, but the longest-lived animal with a backbone, the longest-lived fish, and one of the most ancient individual animals ever documented. Greenland sharks can live to ages of at least 272 years, and possibly much longer. The oldest individual ever dated, using radiocarbon dating of proteins in the eye lens, which forms in the embryo and does not change throughout life, preserving a chemical record of the time of birth, was estimated to be approximately 392 years old, born around 1627, during the reign of Charles I of England, before Newton had formulated his laws of motion, before the telescope had been turned to the heavens. This individual shark had been alive for nearly 4 centuries, swimming the cold, dark waters of the North Atlantic through the entire period of modern history. The Greenland shark's extraordinary longevity is connected to its extraordinary slowness. It is one of the slowest fish in the ocean, with an average swimming speed of approximately 1.2 kilometers per hour, barely faster than a slow human walk. Its metabolism is correspondingly slow, so slow that it grows only about 1 centimeter per year and does not reach sexual maturity until approximately 150 years of age. The Greenland shark is, in every biological dimension, a creature operating in slow motion, living long not by any particular resistance to agging, but by doing almost everything at a pace so leisurely that time itself seems to move differently around it. The flesh of the Greenland shark is toxic when fresh, containing high concentrations of trimethylamine oxide, a compound that the shark uses to maintain osmotic balance in the cold water, but that produces effects similar to severe alcohol poisoning in humans. In Iceland and Greenland, a traditional food called hakal is made from Greenland shark flesh that has been buried and fermented for several months, then dried to break down the toxins, producing a product with an extraordinarily pungent ammonia smell that is considered an acquired taste even by Icelanders. Fact 25. Whale falls create entire ecosystems on the ocean floor. When a whale dies in the open ocean and sinks to the seafloor, it does not simply disappear. It becomes, in death, one of the most extraordinary events in the ecology of the deep sea, a sudden, enormous gift of organic matter to an environment where food is scarce and life hangs by the slenderest of threads. A whale fall, the sunken carcass of a whale resting on the deep ocean floor, passes through a series of ecological stages that can last for decades to over a century, each stage dominated by different communities of organisms, each extracting every possible calorie from the enormous body. The first stage, the mobile scavenger stage, begins immediately after the carcass settles. Sleeper sharks, hagfish, crabs, and a variety of fish begin to consume the soft tissue of the whale at extraordinary rates. A large whale carcass, the body of a blue whale for example, might weigh 100 tons or more, can be consumed down to the skeleton by mobile scavengers within a few months to a few years, the rate depending on depth and the abundance of scavengers in the area. The second stage, the enrichment opportunist stage, sees the exposed bones and surrounding sediment colonized by dense mats of bacteria and by a variety of mobile invertebrates, polychaete worms, crustaceans, and others that take advantage of the nutrient-rich environment created by the decomposing carcass. The third and most extraordinary stage, the sulfophilic stage, can last for decades. The lipid-rich bones of the whale are colonized by anaerobic bacteria that break down the whale oil using sulfate from the surrounding seawater, producing hydrogen sulfide as a byproduct. This hydrogen sulfide, in turn, supports communities of chemosynthetic bacteria, the same type that live around hydrothermal vents, which form the base of a food web of remarkable diversity and richness. Mussels, tube worms, clams, crabs, and dozens of other species colonize the whale skeleton, feeding directly or indirectly on the chemosynthetic bacteria. Some of the species found at whale falls are found nowhere else. They are specialists of this extraordinary, ephemeral ecosystem, spending their entire lives on the slowly decomposing skeleton of a dead whale. A single large whale fall can support hundreds of species and continue producing energy for the deep-sea ecosystem for a century or more. In the food-poor environment of the abyssal plain, a whale fall is not just an ecological event. It is a feast that lasts generations, sustaining communities of life in one of the most extreme environments on Earth long after the last scavenger has picked the bones clean. Fact 26. The anglerfish has one of the strangest reproductive strategies in nature. No creature in the deep ocean is more iconic, more recognizable, or more genuinely strange than the anglerfish. The bioluminescent lure dangling from the modified fin's spine above its enormous, fang-filled mouth, the fishing rod of the deep sea, is one of the most distinctive adaptations in the animal kingdom, a biological solution to the challenge of attracting prey in the absolute darkness of the bathypelagic zone that is simultaneously elegant and deeply unsettling. But the anglerfish's most remarkable characteristic is not its lure. It is the extraordinary, almost unbelievable nature of its reproductive biology, a strategy so strange that when it was first described by scientists, it was initially dismissed as an error. Most deep-sea anglerfish species show extreme sexual dimorphism, a difference in size and form between males and females so extreme that the two sexes look like completely different animals. The large, fearsome anglerfish of popular imagination, the one with the lure and the enormous mouth, is always female. She can reach lengths of up to 1 meter in some species, with a mouth large enough to swallow prey twice her own size. The male anglerfish is a completely different animal. Tiny, typically just 6 to 10 millimeters long, and lacking a lure entirely, the male is essentially a swimming reproductive organ, whose entire biological purpose is to find a female and mate. His nostrils are extraordinarily developed for detecting the chemical signals released by females in the darkness. His eyes are large and sensitive, capable of detecting the faint bioluminescence of the female's lure. When a male finds a female, he bites into her skin and does not let go. Over the following weeks, his body begins to physically fuse with hers. His circulatory system connects to hers. His organs, except his testes, begin to atrophy and disappear. His eyes degenerate. His immune system is suppressed by the female's body, preventing the rejection that would normally occur when foreign tissue is introduced. Eventually, the male becomes entirely integrated into the female's body, a pair of sperm-producing organs, permanently attached, supplied with nutrients through the female's bloodstream, ready to fertilize her eggs whenever she produces them. A single female anglerfish may carry multiple males fused to her body simultaneously. She carries her mates with her everywhere she goes, through the eternal darkness of the deep, a biological solution to the problem of finding a reproductive partner in an environment where encounters between individuals may be vanishingly rare. Fact 27. The mantis shrimp has the most complex eyes in the animal kingdom. In the shallow tropical waters of the Indo-Pacific, living in burrows in the seafloor of coral reefs and sandy shallows, dwells an animal that appears modest in size, typically 5 to 18 centimeters long, but possesses biological capabilities so extraordinary that they have made it one of the most studied animals in biology. The mantis shrimp, not a true shrimp, but a member of the order Stomatopoda, has eyes that are, without question, the most complex visual organs in the animal kingdom, and possibly the most complex in the history of life on Earth. Where human eyes have 3 types of photoreceptors, allowing us to distinguish approximately 10 million colors, and where the most color-sensitive vertebrates have 4 or 5 types, the mantis shrimp has 16 types of photoreceptors, allowing it to perceive colors across a spectrum that extends well into the ultraviolet and infrared, far beyond the range of any human visual experience. But the mantis shrimp's vision is extraordinary not just in its color range. Its eyes are mounted on independent stalks that can move in 3 directions simultaneously, giving the animal a complete 360-degree field of vision with no blind spots. Each eye independently estimates depth and distance, meaning the mantis shrimp does not need to use both eyes together for depth perception, as most animals do. And the eyes process visual information in a way completely different from vertebrate vision. Rather than sending raw visual data to the brain for processing, the mantis shrimp's eyes perform much of the color analysis locally, sending pre-processed information to the brain. The result is a visual system of extraordinary speed and efficiency, perfectly suited to the split-second timing required by the animal's primary hunting strategy. That strategy, the mantis shrimp's strike, is one of the fastest and most powerful movements in the animal kingdom. Mantis shrimps are divided into 2 groups based on their hunting technique: spearers, which use sharp appendages to impale soft-bodied prey like fish and shrimps, and smashers, which use club-like appendages to bludgeon hard-shelled prey like crabs and snails. The smashing strike of a mantis shrimp can accelerate at up to 10,400 G, faster than a bullet leaving a gun, delivering a force equivalent to that of a .22 caliber bullet from a weapon that fits in the palm of your hand. The strike is so fast that it creates a cavitation bubble, a region of near vacuum in the water, that collapses with an additional shockwave capable of stunning or killing prey, even if the physical strike misses. Mantis shrimps routinely break through the shells of crabs, snails, and clams with single strikes, and have been known to shatter aquarium glass. Fact 28. The ocean has its own waterfalls. When we think of waterfalls, we picture cascades of fresh water plunging over rock faces in mountain landscapes, Niagara, Victoria, Angel Falls. We do not typically picture the ocean, and yet the ocean contains some of the largest waterfalls on Earth, flows of water so enormous that the world's greatest surface waterfalls are tiny by comparison. The largest waterfall on Earth is not Niagara Falls, which carries approximately 2,400 cubic meters of water per second. It is not Victoria Falls, the widest waterfall in the world. It is not even Angel Falls, the tallest. The largest waterfall on Earth is the Denmark Strait Cataract, an underwater waterfall between Greenland and Iceland, where cold, dense Arctic water plunges over a submarine ridge and cascades down the ocean floor into the warmer, less dense water of the Irminga Sea below. The Denmark Strait Cataract carries approximately 3.7 million cubic meters of water per second, more than 1,500 times the flow of Niagara Falls, over a vertical drop of approximately 3,500 meters. It is, by any measure, the most powerful waterfall on Earth, and it is entirely invisible from the surface, hidden in the darkness of the deep North Atlantic, known only from the measurements of oceanographic instruments. What drives the Denmark Strait Cataract is the same process that drives the thermohaline circulation discussed in Part 1, the difference in density between cold Arctic water and warmer Atlantic water. When these 2 water masses meet at the submarine ridge of the Denmark Strait, the denser cold water is pulled downward by gravity, spilling over the ridge and cascading down the steep slope of the ocean floor in a continuous, invisible torrent. The cataract plays an important role in the circulation of the North Atlantic and in the exchange of water between the Arctic and Atlantic Oceans, a geological process of enormous importance for global climate, happening in absolute darkness, on a scale that dwarfs all the waterfalls of the visible world. Fact 29. The Mediterranean Sea was once a desert. Here is one of the most extraordinary geological events in the history of the ocean, a story of a sea that dried up completely, leaving behind a vast, bone-dry desert, and then filled again in what may have been the most catastrophic flood in the history of Earth. Approximately 5.96 million years ago, in an event called the Messinian Salinity Crisis. The Mediterranean Sea was cut off from the Atlantic Ocean by tectonic movements that closed the shallow marine connections between the two. Without the continuous inflow of Atlantic water to replace evaporation losses, the Mediterranean, an almost entirely enclosed sea surrounded by warm, arid land, began to evaporate. Over thousands of years, the sea level fell. Shallow areas became mudflats, then desert. Deeper areas persisted for longer, becoming increasingly salty as the water evaporated and the salt concentrated. Eventually, after approximately 640,000 years of gradual desiccation, much of the Mediterranean basin had dried up almost entirely, leaving behind a landscape of salt plains and evaporite deposits that geologists can still identify in the rock record today. The deepest parts of the Mediterranean basin became one of the lowest and most extreme environments on Earth, a scorching desert up to 5 kilometers below sea level, hotter than Death Valley, scoured by winds that descended from the surrounding plateau into the deep basin. Rivers that had previously flowed into the Mediterranean now carved enormous canyons as they plunged toward the evaporated basin. The Nile River cut a canyon over 3 kilometers deep through the Rock of Egypt during this period, a canyon now buried under the Nile Delta sediment. Then, approximately 5.33 million years ago, the Atlantic broke through. In an event called the Zanclean Flood, seawater from the Atlantic poured through the developing Strait of Gibraltar and began to refill the dry Mediterranean basin. The initial trickle became a torrent, and the torrent became, by some estimates, the most catastrophic flood in Earth's history, with water roaring through the Gibraltar Gateway at speeds of up to 90 kilometers per hour, carving an enormous channel in the rock as it poured into the empty basin below. The refilling of the Mediterranean may have taken anywhere from a few hundred years to a few tens of thousands of years, an eye blink in geological time. The Zanclean flood was not witnessed by humans. It occurred nearly 5 million years before our species existed, but the geological evidence of this extraordinary event is preserved in the rock record of the Mediterranean region, and the story it tells is one of the most dramatic episodes in the history of the ocean. Fact 30: Alexandria, the lost city beneath the sea. In the summer of 1994, French marine archaeologist Frank Goddio began an underwater survey in Abu Qir Bay, just off the coast of Alexandria in Egypt, using advanced sonar and magnetometer equipment to map the seafloor of the shallow bay. What he found would rewrite the history of one of the ancient world's greatest cities. Beneath 6 to 8 meters of water, spread across several kilometers of seafloor, lay the ruins of the ancient royal quarters of Alexandria, the palaces, temples, harbors, and streets of the great city, founded by Alexander the Great in 331 BCE and ruled for centuries by the Ptolemaic dynasty, the last of whom was Cleopatra VII. The ruins included the foundations of palaces, statues of the pharaohs and gods, sphinxes, columns, and the remains of the Timonium, the retreat built by Mark Antony on the edge of the harbor after his military defeat at the Battle of Actium. The ancient royal quarter of Alexandria had been submerged not by rising sea levels, but by a series of earthquakes and tsunamis between the 4th and 8th centuries CE that caused the land on which the ancient city stood to sink into the sea. The gradual subsidence, punctuated by sudden seismic events, lowered the level of the coastline by several meters over the course of centuries, progressively inundating the ancient city until the harbor, the palaces, and the public spaces of Ptolemaic Alexandria lay beneath the waves of the Mediterranean. What Goddio and his team discovered was extraordinary. Among the most significant finds was a colossal statue of a Ptolemaic king or queen, approximately 5 meters tall, lying on the seafloor in several pieces, and a red granite sphinx bearing the face of a Ptolemaic ruler. Thousands of smaller artifacts, ceramics, coins, jewelry, statuary, architectural elements were documented and some were recovered. And the ruins themselves, mapped in detail using Goddio's sonar surveys, revealed the layout of the ancient royal quarter with a clarity that the surviving above-water remains of Alexandria, built over and replaced by later constructions over 2,000 years, cannot match. The submerged ruins of ancient Alexandria represent one of the greatest underwater archaeological sites in the world, a direct window into the world of the Ptolemaic kings, of Cleopatra, of the greatest city of the ancient Mediterranean, preserved beneath a few meters of warm Egyptian water. Fact 31: the legendary lighthouse of Alexandria may lie beneath the sea. Among the ruins documented by Frank Goddio and other researchers in the waters of Abu Qir Bay and the eastern harbor of Alexandria lies what may be the most tantalizing archaeological mystery in all of underwater archaeology: the possible remains of one of the 7 wonders of the ancient world. The Lighthouse of Alexandria, the Pharos, was built on the island of Pharos at the entrance to Alexandria's harbour, probably during the reign of Ptolemy II Philadelphus in the 3rd century BCE. Standing at an estimated height of between 100 and 140 meters, it was one of the tallest structures in the ancient world, and its light, produced by a fire reflected and amplified by mirrors of polished bronze, was said to be visible from 50 kilometers out at sea. It functioned as a working lighthouse for over 1,000 years, getting ships into one of the busiest harbors in the ancient Mediterranean. The Pharos was damaged by earthquakes in 956 CE, 1303 CE, and 1323 CE, the last of which reduced it to ruins. The final remnants of the structure were incorporated into the citadel of Cape Bay, an Ottoman fortress built on the site in 1480 CE using the lighthouse's stone as building material. For centuries, it was assumed that the Pharos was completely destroyed, its remains incorporated into later structures, or simply lost. Then in the 1990s, underwater surveys in the waters just off the citadel of Cape Bay revealed hundreds of large stone blocks on the seafloor of the eastern harbour, blocks of granite and limestone, many of them enormous, some bearing carved decorations including sphinxes and obelisks. Some researchers believe these blocks are the collapsed remains of the Pharos itself, fallen into the harbour when the lighthouse was destroyed by the medieval earthquakes. Others argue that the blocks represent the ruins of other ancient structures that once stood on or near the island of Pharos. The question of whether the ruins of the world's most famous ancient lighthouse lie on the seafloor of Alexandria's harbour remains one of the most exciting unresolved questions in underwater archaeology. If the Pharos ruins are indeed there, and the evidence is suggestive if not conclusive, they represent an archaeological treasure of extraordinary significance, a physical remnant of one of the ancient world's greatest engineering achievements, waiting beneath a few meters of water to tell its full story. Fact 32. Port Royal, the sunken city of pirates. On the morning of June 7, 1692, the city of Port Royal in Jamaica, then the wealthiest and most important trading port in the Caribbean, and reputedly the most sinful city on earth, was destroyed in one of the most dramatic natural disasters of the 17th century. A massive earthquake, striking without warning on a hot Tuesday morning, liquefied the waterlogged sand on which much of the city was built, causing entire city blocks to slide into the sea. Within 2 minutes, approximately 2/3 of the city had disappeared beneath the waters of Kingston Harbour. Approximately 2,000 people died immediately, drowned, buried under collapsed buildings, or swallowed by the liquefied ground. Another 3,000 died in the following days from injuries and disease. An entire city, at the height of its power and prosperity, had been swallowed by the sea in the time it takes to read this paragraph. Port Royal in 1692 was an extraordinary place. Founded by the English in the 1650s, it had grown within decades into one of the most important ports in the Western Hemisphere, a centre of sugar trade, privateering, and piracy that handled more goods than any other city in the Americas. The privateers and pirates who used Port Royal as their base, including the legendary Henry Morgan, who served as Lieutenant Governor of Jamaica, had made the city famous and notorious throughout the Atlantic world. Contemporary accounts describe Port Royal as a city of extraordinary wealth and extraordinary vice, with one tavern or brothel for every 10 residents, streets lined with merchants and pirates and slavers, and a harbour always crowded with ships from half the world. When Port Royal sank, it sank largely intact. Buildings, streets, harbour fortifications, and the accumulated goods and possessions of thousands of people all preserved beneath the warm, shallow water of Kingston Harbour. Today, the ruins of Port Royal lie at depths of between 1 and 12 metres, shallow enough for recreational diving, deep enough to have been largely undisturbed since 1692. Archaeological excavations, particularly those led by Donnie Hamilton of Texas A&M University beginning in the 1980s, have revealed an extraordinary cross-section of 17th century life. Pewter plates still set on tables, bottles of wine still sealed, a watch that stopped at 11:43 a.m. on the morning of the earthquake, frozen at the exact moment of the disaster. Port Royal is one of the most significant underwater archaeological sites in the Americas, a city frozen in time at a precise historical moment, preserving a snapshot of 17th century Caribbean life of unparalleled completeness. Fact 33. The ocean produces its own sound landscape. The ocean is not silent. It has never been silent. Long before human beings began filling it with the noise of engines and sonar and propellers, the ocean was alive with sound, an extraordinary acoustic landscape produced by the calls and clicks of whales and dolphins, the snapping of shrimp, the grunting of fish, the crackling of ice, the roar of submarine earthquakes, and the deep, resonant hum of the ocean itself. Sound travels through water approximately 4 to 5 times faster than it travels through air, approximately 1,500 meters per second in seawater, compared to 343 meters per second in air. Water is in many ways an ideal medium for the transmission of sound. It transmits acoustic energy over vast distances with relatively little loss, allowing the calls of marine animals to travel hundreds or even thousands of kilometers through the ocean. In the deep ocean, there exists a remarkable acoustic phenomenon called the SOFAR channel, the sound fixing and ranging channel, a horizontal layer of water at a depth of approximately 600 to 1,200 meters, where the speed of sound reaches a minimum due to the combined effects of temperature and pressure. Sound waves that enter the SOFAR channel tend to be refracted back toward it rather than escaping upward or downward, effectively trapping sound energy in the channel and allowing it to travel enormous distances with minimal loss. Sounds introduced into the SOFAR channel, including the low-frequency calls of great whales, can, under the right conditions, travel completely across ocean basins. It was the SOFAR channel that made possible one of the most poignant and puzzling mysteries of the underwater acoustic world, the 52 Hz whale. Since 1989, researchers monitoring hydrophone arrays in the North Pacific have detected the calls of a whale that vocalizes at approximately 52 Hz, significantly higher than the 1525 Hz frequencies typical of blue whales and the 20 Hz frequencies of fin whales. The call pattern is distinctive and has been detected consistently for decades, apparently produced by a single individual traveling across the Pacific on migration, routes broadly similar to those of blue or fin whales, but calling at a frequency that no other whale of any species is known to produce. The identity of the 52 Hz whale, nicknamed the loneliest whale in the world, on the assumption that no other whale of its kind exists to hear its calls, remains unknown. It may be a blue whale hybrid, or an individual with a rare anatomical abnormality, or possibly even a member of an unknown species. Whatever it is, the story of the 52 Hz whale captures something profound about the ocean's acoustic world, a world in which beings of extraordinary size and intelligence communicate through the darkness across distances we can barely imagine, in a language we are only beginning to learn to hear. Fact 34: the Titanic wreck is being devoured by bacteria. On the night of April 14 to 15, 1912, the RMS Titanic, the largest and most luxurious ocean liner of its era, on its maiden voyage from Southampton to New York, struck an iceberg in the North Atlantic and sank, taking 1,517 lives in one of the deadliest peacetime maritime disasters in history. The wreck settled at a depth of approximately 3,800 meters on the floor of the North Atlantic, where it lay undiscovered for 73 years, until oceanographer Robert Ballard found it in September 1985. When Ballard's remotely operated vehicles first illuminated the Titanic's bow section in 1985, the images that came back were haunting in their detail: a grand staircase, a crow's nest, portholes still intact, deck equipment frozen in position at the moment of sinking. In the cold, dark, low-oxygen environment of the deep North Atlantic, the wreck had been extraordinarily well preserved for over 7 decades. But since 1985, the wreck has been deteriorating, and at an accelerating rate. Multiple expeditions over the decades have documented the progressive collapse of structures that were intact in 1985, the disappearance of features documented in earlier surveys, and the spreading of enormous rust formations called rusticles across the iron hull. The rusticles are not merely corrosion, they are bacterial colonies, formed by iron-oxidizing bacteria that consume the metal of the ship's hull as an energy source, converting iron into iron oxide and releasing it back into the seawater. The primary bacterium responsible for consuming the Titanic's hull, discovered in 2010 and named Halomonas titaniki in honor of its unusual host, is particularly efficient at metabolizing iron, and the rate of hull consumption has been estimated at several hundred kilograms per day across the entire wreck. At this rate, structural engineers and marine archaeologists estimate that the Titanic will have largely collapsed within the next 20 to 50 years. The bow and stern sections will flatten, the remaining standing structures will fall, and the iconic silhouette of the ship will dissolve into a spreading field of iron oxide on the deep ocean floor. The Titanic's destruction is not a tragedy, it is ecology. The bacteria consuming the wreck are performing exactly the function they evolved to perform, breaking down iron compounds and recycling their elements back into the ocean. What is extraordinary is that they are doing it to one of the most famous ships in history, in one of the most documented acts of biological decomposition ever observed. Fact 35. The ocean floor contains frozen methane that could change the climate. Beneath the sediments of the continental shelves and slopes of the world's oceans, locked in a form of ice that exists only under conditions of high pressure and low temperature, lies one of the most significant and potentially most dangerous stores of carbon on Earth. Methane hydrates, also called clathrates, are ice-like crystalline structures in which molecules of methane gas are trapped within a lattice of water molecules. They form in the sediments of the deep ocean floor under conditions of high pressure and low temperature, and they are extraordinarily widespread, estimated to contain somewhere between 500 and 10,000 gigatons of carbon, more than all known reserves of conventional fossil fuels combined. Methane hydrates are stable under current deep-sea conditions, but they are sensitive to changes in temperature and pressure. If the ocean warms or if the pressure decreases, as might happen if sea levels fall, the hydrates can destabilize, releasing their methane into the ocean water and ultimately into the atmosphere. Methane is a potent greenhouse gas, approximately 80 times more effective than carbon dioxide at trapping heat over a 20-year period, and a large-scale release of methane from destabilizing ocean floor hydrates could trigger a rapid and dramatic acceleration of global warming. This scenario, sometimes called the clathrate gun hypothesis, has been proposed as a possible mechanism for some of the most dramatic and rapid climate warming events in Earth's geological past. The Paleocene-Eocene thermal maximum, PETM, approximately 56 million years ago, saw global temperatures rise by 5 to 8 degrees Celsius within approximately 20,000 years, extraordinarily fast by geological standards, and some researchers have proposed that the destabilization of ocean floor methane hydrates contributed to this warming event. Whether and how rapidly methane hydrates might destabilize in response to current ocean warming is one of the most actively researched and most consequential questions in oceanography. The ocean floor contains a vast, frozen store of greenhouse gas, and the conditions under which it is stored are sensitive to exactly the kind of warming that human industrial activity is currently driving. The deep ocean is not just a passive observer of climate change, it may be one of its most significant potential amplifiers. Fact 36. Heraklion, the sunken Egyptian city of the gods. Before Alexandria was built, before the Ptolemaic dynasty rose to power, before Greece and Egypt forged the extraordinary cultural synthesis that produced one of the ancient world's greatest civilizations, there was another great city at the mouth of the Nile. Its name was Thonis Heraklion, known as Thonis to the Egyptians and Heraklion to the Greeks, and it was for centuries the most important port city in Egypt, the gateway through which all trade between the Mediterranean world and the Egyptian heartland had to pass. Ancient texts spoke of Thonis Heraklion, the city where, according to legend, Helen of Troy and Paris had stopped on their voyage to Troy, the city where the Greek hero Heracles was said to have performed one of his labors, the city that guarded the main mouth of the Nile and collected taxes from every ship that passed. But for centuries, the city could not be found. No ruins had been identified on land, no inscriptions located it with certainty. Some historians began to wonder whether it had ever truly existed, or whether it was simply a legend. Then in 2000, Frank Goddio, the same marine archaeologist who had mapped the submerged royal quarter of Alexandria, was conducting underwater surveys in Aboukia Bay, approximately 30 kilometers northeast of Alexandria, when his instruments detected anomalies on the seafloor. When divers investigated, they found the ruins of an ancient city spread across several square kilometers of seafloor, lying beneath 4 to 9 meters of water. The city was Thonis Heraklion. A steel and inscribed stone slab recovered from the site bore the city's name in both Egyptian and Greek, confirming its identity beyond any doubt. And what the subsequent years of excavation have revealed is extraordinary. The ruins of enormous temples dedicated to the Egyptian gods Amun-Jereb and Khonsu. Dozens of granite statues, many of them colossal, depicting the pharaohs and gods who were worshipped there. Hundreds of smaller votive objects, bronze statuettes, gold jewelry, ceremonial vessels. 64 ancient ships resting on the seafloor, the remnants of the great trading fleet that once made Thonis Heraklion the most important port in the ancient Mediterranean. And 700 ancient anchors, the largest collection of ancient anchors ever found at a single site, testament to the thousands of ships that passed through this city over the centuries of its prosperity. Thonis Heraklion sank gradually beneath the sea due to the same combination of subsidence and seismic activity that claimed the ancient royal quarter of Alexandria. The waterlogged delta sediments on which it was built slowly liquefied and compacted, lowering the land surface until the city was swallowed by the sea sometime between the 2nd century BCE and the 8th century CE. Unlike Alexandria, which continued to exist as a city in a different location, Thonis Heraklion simply disappeared, and its memory faded to legend until Godio's sonar brought it back to life. Fact 37. The Bimini Road, Atlantis or Geology. In 1968, off the coast of North Bimini Island in the Bahamas, divers discovered something that would ignite one of the longest-running controversies in underwater exploration: a row of large, flat limestone blocks arranged in a curved line on the seafloor at a depth of approximately 5 to 8 meters. The blocks, some weighing several tons, were roughly rectangular, fitted together in a pattern that, to some observers, looked unmistakably like a paved road or causeway constructed by human hands. The Bimini Road, as it came to be called, immediately attracted extraordinary attention. Some researchers pointed out that the famous psychic Edgar Cayce had predicted in 1938 that evidence of the lost civilization of Atlantis would be found near Bimini in 1968 or 1969, and the discovery of the Bimini Road in 1968 seemed to believers to be a stunning confirmation of Cayce's prophecy. The idea that the Bimini Road was a remnant of the legendary sunken continent of Atlantis attracted enormous popular attention and has never entirely gone away. The mainstream geological and archaeological community has reached a different conclusion. Detailed analysis of the Bimini blocks has found that they are composed of beach rock, a type of limestone that forms naturally when beach sediments are cemented together by calcium carbonate precipitated from groundwater. Beach rock commonly fractures along parallel lines perpendicular to the shoreline, producing naturally rectangular blocks that can appear deceptively regular and artificial. The blocks of the Bimini Road on this interpretation are simply naturally fractured beach rock formations, shaped by geological processes rather than by human hands. The counter-arguments from those who believe the Bimini Road is artificial include the observation that some of the blocks appear to be fitted together more precisely than random fracturing would produce, and that certain features, including what appear to be tool marks on some blocks, are difficult to explain by natural processes alone. The controversy has never been fully resolved. What is certain is that the Bahamas platform, the shallow underwater shelf on which the Bimini Islands stand, was above sea level during the last ice age and was inhabited by people as sea levels rose. Whether the Bimini Road is a remnant of ancient human construction or a remarkable natural formation remains, officially, an open question, and the ocean's talent for creating things that look like the work of human hands continues to blur the boundary between archaeology and geology. Fact 38. The ocean influences every breath you take. We have already discussed, in Part 1, the extraordinary role of ocean phytoplankton in producing a large proportion of Earth's atmospheric oxygen. But the ocean's influence on the air we breathe goes far beyond oxygen production. It extends to the regulation of the composition, temperature, and humidity of the atmosphere in ways that make it the single most important system for maintaining the conditions that make human life possible on this planet. The ocean absorbs approximately 25 to 30% of all the carbon dioxide produced by human industrial activity, acting as an enormous carbon sink that has, for the past 2 centuries of industrialization, significantly buffered the pace of climate change by removing CO2 from the atmosphere and incorporating it into ocean waters, where it dissolves to form carbonic acid. Without this ocean carbon absorption, the concentration of CO2 in the atmosphere, and therefore the pace of global warming, would be dramatically higher than it currently is. But this carbon absorption is coming at a cost. As the ocean absorbs more CO2, the carbonic acid it forms lowers the pH of the ocean water, a process called ocean acidification. Since the Industrial Revolution, the average pH of the ocean surface has fallen from approximately 8.2 to 8.1, a decrease of 0.1 pH units that corresponds to a 26% increase in acidity, because pH is a logarithmic scale. This may sound small, but the consequences for marine life, particularly for organisms that build calcium carbonate shells and skeletons, including corals, oysters, sea urchins, and the tiny pteropods, sea butterflies that form a critical part of ocean food webs, are profound and alarming. The ocean also drives the global water cycle, evaporating water from its surface that rises as vapor, forms clouds, and falls as rain and snow over the continents, providing the fresh water that all terrestrial life depends on. Approximately 86% of global evaporation comes from the ocean, and the energy involved in this evaporation, absorbed from the sun, and then released when water vapor condenses into clouds, is the primary driver of global atmospheric circulation and weather patterns. Every drop of rain that falls on the land came, ultimately, from the ocean. Every breath of moist air carries ocean water that evaporated from the sea surface. The ocean is not a separate system from the land and the atmosphere. It is the engine that drives them both. Fact 39. The ocean has a layer called the deep scattering layer. In the early days of World War II, as the United States and its allies began deploying sonar equipment to detect enemy submarines, Navy operators noticed something strange. Their sonar signals were reflecting back from what appeared to be the ocean floor, but the reflections were coming from depths far shallower than the actual seafloor, and in many cases the apparent bottom seemed to move, rising toward the surface at night and sinking back down during the day. For a period during the war, there was genuine puzzlement about what these mysterious reflections represented. Were they geological features? Were they somehow related to the enemy? Could they be a new kind of natural phenomenon no one had previously documented? The answer turned out to be biological. The mysterious reflections were coming not from the seafloor but from enormous concentrations of marine life, the dense aggregations of fish, squid, and crustaceans that make up the community of the mesopelagic zone, the twilight zone between 200 and 1,000 meters. These concentrations, which sonar signals bounced off just as they would bounce off a solid surface, came to be called the deep scattering layer, DSL, and their daily movement, rising to the surface at night and descending at dawn, was the deal vertical migration we discussed in Fact 8. The deep scattering layer is a biological phenomenon of extraordinary scale. In some parts of the ocean, it is so dense that it appears on sonar as a nearly solid surface, a false bottom, created not by rock but by the massed bodies of billions of living creatures. It extends across every ocean basin, forming a biological layer that is one of the most significant features of the ocean's vertical structure. What lives in the deep scattering layer is still not fully known. The mesopelagic zone is one of the least studied parts of the ocean. Its depths are too deep for easy access, but too shallow to justify the expense of deep-sea submersibles, putting it in an awkward middle ground that has kept it relatively unexplored. Recent estimates suggest that the total fish biomass of the mesopelagic zone may be 10 times higher than previously thought, potentially reaching 10 billion tons, making it one of the largest untapped fish resources on Earth and one of the most significant components of the global carbon cycle. Fact 40. The ocean has not always looked the way it does today. We tend to think of the ocean as permanent, a fixed feature of our planet, always roughly where it is today, always roughly as it appears on our maps. The geological record tells a very different story. The ocean basins of today are geologically young. The Atlantic Ocean did not exist 200 million years ago. The continents of North America, South America, Europe, and Africa were joined together in the supercontinent Pangaea, separated only by a shallow, warm inland sea called the Tethys Sea. As Pangaea broke apart, the Atlantic opened, growing wider by approximately 2.5 centimeters per year as new oceanic crust was generated at the mid-Atlantic ridge. The Atlantic Ocean is still growing today and will continue to grow for tens of millions of years into the future. The Pacific Ocean is the oldest and largest of the ocean basins, a remnant of the ancient Panthalassic Ocean that surrounded Pangaea. But even the Pacific is shrinking, as its floor is consumed at subduction zones around its margins, the ring of fire that produces the earthquakes and volcanoes of the Pacific Rim. In approximately 300 million years, the Pacific may have largely disappeared as the Americas collide with Asia in the formation of the next supercontinent. The Mediterranean Sea, as we discussed in Fact 29, was once a desert. The Black Sea was once a freshwater lake. The North Sea was once dry land. The Persian Gulf was once a river valley. The ocean is not a permanent fixture of Earth's geography. It is a dynamic system, constantly changing on geological timescales, shaped and reshaped by the same tectonic forces that move continents and build mountains. In 250 million years, the continents will have rearranged themselves into a new configuration. The ocean basins will have changed beyond recognition. The specific geography of seas and continents that we know today, the Mediterranean, the Atlantic, the Pacific, the Arctic, will be gone, replaced by new oceans and new landmasses whose shapes we can only vaguely predict. The ocean as we know it is not the ocean as it has always been. It is one frame in a geological film that has been running for 4.5 billion years, and that has many chapters yet to come. 40 facts, and the ocean grows stranger and more magnificent with every one. We have met the giant squid, real, luminous, and far more beautiful than the legend. We have descended with the sperm whale into the crushing darkness of the deep. We have watched the anglerfish carry her mates fused to her body through the eternal night. We have stood in the ruins of Alexandria and Port Royal and Thonis Heracleon, ancient cities swallowed by the sea, preserved by the cold dark water in ways that no land sight can match. We have heard the song of the loneliest whale in the ocean. We have watched the Titanic being devoured, molecule by molecule, by bacteria in the deep Atlantic. We have learned that the ocean contains frozen methane that could change the climate of the world, and waterfalls so vast that Niagara is a trickle by comparison. The ocean is not just a place. It is a world of extraordinary complexity and extraordinary age, of creatures that defy imagination and ruins that rewrite history, of forces that have shaped this planet for billions of years and will continue to shape it for billions more. In Part 3, we go to the places no human has ever seen. We descend to the true deep, the abyssal plains, the Hadal trenches, the hydrothermal vent fields where life thrives in conditions that should make it impossible. We explore more of the ocean's submerged history, the ancient trade routes, the legendary lost harbors, the ships that carried the wealth of the ancient world. And we begin to understand what the ocean's future may hold, and what we stand to lose if we do not act to protect it. Let the deep water carry you to sleep. The ocean is waiting, close your eyes and descend. Fact 41, the abyssal plains are the flattest places on Earth. Imagine a landscape so flat, so featureless, so utterly devoid of variation that it makes the Great Plains of North America look like a mountain range. A surface so level that it deviates from perfect flatness by less than a meter over distances of hundreds of kilometers. A place where the horizon, if there were light to see one, would be a perfectly straight line in every direction, unchanging, infinite. This is the abyssal plain, the vast, flat seafloor that covers more than 50% of Earth's surface, lying at depths between 4,000 and 6,000 meters in every ocean basin. The abyssal plains are the flattest, most featureless landscapes on Earth, and they are also the largest. A single abyssal plain can extend for thousands of kilometers without a significant change in depth. The extraordinary flatness of the abyssal plains is not natural in the sense that the underlying oceanic crust is perfectly smooth. Rather, it is the result of millions of years of sediment accumulation, the continuous rain of fine particles settling from the water column above, slowly filling in every depression, burying every ridge, smoothing every irregularity until the seafloor becomes a nearly perfect plain. In some areas, this sediment blanket is over 2 kilometers thick, a geological mattress that has been accumulating grain by grain for hundreds of millions of years. The abyssal plains are among the most remote and least explored environments on Earth. They are too deep for casual diving, too far from shore for easy access, and too vast to be systematically surveyed with current technology. What we know about them comes primarily from isolated sampling points, cores drilled into the sediment, photographs taken from deep-sea cameras, sonar profiles mapping their extraordinary flatness. But for every square kilometer of abyssal plain that has been examined, thousands remain completely unknown. Life on the abyssal plains is sparse but persistent. The organisms that live here, sea cucumbers, brittle stars, deep-sea worms, occasional fish, survive on the meager organic material that drifts down from the productive surface waters thousands of meters above. It is one of the most energy-poor environments on Earth, and the creatures that inhabit it have evolved extraordinary patience, moving slowly, feeding opportunistically, and living in a state of near-suspended animation between meals. The abyssal plains are the ocean's great silence, a realm of profound stillness, profound darkness, and profound flatness that extends across more of Earth's surface than all the continents combined. Fact 42, the Hadal Zone is named after the Greek underworld. Below 6,000 meters, below the abyssal zone, below the deepest points of the normal ocean floor, lies the Hadal Zone, named after Hades, the ancient Greek underworld. It is the deepest, most extreme, most inaccessible environment on Earth, found only in the deepest ocean trenches where tectonic plates collide and the ocean floor is dragged down into the Earth's interior. The Hadal Zone exists in approximately 40 ocean trenches scattered around the Pacific Rim and in a few locations in the Indian and Southern Oceans. Together, these trenches represent less than 2% of the ocean floor by area, but they reach depths that make the rest of the ocean seem shallow by comparison. The Mariana Trench, the Tonga Trench, the Philippine Trench, the Kermadec Trench, these are the Hadal Zones, the true abyss, the deepest water on Earth. The conditions in the Hadal Zone are almost unimaginably extreme. At 10,000 meters depth, approaching the bottom of the Mariana Trench, the pressure is approximately 1,000 times atmospheric pressure at sea level, equivalent to having a fully loaded 747 jumbo jet pressing down on every square meter of surface. The temperature is just above freezing. There is no light whatsoever. The water chemistry is different from the surface ocean, more acidic, low in oxygen. And the food supply is minimal. Only the tiniest fraction of organic material that falls from the surface makes it all the way to the Hadal depths. And yet life exists. Amphipods the size of your hand scuttle across the sediment, feeding on organic debris. Snailfish with translucent, gelatinous bodies swim through the crushing water, their bodies lacking the swim bladders that would collapse at these pressures. Sea cucumbers plow through the mud, extracting nutrients. And microscopic organisms, bacteria, archaea, single-celled eukaryotes, thrive in the sediment, metabolizing organic compounds and surviving conditions that would kill almost any surface organism instantly. The Hadal Zone is a reminder that life on Earth is more resilient, more adaptable, more persistent than we have any right to expect. It exists in the last place it should be able to exist, doing things it should not be able to do, in a realm that feels more like another planet than another part of our own. Fact 43, Challenger Deep has been visited by only 4 crewed missions. The Challenger Deep, the deepest point in the Mariana Trench and the deepest point on Earth, is one of the most inaccessible locations in the known universe. It is harder to reach than the International Space Station. It is more remote than the summit of Mount Everest. The journey to the bottom and back requires technology so specialized, so expensive, and so dangerous that only 4 crewed missions in the entire history of human exploration have successfully made the descent. The first was in 1960, the historic dive of the bathyscaphe Trieste, piloted by Jacques Piccard and US Navy Lieutenant Don Walsh. The Trieste was essentially a large float filled with gasoline for buoyancy, with a small spherical pressure chamber hanging beneath it. The descent took nearly 5 hours. When Piccard and Walsh reached the bottom at a depth of 10,916 meters, they spent only 20 minutes there, partly because one of the outer windows had cracked during descent, creating a risk of catastrophic failure. They saw in the light of their searchlights what appeared to be a flatfish lying on the sediment, proof that complex life could exist even at the deepest point on Earth. Then they dropped ballast and began the ascent, which took over 3 hours. For 52 years, no one returned. The second crewed visit to the Challenger Deep came in 2012, when filmmaker James Cameron descended solo in the submersible Deep-Sea Challenger, a vertically oriented submersible designed specifically for the dive. Cameron spent approximately 3 hours on the bottom, filming and collecting samples before returning to the surface. His footage revealed a landscape of pale, fine sediment, populated by small amphipods and other creatures adapted to the crushing pressure and absolute darkness. The third and fourth visits came in 2019, when explorer Victor Vescovo made multiple dives to the Challenger Deep in the submersible DSV limiting factor as part of the 5 Deeps expedition. Vescovo's dives set new depth records and allowed for more extensive exploration and sampling than previous missions. Among his findings, troubling and significant, was plastic waste on the bottom of the Challenger Deep, a plastic bag, candy wrappers. Human pollution had reached the most remote point on Earth. 4 missions, 4 crews. Fewer people have been to the bottom of the Challenger Deep than have walked on the Moon. The deepest point on our own planet remains, in the most literal sense, one of the least explored places in the solar system. Fact 44, the ocean contains mountains taller than Everest. We have already discussed in Part 1 that the ocean floor contains the mid-ocean ridge system, the longest mountain range on Earth. But the ocean also contains individual mountains that, measured from base to summit, are taller than Mount Everest. The tallest mountain on Earth, measured from base to peak, is Mauna Kea in Hawaii. From its base on the floor of the Pacific Ocean to its summit, Mauna Kea rises approximately 10,210 meters, more than 1,300 meters taller than Mount Everest measured from sea level to summit. The majority of Mauna Kea, approximately 6,000 meters, is underwater, hidden beneath the surface of the Pacific. Only its upper 4,207 meters are visible above sea level. Mauna Kea is a shield volcano, built over millions of years by countless lava flows that erupted from a hotspot in the Earth's mantle and accumulated layer by layer to form the massive structure. The Hawaiian island chain is essentially a series of these enormous underwater mountains, each built by the same hotspot as the Pacific tectonic plate slowly moved across it. To the northwest of Hawaii lies a chain of older, now submerged volcanoes, seamounts that once stood above the water as islands, but have since subsided and eroded below sea level. The Emperor seamounts extend for over 6,000 kilometers across the Pacific, a geological record of the slow, steady movement of the Pacific plate over the Hawaiian hotspot spanning tens of millions of years. Seamounts, underwater volcanoes that do not reach the surface, are extraordinarily common in the world's oceans. There are estimated to be over 100,000 seamounts more than 1,000 meters tall, scattered across the ocean floor, and potentially millions of smaller ones. Many of these seamounts are biological hotspots. Their slopes provide hard substrate for corals and other sessile organisms to attach to. Their topography alters ocean currents in ways that bring nutrients to the surface, and their presence creates habitats that attract fish, marine mammals, and other mobile species. Some of the richest fishing grounds in the world are associated with seamounts, and some of the most vulnerable deep-sea ecosystems, as bottom trawling for fish, can devastate the slow-growing cold-water corals that colonize seamount slopes. The ocean's mountains are not just geological curiosities. They are critical components of ocean ecosystems, shaping currents, creating habitats, supporting life in the vast blue emptiness of the open ocean. Fact 45: the Great Barrier Reef can be seen from space. The Great Barrier Reef, stretching for over 2,300 kilometers along the northeastern coast of Australia, is the largest living structure on Earth. It is not a single reef, but a vast complex of approximately 2,900 individual reefs and 900 islands, covering an area of roughly 344,400 square kilometers, larger than the United Kingdom, Holland, and Switzerland combined. The Great Barrier Reef is so large that it can be seen from space, one of the few biological structures on Earth visible to astronauts in orbit without magnification. From the International Space Station, the reef appears as a pale blue-green band paralleling the Australian coast, its intricate structure of coral formations and lagoons visible in remarkable detail when the water is clear and the light is right. But what makes the Great Barrier Reef truly extraordinary is not its size but its composition. The entire structure, every reef, every island, every meter of its vast extent, is built by living organisms. Tiny coral polyps, individually no larger than a few millimeters, secrete calcium carbonate skeletons that accumulate over thousands of years to form the massive limestone structures of the reef. The Great Barrier Reef represents the accumulated work of countless trillions of individual coral polyps over approximately 8,000 years of continuous growth, a biological construction project of staggering scale. The reef supports one of the most diverse ecosystems on Earth. Approximately 1,500 species of fish, 400 species of coral, 4,000 species of mollusks, 240 species of birds, and a vast array of other organisms, from microscopic plankton to enormous whale sharks, depend on the reef for survival. It is a biodiversity hotspot of global significance, supporting more species in a smaller area than almost any other ecosystem on the planet. And the Great Barrier Reef is dying. Ocean warming driven by climate change has triggered multiple mass bleaching events in recent decades, episodes in which the symbiotic algae that live inside coral tissues and provide them with energy through photosynthesis are expelled, leaving the coral white and vulnerable to starvation. The bleaching events of 2016, 2017, and 2020 killed approximately half of the coral in some sections of the reef. Recovery is possible if water temperatures cool and the coral can reacquire their algal symbionts, but with ocean temperatures continuing to rise, the prospects for recovery are uncertain at best. The largest living structure on Earth, visible from space, built over thousands of years by the collective labor of countless tiny organisms, is facing an existential threat on a timescale of decades. What took millennia to build may be destroyed within a human lifetime. Fact 46: the Baltic Sea contains a ghost fleet of perfectly preserved ships. The Baltic Sea, the large, shallow inland sea bounded by Sweden, Finland, Russia, Estonia, Latvia, Lithuania, Poland, Germany, and Denmark, has a secret. Its deep waters contain one of the largest and best preserved collections of historic shipwrecks anywhere on Earth, a ghost fleet of wooden sailing ships that have remained almost perfectly intact for centuries in the unique conditions of the Baltic's cold, low oxygen, low salinity deep water. The key to the Baltic's extraordinary ship preservation is the absence of Teredo navalis, the shipworm, a wood-boring mollusk that devastates wooden shipwrecks in most of the world's oceans. Shipworms require a certain minimum salinity to survive, and the Baltic Sea, which receives enormous quantities of freshwater from rivers draining much of northern Europe, has a surface salinity of only about 8 parts per thousand in its northern reaches, far too low for shipworms to tolerate. In the deeper waters of the Baltic, salinity is slightly higher but still too low for shipworms, and oxygen levels are very low due to limited vertical mixing, further slowing biological decomposition. The result is that wooden shipwrecks in the deep Baltic are preserved in astonishing condition. The Vasa, a Swedish warship that sank on its maiden voyage in Stockholm harbour in 1628 and was raised in 1961, is the most famous example, but it is far from the only one. Surveys of the Baltic seafloor have documented hundreds of historic shipwrecks, many of them essentially intact, their masts still standing, their hulls complete, their rigging and deck equipment preserved as if the ship had sunk yesterday rather than centuries ago. Among the most extraordinary discoveries was the wreck of the S. Cyrillic letter 47D ERT A umlaut LJE. a Swedish cargo ship from the 1500s, found in 2019 with its cargo of barrels still in the hold, the ship's carved decorations still visible, and even the sailors' personal possessions preserved in the crew quarters. Another discovery, a medieval cog from approximately 1200 CE, was found with its sail still attached, the only example of a medieval ship's sail ever recovered intact. The Baltic Sea's Ghost Fleet is an archaeological resource of incalculable value, a collection of time capsules from every era of Baltic seafaring, preserved by the unique chemistry of the sea in a state that no land-based site and no other ocean can match. And the fleet continues to grow. Every year, new surveys discover more wrecks, adding to the catalogue of this extraordinary underwater museum. Fact 47, the bloop was one of the ocean's greatest mysteries. In the summer of 1997, an array of underwater microphones operated by the US National Oceanic and Atmospheric Administration, NOAA, detected something extraordinary. A sound, extremely loud, ultra-low frequency, lasting for approximately 1 minute, was picked up by sensors more than 5,000 kilometers apart across the Pacific Ocean. The sound was unlike anything in the acoustic database. It rose rapidly in frequency over about 1 minute, then stopped. NOAA named the sound the bloop, and for years, it became one of the ocean's most tantalizing mysteries. The characteristics of the bloop suggested a biological origin. Its frequency pattern, rising rapidly and then stopping, resembled the calls of marine mammals, but with a crucial difference. The bloop was far louder than any known animal sound. Blue whale calls, the loudest sounds produced by any known animal, can reach approximately 188 decibels and travel for hundreds of kilometers. The bloop was detected across the entire width of the Pacific. If it was biological in origin, it was produced by an animal far larger or far louder than any known whale. Speculation was immediate and, in some quarters, wildly imaginative. Was the bloop produced by an unknown species of enormous deep-sea creature, a giant squid far larger than any ever documented, or a deep-sea predator of truly monstrous size? Was it evidence of a creature that science had never identified, living in the unexplored depths of the Pacific? The idea of an unknown leviathan became popular in the public imagination, and the bloop became a fixture of cryptozoology and ocean mystery lore. The truth, when it was finally determined in 2005, was less sensational but geologically significant. NOAA researchers concluded that the bloop was not biological but cryogenic, the sound of an enormous iceberg fracturing and breaking off from an Antarctic ice shelf. The frequency pattern, the loudness, and the location of detection were all consistent with the acoustic signature of a large icequake, a sudden fracture in the ice that releases enormous amounts of acoustic energy into the surrounding water. The bloop was not a monster, it was ice, but the fact that such a sound, so loud, so strange, so unlike anything previously recorded, could go unexplained for 8 years is a reminder of how little we understand about the acoustic environment of the deep ocean. The ocean is full of sounds we have never heard, produced by processes we do not fully understand, in a realm where sound is the primary means of sensing the environment, and where the loudest events may go entirely unwitnessed by human ears. Fact 48, the ocean's twilight zone contains more fish than all fisheries combined. The mesopelagic zone, the twilight zone of the ocean, lying between 200 and 1,000 meters depth, is one of the least understood and most underestimated ecosystems on Earth. For decades, it was assumed to be a relatively sparse environment, a transition zone between the rich surface waters and the impoverished deep sea, populated by small fish and invertebrates of limited ecological significance. Recent research has completely upended this assumption. Advanced sonar surveys and net sampling campaigns conducted over the past 2 decades have revealed that the mesopelagic zone contains a biomass of fish that is staggering in its scale, estimated at somewhere between 1 billion and 10 billion tons, depending on the methodology used. Even the lower estimate represents more fish biomass than all the fish caught by all the world's fisheries in an entire year. The higher estimates suggest that the mesopelagic zone may contain more fish than all other ocean zones combined. The fish of the twilight zone are mostly small, lanternfish, bristlemouths, hatchetfish, and others, typically only a few centimeters long. But their numbers are so vast that they represent one of the largest concentrations of vertebrate biomass on the planet. And they play a critical role in ocean ecology, participating in the ideal vertical migration, rising to feed in surface waters at night and descending to the depths during the day, transporting enormous quantities of carbon from the productive surface to the deep ocean in the process. This carbon transport, the biological pump we have discussed previously, is one of the most important mechanisms by which carbon is removed from the atmosphere and stored in the deep ocean on long timescales. The mesopelagic fish are, in a sense, the engines of this pump, eating carbon-rich food at the surface and excreting it as waste in the deep, where it sinks to the ocean floor and is buried in sediment. The ecological importance of the mesopelagic zone is therefore not just a matter of fish populations, it is a matter of global climate regulation. And the mesopelagic zone is now being eyed as a potential fishery resource. Several countries and commercial interests have begun exploring the possibility of large-scale fishing in the twilight zone, arguing that the enormous biomass represents an untapped source of protein and fish meal. But scientists warn that harvesting mesopelagic fish could have catastrophic consequences, disrupting the biological pump, reducing carbon sequestration, and destabilizing ocean food webs in ways we cannot fully predict. The twilight zone is not a resource waiting to be exploited. It is a critical component of the Earth system that we have only just begun to understand. Fact 49. The Antikythera shipwreck changed our understanding of ancient technology. We have mentioned the Antikythera shipwreck briefly in part 1, but its significance deserves fuller exploration. The ship, a large Roman-era cargo vessel that sank off the Greek island of Antikythera around 65 BCE, was discovered in 1900 by sponge divers who were sheltering from a storm. What they found on the seafloor at a depth of approximately 45 meters was one of the most important archaeological discoveries in history. The cargo of the Antikythera wreck was extraordinary: bronze and marble statues, jewelry, glassware, pottery, coins, and luxury goods from across the ancient Mediterranean, being transporting probably from Greece to Rome when the ship sank. Among the statues recovered were some of the finest examples of ancient Greek bronze sculpture ever found, including the famous Antikythera youth, a larger-than-life bronze statue of a young man, possibly representing Perseus or Paris, of extraordinary artistic quality. But it was a single corroded lump of bronze and wood, recovered from the wreck and initially ignored, that would ultimately prove to be the most significant find. In 1902, archaeologist Valerio Stais noticed that the lump appeared to contain a gear wheel, a bronze cogwheel, corroded and encrusted but unmistakable. Further cleaning revealed more gears, and more. The lump was not a single object, but a complex mechanism, a device of extraordinary sophistication that would come to be known as the Antikythera mechanism. It took decades of study using X-ray imaging, CT scanning, and painstaking analysis of the corroded fragments to understand what the Antikythera mechanism actually was. The conclusion was stunning. It was an analog computer, a mechanical calculator of extraordinary complexity, designed to track the positions of the sun, moon, and planets, predict eclipses, and calculate the dates of the ancient Olympic Games. It contained at least 30 interlocking bronze gears, possibly as many as 37, arranged in a configuration that allowed it to model the complex motions of celestial bodies with remarkable accuracy. The Antikythera mechanism was built around 100 BCE, and nothing of comparable mechanical sophistication is known to have existed anywhere in the world for another 1,000 years. The device shattered the assumption that ancient technology was primitive, demonstrating that the ancient Greeks possessed a level of mechanical engineering capability that historians had not imagined. If one such device could be built in the ancient world, how many others existed? And how much knowledge of ancient technology has been lost because the devices were made of metal, which corrodes, rather than stone or pottery, which lasts? The Antikythera mechanism is a reminder that the ocean's shipwrecks are not just historical curiosities. They are time capsules that can fundamentally change our understanding of what past civilizations knew and what they were capable of creating. Fact 50. Rogue waves are real and terrifying. For centuries, sailors told stories of enormous waves that appeared without warning in the open ocean, walls of water far larger than any normal wave, rising from the sea like moving mountains, smashing into ships with catastrophic force and disappearing as suddenly as they had appeared. These rogue waves, also called freak waves or monster waves, were dismissed by oceanographers and naval architects as exaggerations, the inevitable mythology of frightened sailors encountering large but not exceptional storm waves. Then, on January 1, 1995, an oil platform called the Draupner platform in the North Sea recorded something that should not have been possible. In a storm with significant wave heights, the average height of the highest one-third of waves, of approximately 12 meters, the platform's instruments detected a single wave with a height of 25.6 meters, more than twice the significant wave height, and far larger than any wave that existing wave models predicted could occur under those conditions. The Draupner wave was the first rogue wave ever scientifically documented with instrumental measurements. Its existence confirmed what sailors had been saying for centuries. rogue waves are real. Since the Dropner wave was recorded, satellite observations and ship-based measurements have documented thousands of rogue waves in oceans around the world. They are far more common than anyone had realized, occurring somewhere in the ocean possibly several times per day, and they are genuinely anomalous, far exceeding the size that linear wave theory predicts. A rogue wave is typically defined as a wave whose height is more than twice the significant wave height of the surrounding sea state, a statistical outlier so extreme that it should occur only once in tens of thousands of waves, and yet occurs far more frequently. What causes rogue waves is still not fully understood. Several mechanisms have been proposed: constructive interference, where multiple waves temporarily combine to form a larger wave; wave focusing by currents, where strong currents compress wave energy into a smaller area; and nonlinear wave interactions, where the physics of wave propagation in steep seas produces occasional extreme waves. The true answer is probably a combination of all of these mechanisms, occurring under specific conditions that are difficult to predict. What is certain is that rogue waves are dangerous. They have sunk ships, damaged oil platforms, killed sailors, and broken supposedly unsinkable vessels. The MV München, a modern cargo ship that disappeared in the North Atlantic in 1978 with all hands, is believed to have been destroyed by a rogue wave, based on the debris recovered and the extreme damage to the ship's superstructure. The Prestige oil tanker, which broke apart off the coast of Spain in 2002, causing one of the worst environmental disasters in European history, may have been structurally weakened by a rogue wave encountered days earlier. The ocean is not a smooth, predictable surface. It is a dynamic, chaotic system where extreme events occur more frequently than probability would suggest. The rogue wave is the ocean's reminder that its power and its unpredictability can never be fully tamed. Fact 51: the ocean has rivers and lakes within it. One of the most extraordinary and counterintuitive phenomena in the deep ocean is the existence of underwater rivers and lakes, bodies of water with distinctly different chemistry, temperature, and density from the surrounding ocean, flowing through the sea or pooling on the seafloor like rivers and lakes on land, but underwater. These underwater rivers and lakes are formed by brine, extremely salty water that is denser than normal seawater, and therefore sinks to the ocean floor rather than mixing with the surrounding water. The brine can come from several sources: the dissolution of salt deposits buried beneath the seafloor, the concentration of seawater through evaporation in isolated basins, or the expulsion of salt-rich water from sediments being compressed by geological forces. One of the most studied underwater brine bodies is the brine pool in the Gulf of Mexico, discovered in the 1990s at a depth of approximately 650 meters. The brine pool is an eerie sight, a perfectly defined lake on the ocean floor, approximately 30 meters long and 12 meters wide, with a distinct shoreline where the brine meets the overlying seawater. The brine is approximately 4 to 5 times saltier than normal seawater, and it is toxic, containing high concentrations of methane and hydrogen sulfide that make it lethal to most marine life. Fish and other organisms that swim into the brine pool die almost immediately, their bodies sinking to the bottom of the pool and becoming food for the specialized bacteria and tube worms that colonize the pool's edges. Underwater rivers have also been documented, most famously in the Yucatan Peninsula of Mexico, where freshwater flowing out of the extensive cave systems beneath the limestone bedrock meets the saltwater of the ocean in the flooded cenotes, sinkholes. The freshwater and saltwater do not immediately mix. Instead, they form distinct layers, with the freshwater floating on top of the denser saltwater and flowing along the interface like a river. Divers swimming through these underwater rivers describe the surreal experience of passing through a distinct boundary, a halocline, where the water's chemistry changes abruptly and visibility becomes blurred as light refracts differently through the two layers. The existence of underwater rivers and lakes is a reminder that the ocean is not a uniform body of water, but a complex, stratified system where differences in temperature, salinity, and chemistry create boundaries and flows that behave in many ways like the aquatic systems of the land. Fact 52: the SS Central America carried gold that changed the economy. On September 12, 1857, a sidewheel steamship called the SS Central America was steaming northward from Panama to New York City, carrying 578 passengers and crew and an extraordinarily valuable cargo, approximately 30,000 pounds of gold, gold bars, gold coins, and raw gold dust, mined from the goldfields of California during the gold rush and being shipped east to banks and investors. The Central America ran into a hurricane off the coast of the Carolinas. For 2 days, the crew and passengers fought to keep the ship afloat, bailing water, jettisoning cargo, and desperately trying to keep the boilers running. On the evening of September 12, the ship's hull gave way. The Central America sank in approximately 2,200 meters of water, taking 425 lives and its entire cargo of gold to the bottom of the Atlantic. The loss of the Central America had immediate and dramatic economic consequences. The gold on board represented a significant fraction of the gold reserves backing the US banking system at the time, and its sudden disappearance contributed to the Panic of 1857, a financial crisis that saw the failure of numerous banks and a severe economic recession. The sinking of a single ship had changed the economy of the nation. For 130 years, the wreck of the Central America remained undiscovered, despite numerous attempts to locate it. Then, in 1988, a team led by deep-sea recovery expert Tommy Thompson used advanced sonar and remotely operated vehicles to find the wreck lying on the deep Atlantic seafloor. What they found was extraordinary. The gold cargo was still there, scattered across the seafloor around the wreck site, preserved in remarkable condition by the cold, oxygen-poor deep water. The recovery of the Central America's gold, approximately 7,000 gold coins, hundreds of gold bars, and quantities of gold dust, with a total value in the hundreds of millions of dollars, was one of the most valuable deep-sea salvage operations in history. But the recovery was also controversial, leading to decades of legal battles over ownership of the treasure among the salvors, the insurance companies that had paid claims on the gold in the 1850s, and the descendants of the original owners. The story of the SS Central America is a reminder that the ocean's shipwrecks are not just archaeological sites. In some cases, they are treasure troves of extraordinary value, and the legal, ethical, and practical challenges of recovering that treasure are as complex as the technical challenges of finding the wrecks in the first place. Fact 53: the ocean's conveyor belt regulates Earth's climate. We have discussed the thermohaline circulation briefly in Part 2, but its importance to Earth's climate system deserves fuller attention. The thermohaline circulation, often called the global ocean conveyor belt, is a system of interconnected ocean currents that spans every ocean basin on Earth, transporting heat, salt, nutrients, and dissolved gases on a planetary scale. The conveyor belt begins in the North Atlantic. Warm surface water carried northward by the Gulf Stream loses heat to the cold atmosphere as it approaches the Arctic. As it cools, the water becomes denser. At the same time, sea ice formation extracts fresh water from the surface and leaves the salt behind, making the surface water even denser and saltier. Eventually, this cold, dense, salty water sinks to the ocean floor, a process called deep water formation, and begins flowing southward as a cold bottom current. This southward flowing deep current moves down the Atlantic, around the southern tip of Africa, and into the Indian and Pacific Oceans, where it gradually rises back to the surface in a process called upwelling. Once at the surface, the water warms, flows westward across the Pacific and Indian Oceans, rounds the southern tip of Africa again, and flows northward up the Atlantic to complete the loop. A single cycle of the conveyor belt takes approximately 1,000 years, meaning that water currently sinking in the North Atlantic will not return to the surface until the year 3025. The climate implications of this circulation are profound. The Gulf Stream and North Atlantic Drift transport approximately 1.4 petawatts of heat energy northward, roughly equivalent to 100 times the total energy consumption of human civilization. This heat makes northern Europe's climate far milder than its latitude would suggest. Without the thermohaline circulation, London, at the same latitude as Newfoundland, would have winters like those of northern Canada. And the thermohaline circulation is weakening. Multiple studies over the past 2 decades have found evidence that the Atlantic Meridional Overturning Circulation, AMOC, the Atlantic component of the global conveyor belt, has slowed by approximately 15% since the mid-20th century. The cause is the addition of freshwater from melting ice sheets in Greenland and the Arctic, which dilutes the salty surface water and reduces its density, making it less likely to sink. Climate models suggest that continued warming could slow the AMOC further, or possibly trigger a collapse, a sudden shutdown of the circulation that would have catastrophic consequences for European and North American climates. The ocean's conveyor belt is not a passive feature of the Earth system. It is an active regulator of global climate, and its stability is not guaranteed. Fact 54: Doggerland was the Atlantis of the North Sea. Between approximately 18,000 and 6,000 years ago, when sea levels were lower during and after the last ice age, a large landmass connected the island of Great Britain to continental Europe. This land, now submerged beneath the southern North Sea, has come to be called Doggerland, after the Dogger Bank, a shallow area of the North Sea where fishing trawlers frequently pull up ancient bones, tools, and artifacts from the seafloor. Doggerland was not a barren wasteland. It was a rich, habitable landscape, a gently rolling plain crossed by rivers, dotted with lakes and marshes, forested with birch and pine, and populated by large animals including mammoth, aurochs, red deer, and wild horse. And it was inhabited by humans, hunter-gatherer populations who lived on Doggerland for thousands of years, fishing its rivers, hunting its forests, and establishing communities on what was, at the time, some of the most productive land in northern Europe. As the Ice Age ended and the great ice sheets melted, sea levels rose. Doggerland was progressively inundated, first from the north, as the rising North Sea advanced across the low-lying plains, and later from the south as the English Channel opened. By approximately 6,500 years ago, Doggerland had been entirely submerged, and Britain had become an island, separated from the continent by the sea. The flooding of Doggerland was gradual enough that the human populations living there would not have experienced it as a sudden catastrophe. Rather, it would have been a slow retreat over many generations, with coastal settlements being abandoned as the sea advanced and populations moving inland to higher ground. But the cumulative effect was the loss of an enormous area of habitable land. Estimates suggest that Doggerland at its maximum extent was approximately the size of modern Britain, and the displacement of the human populations that had lived there for millennia. Modern marine archaeology is now beginning to recover the physical evidence of Doggerland's human inhabitants. Trawler nets have pulled up worked flints, barbed antler points, and fragments of tools. Seismic surveys have identified buried river channels and what may be the remains of human settlements preserved beneath the sediment of the North Sea floor. In 2019, a team of archaeologists and divers announced the discovery of what they believe is a submerged prehistoric settlement on the Dogger Bank. Stone tools, animal bones, and charcoal deposits preserved in sediment at a depth of approximately 30 meters, dating to approximately 7,000 years ago, just before the final flooding of Doggerland. Doggerland is often called the Atlantis of the North Sea, not because it was a mythical lost civilization, but because it was a real, inhabited land that was swallowed by rising sea levels, and whose memory has been preserved in the physical evidence being slowly recovered from the seafloor. Fact 55: methane seeps on the ocean floor create underwater volcanoes of ice. In certain areas of the deep ocean floor, particularly along the edges of continental shelves where methane hydrates are destabilizing, methane gas seeps up through the sediment and into the overlying water. When this methane reaches the cold, high-pressure environment of the deep seafloor, something extraordinary happens: it freezes. Not into water ice, but into methane hydrate, the same clathrate structure we discussed in Part 2, in which methane molecules are trapped within a lattice of water ice. As the methane continues to seep upward, more and more hydrate accumulates around the seep site, building upward from the seafloor in structures that can reach heights of 40 meters or more, mounds of frozen methane and water ice, rising from the ocean floor like underwater volcanoes. These structures are called methane hydrate mounds, or more poetically, ice volcanoes. They have been documented in multiple locations: off the coast of Norway in the Gulf of Mexico, off the Pacific Northwest coast of North America, and they represent one of the most visually striking features of the deep ocean floor. The mounds are colonized by chemosynthetic bacteria that metabolize the methane seeping from the structure, and these bacteria in turn support communities of tube worms, clams, mussels, and other organisms in a miniature ecosystem, powered entirely by methane rather than sunlight. The methane hydrate mounds are also unstable. If ocean temperatures rise or if pressure conditions change, the hydrate can destabilize, releasing large quantities of methane gas into the water column. In some cases, this release is gradual, a continuous seepage that feeds the chemosynthetic communities. In other cases, it can be explosive, a sudden release of gas that creates enormous plumes of bubbles rising from the seafloor, temporarily creating zones of reduced water density that could, in theory, pose a hazard to ships passing overhead. The existence of methane hydrate mounds is a reminder that the ocean floor is not a static landscape. It is a place where geological and biological processes create structures of extraordinary beauty and complexity, structures that exist only under the specific conditions of the deep sea, and that would collapse if brought to the surface. Fact 56: the ocean has underwater crop circles. In 1995, divers off the coast of southern Japan discovered something that seemed impossible: large, intricate circular patterns carved into the sandy seafloor at a depth of approximately 25 meters. The patterns were geometrically precise, approximately 2 meters in diameter, with radial ridges extending outward from a central hub and smaller circular grooves creating a mandala-like design. They looked artificial, too regular, too symmetrical to be natural formations. But who or what had created them, and for what purpose? The mystery of the underwater circles off Japan remained unsolved for nearly 20 years. Various theories were proposed. Some researchers suggested they were the result of unusual current patterns. Others proposed they were created by geological processes or by human activity. The truth, when it was finally discovered in 2011 by photographer Yoju Carter and subsequently documented by marine biologists, was more charming and more unexpected than anyone had imagined. The circles were created by a small species of pufferfish, Torquigena albimaculosus, a fish approximately 12 centimeters long. The male pufferfish constructs the circles as part of his mating display, spending 7 to 9 days swimming in circular patterns, using his fins to sculpt the sand into the intricate geometric design, complete with radial ridges that serve to channel ocean currents and create a calmer area in the center. The completed circle serves as a nest site. Females are attracted to the most elaborate and well-constructed circles, where they lay their eggs in the central area. The male then guards the eggs until they hatch. The discovery that a 12-centimeter fish could create a 2-meter geometric structure, approximately 160 times its own body length, of such precision and complexity was astonishing. It represents one of the most sophisticated examples of animal construction behavior ever documented, comparable in relative scale to a human building a structure the size of a city block using only their hands and feet. The underwater circles of Japan are a reminder that the ocean contains behaviors and phenomena that we have not yet imagined, that evolution can produce solutions to the challenges of survival and reproduction that are as beautiful as they are unexpected. Fact 57. The ocean contains lakes of liquid carbon dioxide. In certain areas of the deep ocean floor, particularly near underwater volcanoes and at tectonic boundaries where volcanic activity releases gases from the Earth's interior, carbon dioxide seeps up through the sediment and into the overlying water. At the cold temperatures and high pressures of the deep ocean, this CO2 does not form bubbles and rise to the surface. Instead, it forms liquid pools. Liquid CO2 is denser than seawater at deep-sea pressures. When it emerges from the seafloor, it pools in depressions and flows downslope like water on land, forming lakes and streams of liquid carbon dioxide on the ocean floor. These CO2 lakes are transparent but visible. The boundary between the liquid CO2 and the overlying seawater creates a distinct shimmering interface, similar to the heat shimmer seen above a hot road. The CO2 lakes are toxic to most marine life. The dissolved CO2 acidifies the surrounding water, and the concentration of CO2 itself is lethal to organisms that enter the lake. Fish and invertebrates that swim into a CO2 lake die within seconds, their bodies sinking to the bottom of the lake where they are preserved in the acidic, oxygen-poor liquid. The largest documented CO2 lakes are found near underwater volcanoes in the Western Pacific, including sites near Taiwan and Japan. Research submarines exploring these sites have documented pools of liquid CO2 several meters across, with streams of liquid CO2 flowing through channels in the seafloor, creating what looks like a landscape from another planet, a toxic, alien world of transparent liquid rivers flowing through the darkness. Scientists studying these natural CO2 seeps are interested in them not just as geological curiosities, but as analogues for what might happen if large-scale carbon capture and storage, the proposed technology of capturing CO2 from industrial sources and injecting it into the deep ocean or into geological formations beneath the seafloor, were to leak. The CO2 lakes demonstrate that liquid CO2 can persist for long periods in the deep ocean, and that its environmental effects on surrounding ecosystems can be severe. Fact 58. Tsunamis can cross entire ocean basins. The word tsunami comes from the Japanese words tsu, harbor, and nami, wave, reflecting Japan's long and tragic history with these devastating waves. But calling a tsunami a wave is misleading in important ways. A tsunami is not like a wind-driven surface wave, it is a displacement wave caused by the sudden vertical movement of enormous volumes of water, typically triggered by underwater earthquakes, volcanic eruptions, or submarine landslides. When an underwater earthquake displaces the seafloor, lifting or dropping it by several meters in an instant, it displaces the entire water column above it, creating a wave that propagates outward in all directions from the source. In deep water, a tsunami may have a wavelength, the distance from one wave crest to the next, of 100 to 200 kilometers or more, and an amplitude wave height of only a meter or less, so small that ships in deep water often do not notice a tsunami passing beneath them. But tsunamis travel at extraordinary speeds. The speed of a tsunami is determined by the depth of the water. In the deep ocean, where depths are 4,000 to 5,000 meters, a tsunami travels at approximately 700 to 800 kilometers per hour, the speed of a commercial jet aircraft. This means that a tsunami generated by an earthquake near Japan can cross the entire Pacific Ocean and strike the coast of Chile in less than 24 hours. As a tsunami approaches shore and the water depth decreases, its speed decreases but its height increases dramatically, a process called shoaling. The energy that was spread over the entire depth of the water column in the deep ocean is compressed into a smaller vertical space as the water shallows, causing the wave to rise. A tsunami that was only a meter high in the deep ocean can grow to heights of 10, 20, or even 30 meters as it approaches the coast, becoming a wall of water that strikes with catastrophic force. The Indian Ocean tsunami of December 26, 2004, triggered by a magnitude 9.1 earthquake off the coast of Sumatra, was one of the deadliest natural disasters in recorded history. The tsunami killed an estimated 230,000 people in 14 countries around the Indian Ocean, with waves reaching heights of up to 30 meters in some locations. The wave crossed the entire Indian Ocean, striking the coast of Somalia in East Africa, approximately 5,000 kilometers from the epicenter, approximately 7 hours after the earthquake. The Tohoku tsunami of March 11, 2011, triggered by a magnitude 9 earthquake off the northeastern coast of Japan, reached heights of up to 40 meters in some coastal areas, traveled up to 10 kilometers inland, and caused the Fukushima Daiichi nuclear disaster when it flooded the power plant's backup generators. The tsunami was detected by buoys and tide gauges across the entire Pacific and caused measurable changes in sea level as far away as Antarctica. Tsunamis are the ocean's reminder that it is connected, that events in one part of the ocean can have consequences on the opposite side of the planet, and that the power of the sea, when unleashed, respects no boundary. Fact 59: the ocean's dead zones are growing. In certain areas of the world's oceans, particularly in coastal waters near major river mouths and in semi-enclosed seas, the oxygen concentration in the deep water has dropped to levels so low that most marine life cannot survive. These areas are called hypoxic zones, or more colloquially, dead zones, and they represent one of the most alarming trends in ocean health over the past several decades. Dead zones are caused by a process called eutrophication, the over-enrichment of water with nutrients, particularly nitrogen and phosphorus from agricultural runoff and sewage discharge. When these nutrients enter coastal waters, they trigger explosive growth of algae and phytoplankton. When these organisms die, they sink to the bottom and are decomposed by bacteria, a process that consumes oxygen. In stratified water columns, where surface and deep water do not mix efficiently, the oxygen in the deep water can be completely depleted, creating conditions that suffocate fish, crabs, and other oxygen-dependent organisms. The Gulf of Mexico contains one of the largest and most studied dead zones in the world, an area that forms every summer off the coast of Louisiana and Texas, fed by nutrients washing down the Mississippi River from the agricultural heartland of the United States. At its peak, the Gulf of Mexico Dead Zone has covered an area of over 22,000 square kilometers, roughly the size of New Jersey, rendering vast areas of historically productive fishing grounds uninhabitable for most marine life. But the Gulf of Mexico is far from the only dead zone. The Baltic Sea has a massive dead zone in its central basin that has existed for decades. The Chesapeake Bay in the eastern United States develops seasonal dead zones. The Black Sea has a permanent anoxic layer below approximately 150 meters depth. And the number and size of dead zones worldwide has been increasing. Over 500 dead zones have been documented globally, up from fewer than 50 in the 1950s. Some dead zones are seasonal, forming in summer when warm water stratification prevents oxygen mixing, and disappearing in winter when storms mix the water column. Others are persistent, lasting year-round and expanding over time. And in some locations, including parts of the eastern Pacific off the coast of South America, dead zones are expanding and moving closer to shore as ocean warming reduces the oxygen-carrying capacity of seawater and increases stratification. The growth of ocean dead zones is not a distant or abstract problem. It is a direct consequence of human agricultural and industrial practices, and it represents a significant threat to ocean productivity and to the communities that depend on the sea for food and livelihoods. Fact 60: the ocean is becoming more acidic faster than any time in 300 million years. We end part 3 with perhaps the most consequential fact of all. The ocean is absorbing carbon dioxide from the atmosphere at an unprecedented rate, and in doing so, it is becoming more acidic faster than at any time in at least the past 300 million years, and possibly faster than at any time since the ocean formed. When CO2 dissolves in seawater, it reacts with water to form carbonic acid, which then dissociates to release hydrogen ions, lowering the pH of the water. Since the beginning of the Industrial Revolution, the ocean has absorbed approximately 525 billion tons of CO2 from the atmosphere, roughly 30% of all the CO2 released by human activity. This absorption has lowered the average pH of the ocean's surface from approximately 8.2 to 8.1, a change that corresponds to a 30% increase in acidity. The rate of this change is the critical issue. Geological records show that the ocean has experienced changes in pH in the deep past, during the Paleocene thermal maximum 56 million years ago, for example, or during the end Permian mass extinction 252 million years ago. But those changes occurred over thousands to millions of years, timescales that allowed marine organisms to adapt through evolution, migration, or physiological acclimation. The current acidification is occurring over decades, a rate of change that is 10 to 100 times faster than any comparable event in the geological record, and too fast for many marine organisms to adapt. The organisms most vulnerable to ocean acidification are those that build calcium carbonate shells and skeletons, including corals, mollusks, echinoderms, and pteropods. As the ocean becomes more acidic, the carbonate ion concentration decreases, making it more difficult for these organisms to precipitate calcium carbonate and build their structures. In extreme cases, acidification can cause existing calcium carbonate structures to dissolve. Pteropods, small swimming snails that are a critical food source for many fish species, seabirds and whales, are already showing signs of shell dissolution in some areas of the Southern Ocean and the North Pacific where acidification is most advanced. Coral reefs are experiencing reduced calcification rates, making them more vulnerable to storm damage and erosion. Oyster hatcheries in the Pacific Northwest have experienced massive die-offs of larvae when upwelling brings acidified deep water to the surface. The ocean has buffered humanity from the full consequences of our carbon emissions for 2 centuries. But that buffering is coming at a cost, a fundamental change in ocean chemistry that is already affecting marine ecosystems, and that will intensify in the coming decades unless carbon emissions are dramatically reduced. 60 facts, and the ocean reveals itself not just as a place of wonder and mystery, but as a system under stress. A system that has absorbed the consequences of human activity for centuries and is now beginning to show the strain. We have descended to the abyssal plains, the flattest places on Earth. We have visited the Challenger Deep, the deepest point in the ocean, accessible to only a handful of humans in all of history. We have met the pufferfish that creates underwater art and learned that the ocean contains rivers, lakes, and ice volcanoes beneath the waves. We have explored Doggerland, the Atlantis of the North Sea, and learned that sea level rise has swallowed civilizations before and will do so again. We have recovered the gold of the SS Central America and the impossible mechanism of Antikythera. We have watched rogue waves rise from the sea and tsunamis cross entire ocean basins in hours. And we have learned that the ocean is changing, warming, acidifying, losing oxygen, stressed by the cumulative weight of human activity in ways that threaten the very systems that make life on Earth possible. In Part 4, we will explore more of the ocean's wonders and more of its warnings. We will meet more extraordinary creatures, explore more sunken cities, and dive deeper into the question of what the future holds for the ocean and for us. The deep water awaits. Now we explore more of the ocean's extraordinary creatures and its most profound mysteries. We meet the immortal jellyfish that can reverse its own agging, the fish that live in boiling water, the sharks that glow in the dark. We explore more sunken treasures, Spanish galleons laden with silver, Viking longships preserved in mud, ancient Mediterranean traders that carried the wealth of empires. And we confront the ocean's future, the rising seas, the warming waters, the changes that are already beginning and that will reshape coastlines and civilizations in the decades to come. The ocean is vast, the ocean is deep, and we have only begun to understand what it holds. Close your eyes, descend with us into rest. Fact 61, the immortal jellyfish can reverse its agging. In the warm coastal waters of the Mediterranean Sea and the waters around Japan lives a small jellyfish, Turritopsis dohnaei, typically only 4 to 5 millimeters in diameter, that possesses one of the most extraordinary biological capabilities ever documented. This jellyfish is, in a very real sense, biologically immortal. Like all jellyfish, Turritopsis dohnaei begins its life as a larva that settles on the seafloor and develops into a polyp, a small, stationary form that looks more like a tiny sea anemone than a jellyfish. The polyp eventually buds off free-swimming medusae, the familiar bell-shaped jellyfish form, which mature, reproduce sexually, and then normally die. But Turritopsis dohnaei does not die. when the adult medusa is stressed by starvation, injury, disease, or environmental changes, it can revert to the polyp stage. The bell-shaped body contracts, the tentacles are reabsorbed, and the entire organism transforms back into a polyp, settling on the seafloor and beginning its life cycle again. This process, called transdifferentiation, in which mature cells transform into completely different cell types, allows the jellyfish to essentially reset its biological clock and begin life anew. There is no known limit to how many times a single Turritopsis doana can undergo this transformation. In theory, an individual jellyfish could cycle between medusa and polyp stages indefinitely, never dying of old age, though in practice, most are eaten by predators or killed by disease or accidents long before they have a chance to demonstrate true immortality. The mechanism by which Turritopsis doana reverses its development is still being studied, but it involves the activation of genes normally expressed only during early development and the transformation of specialized adult cells back into stem cells that can then differentiate into any cell type the organism needs. Understanding this process could have profound implications for regenerative medicine and the biology of aging in other organisms, including humans. The immortal jellyfish is a reminder that the ocean contains organisms with capabilities that seem to violate the fundamental rules of biology as we understand them, and that studying these organisms may reveal secrets about life that we have not yet imagined. Fact 62. The Pompeii worm lives at temperatures that should kill it. At hydrothermal vents on the seafloor, those extraordinary ecosystems we discussed in Part 1, where superheated water pours from cracks in the ocean floor and supports communities of life based on chemosynthesis rather than photosynthesis, lives one of the most heat-tolerant animals on Earth. The Pompeii worm, Alvinella pompeiana, named after the deep-sea submersible Alvin that discovered it, lives in tubes attached to the sides of hydrothermal vent chimneys in the eastern Pacific Ocean. These chimneys, called black smokers because they emit plumes of dark, mineral-rich water, can reach temperatures of 350 to 400 degrees Celsius at their openings. The Pompeii worm builds its tube right at the edge of this extreme heat, positioning its tail end in water that can reach 80 degrees Celsius, far hotter than any other animal is known to tolerate. How does the Pompeii worm survive these temperatures? The answer is only partially understood. The worm's body is covered with a fleece-like mat of bacteria that appears to provide insulation, keeping the worm's body temperature lower than the surrounding water. The worm also produces heat shock proteins, molecules that protect other proteins from denaturing at high temperatures, at levels far higher than most organisms. And the worm positions itself strategically in its tube, keeping its head end in cooler water while exposing only its tail to the extreme heat. Even so, the temperatures the Pompeii worm endures would be lethal to almost any other complex animal. The proteins that make up most animals' bodies begin to denature, to unfold and lose their function, at temperatures above 40 to 50 degrees Celsius. The Pompeii worm's ability to function at 80 degrees Celsius represents an extraordinary adaptation to one of the most extreme environments on Earth. The Pompeii worm, like the other organisms of the hydrothermal vent ecosystems, has expanded our understanding of the conditions under which complex life is possible, and has implications for the search for life in extreme environments elsewhere in the solar system, including the subsurface oceans of Europa and Enceladus, where hydrothermal activity may create similar conditions beneath kilometers of ice. Fact 63. Sharks have been around for over 400 million years. Sharks are older than trees, older than dinosaurs, older than the rings of Saturn. Sharks have existed in the ocean for over 400 million years, since the Devonian period, long before the first vertebrates crawled onto land, long before forests covered the continents, long before most of the familiar features of the modern world came into existence. The earliest sharks were very different from modern species, smaller, with different jaw structures and different tooth arrangements. But the basic body plan, streamlined, cartilaginous skeleton, multiple gill slits, replaceable teeth, has proven so successful that it has persisted almost unchanged for hundreds of millions of years. Sharks survived the mass extinction that killed the dinosaurs 66 million years ago. They survived the Permian-Triassic extinction 252 million years ago, the worst mass extinction in Earth's history, which killed approximately 96% of all marine species. Sharks, as a group, have survived every major catastrophe in the history of complex life on Earth. Some ancient shark species were genuinely monstrous in size. Megalodon Otodus megalodon was the largest shark that ever lived, reaching lengths of up to 18 meters and weights of up to 60 tons. Its teeth, triangular, serrated, and up to 18 centimeters long, are found in marine sediments around the world, testimony to a predator that dominated the oceans for approximately 20 million years before going extinct approximately 3.6 million years ago. The bite force of Megalodon has been estimated at up to 18 tons, the strongest bite of any animal ever documented, sufficient to crush the skull of a whale in a single bite. Modern sharks are smaller than Megalodon but no less impressive. The great white shark, Carcharodon carcharias, can reach lengths of up to 6 meters and is one of the ocean's apex predators, capable of breaching completely out of the water when attacking seals. The whale shark, Rhynchodon typus, is the largest fish in the ocean, reaching lengths of up to 18 meters, but is a gentle filter feeder that eats primarily plankton and small fish. Today, sharks face a threat they have never encountered before in their 400 million year history: industrial-scale human fishing. Approximately 100 million sharks are killed each year, primarily for their fins, which are used in shark fin soup. Many shark populations have declined by 90% or more over the past several decades. These ancient survivors, which outlasted the dinosaurs, outlasted countless mass extinctions, outlasted the rise and fall of entire geological eras, may not survive the century if current fishing practices continue. Fact 64: the ocean floor is littered with aircraft wrecks from World War II. The ocean floor contains not just ancient shipwrecks, but the wreckage of more recent conflicts. And nowhere is this more evident than in the Pacific Ocean, where thousands of aircraft from World War II lie scattered across the seafloor, testimony to the vast aerial battles that raged across the Pacific theater between 1941 and 1945. The Pacific War was fought across an area spanning more than 15 million square kilometers of ocean. Aircraft carriers launched thousands of sorties. Land-based aircraft flew missions over vast stretches of open water. And when aircraft were damaged in combat, suffered mechanical failures, or ran out of fuel, they fell into the sea, often in water so deep that they were never recovered. The ocean floor around the island chains of the Pacific, Micronesia, the Marshalls, the Marianas, the Solomons, is littered with the wrecks of American, Japanese, and Allied aircraft. Wildcats and Hellcats, Zeros and Bettys, B-17s and B-24s, all lying on the seafloor in varying states of preservation, their aluminum airframes corroding slowly in the salt water, but often still recognizable decades after they crashed. Some of these aircraft wrecks lie in shallow water and have become popular diving sites, coral-encrusted fighters and bombers resting on sandy bottoms at depths accessible to recreational divers. Others lie in deep water, known only from sonar contacts and occasional ROV surveys, and many more have never been located at all. They are recorded in military records as missing, their final resting places unknown. The aircraft wrecks of the Pacific are more than historical curiosities, they are war grave. Many still contain the remains of their crews, pilots and gunners and navigators who died when their aircraft went down, their bodies entombed in the wreckage. For the families of those lost, these wrecks are sacred sites, deserving of respect and protection. Organizations dedicated to locating and documenting Pacific war wrecks, including Project Recover, a collaborative effort between scientists and historians, have made it their mission to find these missing aircraft, identify the remains of crew members when possible, and bring closure to families who have waited decades to know what happened to their loved ones. The ocean remembers the wars we fought across its surface, and the technology now exists to recover those memories, one wreck at a time. Fact 65: bioluminescent bays glow when disturbed. In a few rare locations around the world, most famously in Puerto Rico, Jamaica, and Vietnam, coastal bays and lagoons exhibit one of the most magical phenomena in the natural world. When the water is disturbed by a swimming fish, a kayak paddle, a hand trailing in the water, or even by rain falling on the surface, it glows with an eerie blue-green light, as if the water itself has become luminous. These bioluminescent bays are created by enormous concentrations of dinoflagellates, single-celled organisms that produce light through a chemical reaction when they are mechanically disturbed. The specific species responsible for most bioluminescent bays is Pyridinium bahamense, which exists in normal coastal waters at low concentrations, but can bloom to densities of up to 700,000 cells per liter of water in bays with the right conditions: warm water, shallow depth, limited exchange with the open ocean, and nutrient input from surrounding mangroves. When an individual dinoflagellate is disturbed by movement in the water, it produces a brief flash of blue-green bioluminescence lasting about a tenth of a second. In a bay with hundreds of thousands of dinoflagellates per liter, every movement creates a cascade of light, millions of tiny organisms flashing simultaneously, creating a glow that outlines fish, illuminates swimming bodies, and turns every splash and ripple into a burst of living light. The brightest bioluminescent bay in the world is Mosquito Bay on the island of Vieques in Puerto Rico, where dinoflagellate concentrations can reach over 700,000 cells per liter. On a moonless night, swimming in Mosquito Bay is a surreal experience. Every movement leaves a trail of blue-green light. Fish appear as glowing torpedoes darting through the darkness, and raising a hand from the water causes droplets to fall like liquid stars. But bioluminescent bays are fragile ecosystems. They require specific environmental conditions to maintain the dinoflagellate populations, and they are vulnerable to pollution, coastal development, and changes in water flow. Several formerly bioluminescent bays have lost their glow due to environmental degradation. The preservation of these extraordinary ecosystems requires careful management and protection, because once the light is lost, it may never return. Fact 66. The ocean contains enough gold to make every person on Earth a billionaire. Here is a fact that sounds like fantasy, but is absolutely true. The ocean contains approximately 20 million tons of dissolved gold, enough gold to give every person on Earth approximately 9 pounds, 4 kilograms of gold, worth roughly $240,000 at current prices. The gold in seawater exists in extraordinarily dilute concentrations, approximately 10 to 30 parts per trillion, depending on location and depth. This means that in 1 million liters of seawater, roughly enough to fill a large swimming pool, there are only about 10 to 30 grams of gold. To extract a single ounce of gold, about 28 grams, would require filtering and processing approximately 1 million liters of seawater, a task that, with current technology, would cost far more in energy and equipment than the gold would be worth. The source of the ocean's dissolved gold is the weathering and erosion of gold-bearing rocks on land. Rivers carry microscopic particles and dissolved ions of gold into the ocean, where they remain in solution, so dilute that they are essentially unrecoverable with any technology that exists or that is likely to exist in the foreseeable future. This has not stopped people from trying. In the 1890s, a British chemist named Edward Sonstadt proposed extracting gold from seawater and even conducted small-scale experiments that appeared to confirm the presence of gold in ocean water. In the 1920s, the German chemist Fritz Haber, already famous for inventing the process for synthesizing ammonia, spent years attempting to develop a practical method for extracting gold from seawater. Hoping to help Germany pay off its war debts from World War I, he eventually concluded that the concentrations were too low and the technical challenges too great for the process to be economically viable. The ocean's dissolved gold is a reminder that the sea contains vast resources, not just biological resources like fish, not just mineral resources like the polymetallic nodules on the ocean floor, but dissolved elements in quantities that dwarf the known reserves of those elements on land. The challenge is not the quantity, it is the concentration and the energy cost of extraction. The ocean holds wealth beyond imagining, but most of it will remain, for the foreseeable future, beyond our reach. Fact 67. Lanternfish make up 65% of all deep-sea fish biomass. If you were to take a census of all the fish in the deep ocean and weigh them, you would find that approximately 65% of the total biomass consists of a single family of small, bioluminescent fish that most people have never heard of, the lanternfish family Myctophidae. Lanternfish are typically 2 to 15 centimeters long, small enough to fit in the palm of your hand, and they live primarily in the mesopelagic zone, the twilight zone between 200 and 1,000 meters depth. They get their name from the rows of bioluminescent photophores on their undersides and flanks, light-producing organs that glow with a pale blue-green light, creating patterns unique to each species that may serve as species recognition signals or as camouflage through counter-illumination. What makes lanternfish ecologically significant is not their individual size, but their collective abundance. There are approximately 250 species of lanternfish, and they exist in such vast numbers that they may represent the most abundant vertebrates on Earth by total biomass, exceeding even the combined biomass of all domesticated animals, all wild terrestrial mammals, and possibly even all humans. Lanternfish are active participants in the Deal vertical migration, rising to feed in the productive surface waters at night and descending to the depths during the day. In doing so, they transport enormous quantities of carbon from the surface to the deep ocean, playing a critical role in the biological pump that regulates atmospheric CO2 levels. They are also a major food source for larger predators. Tuna, swordfish, seals, seabirds, and many species of whales depend on lanternfish as a primary component of their diet. Despite their importance, lanternfish remain poorly studied. They are difficult to sample, too deep for easy net fishing, too small to be a commercial target. and much of what we know about them comes from stomach contents of predators and from acoustic surveys that detect their presence but cannot easily distinguish species or count individuals. The ocean's most abundant vertebrates remain, in many ways, a mystery, testament to how much we still do not know about the life that exists just below the sunlit surface. Fact 68, the Nuestra Señora de Atocha carried $450 million in treasure. On September 6, 1622, a Spanish galleon called Nuestra Señora de Atocha left Havana harbor as part of a fleet of 28 ships carrying the wealth of the New World back to Spain. The cargo included approximately 40 tons of silver and gold, 32 kilograms of emeralds from Colombia, and countless other valuable items, jewelry, coins, worked metal, gemstones, representing the accumulated tribute and trade goods from Spain's American colonies. The Atocha never reached Spain. One day out of Havana, the fleet sailed into a hurricane. The storm scattered the ships and drove many of them onto the coral reefs and shallow waters of the Florida Keys. The Atocha struck a reef and sank in approximately 17 meters of water off Key West, taking all but 5 of her 265 passengers and crew to the bottom. Her cargo, one of the richest in the history of Spanish colonial shipping, settled into the sand and turtle grass of the seafloor, where it would remain for 363 years. Spanish authorities organized immediate salvage efforts, but the Atocha's wreck site proved difficult to locate, and a second hurricane scattered the wreckage across a wide area of seafloor. Eventually, the salvage efforts were abandoned, and the location of the wreck was lost. In 1985, after 16 years of searching, treasure hunter Mel Fisher and his team located the main wreck site of the Atocha using magnetometers and side-scan sonar. What they found was extraordinary. Silver bars stacked like cordwood, gold chains weighing several kilograms, emeralds the size of walnuts, and thousands of silver coins scattered across the seafloor. The total value of the treasure recovered from the Atocha has been estimated at over $450 million, making it one of the most valuable shipwreck discoveries in history. The Atocha's treasure is now displayed in museums in Florida and around the world. Silver bars with the stamps of colonial mints, exquisitely worked gold jewelry. Emeralds of museum quality, but the recovery of the Atocha also sparked controversy over the ethics and legality of treasure hunting. Critics argue that treasure hunters destroy the archaeological context of shipwrecks in their rush to recover valuable items, turning historical sites into profitable salvage operations. Defenders argue that without the financial incentive of treasure hunting, many important wrecks would never be found. The debate continues, but the ocean's treasure continues to draw those willing to search for it, and the financial rewards for finding ships like the Atocha remain irresistible. Fact 69, some sharks glow in the dark. In 2019, marine biologists studying kitefin sharks, Dalacius licher, in the deep waters off New Zealand made a surprising discovery. The sharks glowed in the dark, not with bioluminescence produced by symbiotic bacteria, as many deep-sea fish do, but with light generated by the sharks' own bodies through specialized light-producing cells called photophores. The kitefin shark, which can grow to lengths of up to 1.8 meters, became the largest known bioluminescent vertebrate ever documented, far larger than the small lanternfish and other bioluminescent species previously known. The sharks produce a blue-green glow across their bellies and along their flanks, likely serving the same function as in other bioluminescent deep-sea animals: counterillumination, which makes the shark invisible to predators looking upward by matching the faint glow of surface light filtering down from above. But the kitefin sharks were not alone. The same study documented bioluminescence in 2 smaller shark species, the black-belly lantern shark and the southern lantern shark, bringing the total number of known bioluminescent shark species to over 50. These species produce light through different chemical mechanisms and with different patterns, suggesting that bioluminescence has evolved independently multiple times in sharks. The discovery of bioluminescent sharks raises fascinating questions about the ecology of the deep sea. If sharks can produce light, they may be using it not just for camouflage, but for communication, prey attraction, or species recognition. The patterns of photophores on different species are species-specific, suggesting they may function as visual signals, a glow pattern that allows sharks to identify potential mates in the darkness. The ocean holds more mysteries than we know, and the discovery that some of its largest predators glow in the dark, producing their own light in the eternal darkness of the mesopelagic zone, is a reminder that even familiar animals like sharks can surprise us with capabilities we never imagined. Fact 70, the ocean has waves beneath its surface. The waves we see on the ocean surface, wind-driven waves that crash on beaches and rock ships in storms, are familiar to everyone. But beneath the surface, the ocean contains another type of wave entirely. Internal waves, which occur at the boundaries between water layers of different densities and can be far larger than any surface wave. Internal waves form at the interface between layers of water with different temperatures or salinities, a boundary called a pycnocline. When tidal currents flow over underwater ridges or continental shelf breaks, they disturb the pycnocline, creating waves that propagate along the density interface, much as surface waves propagate along the air-water interface. But because the density difference between the two water layers is much smaller than the density difference between air and water, internal waves can grow to enormous heights, in some cases exceeding 100 meters from trough to crest. These internal waves are invisible from the surface. They occur entirely underwater, sometimes at depths of hundreds of meters, but they have real physical effects. Submarines traveling through regions of strong internal waves can experience sudden changes in buoyancy, causing the submarine to rise or sink unexpectedly. Internal waves transport enormous quantities of energy and nutrients, bringing cold, nutrient-rich deep water to the surface and supporting marine ecosystems in ways that scientists are only beginning to understand. Internal waves can also be detected from space. When an internal wave approaches the surface, it creates subtle changes in surface roughness. The water above the wave's crest moves faster than the water above the trough, creating ripples that can be detected by satellite radar. Images from space reveal vast fields of internal waves radiating from undersea ridges and shelf breaks, covering areas of hundreds of square kilometers, invisible giants of the ocean interior, moving through the depths in silence. Fact 71, the Viking longships of Roskilde were found in a fjord. In the late 1950s, researchers investigating Roskilde Fjord in Denmark began to notice unusual obstructions on the fjord floor near the town of Skulderlev. Local legend held that several ships had been deliberately sunk in the narrow channel centuries ago to block enemy vessels from sailing up the fjord to attack the town of Roskilde, then an important Viking settlement. But the truth of this legend, and the age and nature of the sunken ships, remained unknown until an archaeological expedition in 1962 began the painstaking process of excavating the site. What the excavation revealed was extraordinary. 5 Viking ships, deliberately sunk and weighted with stones sometime around 1070 CE to create a barrier across the narrowest part of the fjord. The ships were not identical. They represented a cross-section of Viking maritime technology, including a large ocean-going cargo ship, Nar, a smaller coastal trader, a longship designed for warfare and raiding, and 2 smaller vessels for fishing and local transport. The ships had been preserved in the cold, low-oxygen mud of the fjord for nearly 900 years. When excavators removed them piece by piece, and transporting them to the Viking Ship Museum in Roskilde, they found that much of the original timber was intact, allowing researchers to study Viking shipbuilding techniques in extraordinary detail. The grain of the wood revealed which trees the ships were built from. Tool marks on the planks showed how Viking shipwrights shaped and joined timber. Even repairs and modifications made during the ships' working lives were visible, providing a record of how the ships had been used and maintained. The Skulderlev ships are among the best preserved Viking vessels ever discovered, and they have transformed our understanding of Viking maritime capability. The ocean-going Nar, for example, was built for long-distance trade across the North Atlantic, a vessel capable of carrying cargo to Iceland, Greenland, and possibly even to the Viking settlements in North America. Its construction, clinker-built, with overlapping planks fastened with iron rivets, shows a level of engineering sophistication that allowed the Vikings to navigate the most dangerous waters of the North Atlantic in open boats. The ships of Roskilde Fjord are a reminder that the shallow waters of the world's coastlines contain treasures of historical importance equal to any deep-sea wreck, and that sometimes the most important discoveries are made not in the open ocean, but in the muddy, unremarkable waters close to shore. Fact 72, the ocean absorbs most of the heat from global warming. When we talk about global warming and climate change, the focus is usually on the atmosphere, rising air temperatures, changing weather patterns, more frequent heat waves. But this atmospheric focus misses the most important part of the story. The ocean is absorbing most of the heat. Since the 1970s, more than 90% of the excess heat trapped by greenhouse gases has been absorbed by the ocean. The atmosphere, the land surface, and the melting of ice have absorbed the remaining 10%. This means that the ocean has acted as an enormous heat sink, buffering the atmosphere from the full effects of greenhouse gas accumulation and slowing the rate of atmospheric temperature increase. But this buffering has come at a cost. The ocean is warming, and warming faster than at any time in the geological record. Average ocean temperatures have increased by approximately 0.7 degrees Celsius since the pre-industrial era, with the warming concentrated in the upper layers of the ocean, where mixing with the atmosphere occurs most readily. In some regions, particularly in the Arctic and in the subtropical gyres, the warming has been even more pronounced. Ocean warming has direct and serious consequences. Warmer water holds less dissolved oxygen, creating or expanding dead zones. Warmer water is less dense, increasing stratification and reducing the vertical mixing that brings nutrients from the deep to the productive surface waters. Warmer water causes the expansion of the ocean volume, thermal expansion, which is currently responsible for approximately half of observed sea level rise. And warmer water stresses marine ecosystems, triggering coral bleaching events, shifting the ranges of fish species poleward, and disrupting the timing of biological events like spawning and migration. The ocean has protected humanity from the worst effects of our greenhouse gas emissions. But the ocean's capacity to absorb heat is not infinite, and the consequences of the heat it has already absorbed are becoming increasingly severe. The ocean is warming, and it will continue to warm for decades or centuries, even if greenhouse gas emissions are reduced, because of the enormous thermal inertia of the ocean system. Fact 73: octopuses are among the most intelligent invertebrates. The octopus, a soft-bodied cephalopod mollusk with 8 flexible arms covered in suckers, is one of the ocean's most extraordinary creatures, not because of its size or its speed, but because of its intelligence. Octopuses are widely considered to be the most intelligent invertebrates on Earth, exhibiting cognitive abilities that rival or exceed those of many vertebrates. Octopuses can solve complex problems. They can navigate mazes, unscrew jar lids to access food, use tools including coconut shells, which some species carry with them and use as portable shelters, and learn through observation, watching other octopuses and then imitating their behavior. They have excellent memories, remembering individual humans and reacting differently to those who have fed them versus those who have not. And they are masters of camouflage, not just changing color to match their surroundings, but changing the texture of their skin to mimic rocks, coral, or seaweed, transforming their appearance in less than a second. The octopus nervous system is extraordinary in its architecture. An octopus has approximately 500 million neurons, comparable to a dog, but only a third of those neurons are in the brain. The rest are distributed throughout the animal's 8 arms, which means that each arm has a degree of autonomy, capable of sensing, moving, and even deciding without direct input from the central brain. An octopus arm can continue to move and respond to stimuli, even after being severed from the body, a capability that is both fascinating and deeply unsettling. Octopuses are also short-lived. Most species live only 1 to 2 years, and even the largest species rarely live more than 5 years. This short lifespan, combined with their extraordinary intelligence, raises fascinating questions about the evolution of cognition. Octopuses do not learn from their parents. They hatch from eggs and are immediately independent, with no parental care. Their intelligence is therefore largely innate rather than learned, encoded in their genes and neural architecture rather than transmitted through culture. The octopus is a reminder that intelligence can evolve along pathways very different from our own, that the brains of mollusks can produce cognitive capabilities comparable to those of mammals, and that the ocean contains minds that experience the world in ways we can barely imagine. Fact 74: the Dead Sea Scrolls were preserved by extremely dry conditions, but the ocean preserves differently. This fact may seem out of place in a series about the ocean, but it illustrates an important principle about preservation. The Dead Sea Scrolls, ancient religious texts dating from approximately 250 BCE to 68 CE, were preserved for over 2,000 years in the extremely dry caves near the Dead Sea, where the lack of moisture prevented the decay of the parchment and papyrus on which they were written. The ocean preserves materials through an exactly opposite mechanism, not through dryness but through cold, darkness, and in some cases, low oxygen. Organic materials that would rot within years on land can persist for centuries or millennia in the deep ocean. Shipwrecks that would be destroyed by weathering and biological decomposition on land are preserved in extraordinary detail on the seafloor. Wooden artifacts that would disintegrate in soil remain intact in anoxic sediments. But there is a critical difference. The ocean preserves what is already submerged, but it destroys what is not adapted to its environment. Paper documents dissolve in seawater. Unsealed containers flood and their contents are lost. Materials that depend on staying dry, like books, textiles, and most written records, are destroyed almost immediately when submerged. This is why the archaeological record of the ocean is so dominated by durable materials. Ceramics, glass, metal, stone. The ocean is an extraordinary preserver of ships, statues, and structures, but it is a terrible preserver of written records. We know the shapes of ancient ships in extraordinary detail because the wood is preserved. But we know almost nothing about what the sailors were reading, what records they kept, what letters they carried, because those materials dissolved. The exception is when organic materials are sealed, trapped in containers, buried in sediment, or protected by the structure of the ship itself before seawater can reach them. Some of the most exciting recent discoveries in maritime archaeology have come from finding sealed storage areas in shipwrecks, amphora that still contain their original olive oil or wine, wooden chests that protected their contents from seawater, writing tablets sealed in wax that preserved the scratched text beneath. The ocean and the desert preserve through opposite mechanisms, but both teach us the same lesson: that preservation is not passive but requires specific conditions, and that most of what existed in the past has been lost. What survives is the exception, not the rule. Fact 75: sea level has risen 20 centimeters since 1880. Since the late 19th century, the beginning of systematic tide gauge measurements, global mean sea level has risen by approximately 20 to 23 centimeters, 8 to 9 inches. This may not sound like much, less than the length of a ruler, but the consequences have been significant, and the rate of rise is accelerating. Sea level rise is caused by two primary mechanisms: thermal expansion of seawater as the ocean warms, and the addition of water from melting ice sheets and glaciers. Of the approximately 20 centimeters of rise observed since 1880, roughly half has come from thermal expansion and half from ice melt. But the rise is not uniform across the globe. Some regions, particularly the Western Pacific and the Eastern Indian Ocean, have experienced sea level rise of 30 centimeters or more, while other regions have seen smaller increases or even local decreases due to land uplift or changes in ocean circulation. Coastal communities in low-lying regions, Pacific island nations, river deltas, coastal plains, are already experiencing increased flooding during high tides and storm surges, saltwater intrusion into freshwater aquifers, and erosion of coastlines. And the rate of rise is accelerating. Between 1880 and 1920, sea level rose at an average rate of approximately 0.6 millimeters per year. Between 1920 and 1990, the rate increased to approximately 1.4 millimeters per year. Since 1990, the rate has been approximately 3.3 millimeters per year, more than twice the 20th century average. Satellite measurements show that the rate is continuing to increase, driven primarily by accelerating ice loss from Greenland and Antarctica. Current projections suggest that global sea level could rise by 30 to 60 centimeters by 2100 under moderate emissions scenarios, and by 60 to 110 centimeters or more under high emissions scenarios. Some recent studies suggest that these projections may be conservative, that the potential for rapid ice sheet collapse in Antarctica could drive sea level rise of 2 meters or more by 2100 in worst-case scenarios. A rise of 1 meter would displace hundreds of millions of people, inundate major cities including Miami, New Orleans, Shanghai, Mumbai, and Bangkok, and permanently submerge many island nations. The ocean is rising, and the consequences will reshape the geography and the demography of the world. Fact 76: the mimic octopus can impersonate other animals. In the murky waters of river mouths and estuaries in Indonesia and Malaysia lives one of the ocean's most remarkable performers, the mimic octopus, Thormictopus mimicus. Unlike other octopuses, which camouflage themselves by matching their surroundings, the mimic octopus impersonates other animals, changing not just its color and texture, but its shape and behavior to look like venomous or dangerous species that predators avoid. The mimic octopus has been observed impersonating at least 15 different species, including lionfish, by spreading its arms to mimic the lionfish's venomous spines, sea snakes, by hiding most of its body and waving two arms to look like two swimming snakes, and flatfish, by pulling its arms close to its body and gliding across the seafloor. The impersonations are remarkably convincing. The octopus changes not just its appearance, but its movement patterns to match the species it is imitating. What makes this behavior even more extraordinary is that it appears to be strategic. The mimic octopus chooses which animal to impersonate based on the threat it is facing. When approached by a predatory fish, it may impersonate a lionfish. When approached by a different predator, it may impersonate a sea snake. The octopus seems to have a repertoire of impersonations and the cognitive ability to select the appropriate one for the situation. The mimic octopus was only scientifically described in 1998. And its discovery fundamentally changed our understanding of what invertebrates are capable of. The level of behavioral flexibility and cognitive sophistication required to impersonate multiple different species, to observe those species, learn their appearance and movement patterns, and then reproduce them convincingly, is extraordinary for any animal and almost unheard of in an invertebrate. The mimic octopus is a reminder that the ocean's creatures are not simple automata responding mechanically to stimuli. They are problem solvers, adapters, performers, beings with rich behavioral repertoires, and perhaps inner lives of complexity and depth that we are only beginning to appreciate. Fact 77: the ocean has garbage patches larger than Texas. In the North Pacific Ocean, approximately halfway between Hawaii and California, there exists a region known as the Great Pacific Garbage Patch, an enormous accumulation of plastic debris, fishing nets, and other human waste that has been concentrated by ocean currents into an area estimated to be anywhere from 700,000 to 1.6 million square kilometers in size, larger than Texas, possibly twice the size of Texas. The Great Pacific Garbage Patch is not a solid island of trash. It is more accurately described as a diffuse soup of plastic particles, with higher concentrations of debris than surrounding waters, but still mostly open water. Much of the plastic is in the form of microplastics, particles smaller than 5 millimeters that have broken down from larger plastic items through the action of sunlight, waves, and weathering. These microplastics are suspended throughout the water column, creating a region where every sample of water contains plastic particles. The garbage patch exists because of the North Pacific Gyre, a large system of rotating ocean currents that concentrates floating debris in its center. Plastic waste from rivers, coastal areas, and ships throughout the Pacific Basin is transporting by currents toward the center of the gyre, where it accumulates indefinitely. Because most plastics do not biodegrade, they only break down into smaller and smaller pieces. The debris in the garbage patch can persist for decades or centuries. The Great Pacific Garbage Patch is not the only one. Similar accumulations of plastic debris have been identified in the South Pacific, the North Atlantic, the South Atlantic, and the Indian Ocean, 5 major garbage patches corresponding to the 5 major ocean gyres. Together, these patches contain an estimated 5.25 trillion pieces of plastic debris, weighing approximately 269,000 tons. The ecological consequences are severe. Seabirds, sea turtles, and marine mammals ingest plastic debris, mistaking it for food, leading to starvation, poisoning, and death. Fish and invertebrates consume microplastics, which accumulate in their tissues and are transferred up the food chain. The plastic debris provides transport for invasive species, organisms that attach to floating plastic and travel across ocean basins to colonize new regions. And the sheer visual and chemical pollution of the ocean represents a profound degradation of one of Earth's most important ecosystems. The ocean's garbage patches are a visible, measurable consequence of human consumption and waste disposal. They are not natural features, they are entirely human-created, and they will persist until we change the systems that produce them. Fact 78: jellyfish are among the oldest animals on Earth. Jellyfish, soft-bodied, gelatinous animals with radial symmetry and trailing tentacles, have existed in the ocean for at least 500 million years, and possibly much longer. Fossil evidence of jellyfish-like organisms has been found in rocks dating to the Cambrian period, approximately 500 million years ago, and possibly even earlier, to the Ediacaran period, approximately 635 to 541 million years ago, making jellyfish among the oldest complex animals on Earth. The reason jellyfish have persisted for so long is their extraordinary simplicity and efficiency. Jellyfish have no brain, no bones, no blood, no heart. They are approximately 95% water, with the remaining 5% consisting of a simple nerve net, a thin layer of tissue, and the stinging cells, cnidocytes, that they use to capture prey and defend themselves. This simplicity makes jellyfish extraordinarily efficient. They require very little energy to survive, can tolerate a wide range of environmental conditions, and can thrive in waters too low in oxygen or too polluted for most other animals. Jellyfish populations have been increasing in many parts of the world over the past several decades, a phenomenon sometimes called jellification of the ocean. The causes are complex and include overfishing, which removes predators and competitors of jellyfish, nutrient pollution, which creates conditions favorable for jellyfish blooms, and climate change, which warms waters and reduces oxygen levels, both of which favor jellyfish over fish. Some jellyfish blooms have been large enough to cause significant economic and ecological impacts. Massive blooms of jellyfish have clogged the cooling water intakes of power plants, forcing shutdowns. They have devastated fish farms by stinging farmed fish to death. They have invaded tourist beaches in such numbers that swimming becomes impossible. In the Sea of Japan, blooms of Nomura's jellyfish, enormous jellyfish that can weigh up to 200 kilograms, have been so large that they damaged fishing nets and made fishing economically unviable in affected areas. The success of jellyfish in the modern ocean is, in a sense, a warning sign. Jellyfish thrive in degraded ocean conditions, warm, polluted, overfished waters where most other organisms struggle. The more the ocean becomes dominated by jellyfish, the less it resembles the productive, diverse ecosystem that has existed for most of Earth's history. Fact 79. The ocean floor contains deep-sea coral reefs that are thousands of years old. When most people think of coral reefs, they picture the warm, shallow, sunlit reefs of the tropics, the Great Barrier Reef, the reefs of the Caribbean, the atolls of the Pacific. But the ocean also contains another type of coral reef, very different from the tropical reefs we know. Deep-sea coral reefs, found at depths of 200 to 2,000 meters or more, in cold, dark water far from any sunlight. Deep-sea corals, also called cold-water corals, do not rely on photosynthetic algae for energy as tropical corals do. Instead, they feed on plankton and organic particles suspended in the water, capturing food with their tentacles and surviving in complete darkness on the energy extracted from their prey. Because they grow so slowly, some deep-sea coral species grow only a few millimeters per year. They can live for extraordinary lengths of time. Some deep-sea coral colonies have been radiocarbon dated to over 4,000 years old, making them among the oldest living organisms on Earth. Deep-sea coral reefs provide critical habitat for other deep-sea organisms. Fish, crustaceans, mollusks, and other invertebrates congregate around deep-sea coral structures, which provide shelter, feeding opportunities, and substrate for attachment in the otherwise relatively featureless environment of the deep ocean floor. In some areas, deep-sea coral reefs support fisheries. Commercial fishing vessels target the aggregations of fish around coral structures, often using bottom trawls that drag heavy nets across the seafloor. This bottom trawling is catastrophic for deep-sea coral reefs. The trawl nets tear through the coral structures, breaking apart colonies that took thousands of years to grow, crushing them into fragments and scattering the debris across the seafloor. Because deep-sea corals grow so slowly, recovery from trawling damage can take centuries or millennia if it occurs at all. Surveys of trawled areas have found fields of broken coral rubble where living reefs once stood, ecosystems destroyed in minutes that will not recover within any human timeframe. The protection of deep-sea coral reefs is one of the most pressing issues in ocean conservation. These ecosystems are among the oldest and slowest growing on Earth, and they are being destroyed faster than they can be mapped and studied. Once they are gone for millennia. Fact 80. The ocean may contain undiscovered megafauna. We have explored approximately 5% of the ocean. We have mapped about 20% of the ocean floor in any detail. The vast majority of the ocean, particularly the deep sea below 1,000 meters, remains virtually unexplored, surveyed only by occasional ship transects, ROV dives, and sonar surveys that reveal the general bathymetry but provide little information about what lives there. This raises a tantalizing question. Could there be large animals in the ocean that science has not yet discovered? The answer is almost certainly yes, but with important caveats. It is unlikely that there are completely unknown animals the size of whales swimming in the surface waters of the ocean. The surface is relatively well studied, heavily trafficked by ships, and regularly surveyed by satellites. Any large animal consistently surfacing to breathe would almost certainly have been observed by now. But the deep sea is different. The mesopelagic and bathypelagic zones, the twilight zone and the midnight zone, are vast, dark, and poorly studied. Large animals that live permanently at depth that do not surface, and that exist at low population densities could easily remain undiscovered. The giant squid was essentially unknown to science until the 20th century, and was not filmed alive in its natural habitat until 2012. The colossal squid was unknown until the early 20th century, and remains one of the least studied large animals on Earth. In 2021, researchers using ROVs to explore the deep Pacific near Australia discovered a siphonophore, a colonial organism related to jellyfish, with a body length estimated at 45 to 50 meters, making it potentially the longest animal ever recorded. It was discovered by accident during a survey intended to study deep-sea ecosystems in an area that had never been previously explored. If a 50-meter animal can be discovered in 2021, what else might be down there? The deep ocean is large enough, dark enough, and unexplored enough that the possibility of undiscovered megafauna, large animals completely unknown to science, remains real. The ocean keeps its secrets well, and some of those secrets may be very large indeed. 80 facts, and the ocean reveals itself as even stranger, richer, more endangered than we imagined. We have met the immortal jellyfish and the fish that live in boiling water. We have discovered that sharks glow in the dark and that octopuses can impersonate other animals. We have explored the treasure of the Atocha and the Viking ships of Roskilde. We have learned that the ocean is warming, acidifying, rising, changing faster than at any time in hundreds of millions of years. We have seen the Great Pacific Garbage Patch and the deep-sea coral reefs that are being destroyed in minutes after growing for millennia. We have learned that the ocean absorbs most of the heat from global warming, that sea level has risen 20 centimeters and will rise much more, and that the consequences of these changes will reshape the world. In the final part, we complete the journey. We explore the remaining 20 facts, from the extraordinary creatures that survive in the most extreme environments to the greatest mysteries that the ocean still holds. We confront the ocean's future and our own, and we ask the most important question of all: what will we do with what we now know? The ocean is waiting, one more descent remains. We have explored every zone of the ocean, from the sunlit surface where phytoplankton produce half the oxygen we breathe, down through the twilight zone where bioluminescent creatures make their own light, past the midnight zone of permanent darkness, all the way to the Hadal trenches where the pressure would crush a submarine, and yet life persists. We have met the giants, the blue whale, the giant squid, the colossal squid. We have met the ancient survivors, sharks that have existed for 400 million years, Greenland sharks that live for centuries, jellyfish that may be immortal. We have explored sunken cities, Alexandria, Port Royal, Thonis Heraclean, Pavloptri, and recovered treasures from Spanish galleons and Viking longships. We have learned that the ocean is not just vast but changing, warming faster than at any time in the geological record, acidifying at rates that organisms cannot adapt to, rising in ways that will reshape coastlines and displace hundreds of millions of people. We have seen the garbage patches, the dead zones, the coral bleaching events that are transforming the ocean before our eyes. Now in this final part, we complete the journey. We explore the last 20 facts. From the deepest mysteries the ocean still holds to the most extraordinary adaptations life has evolved to survive in impossible conditions. We confront what the ocean's future may hold, and we ask ourselves what responsibility we have to protect the ocean that has made our existence possible. The final descent, the deepest truths. Close your eyes one last time, and let the ocean carry you home. Fact 81, the Mariana snailfish lives deeper than almost any other fish. In 2017, an international team of researchers deployed a deep-sea lander, a free-falling camera system designed to sink to the ocean floor, record video, and then return to the surface, in the Mariana Trench at a depth of approximately 8,178 meters. What the camera recorded was extraordinary: a fish swimming actively near the seafloor at a depth where most fish cannot survive. The fish was a Mariana snailfish, Pseudolaparus swirei, a species scientifically described in 2017 and known only from the Hadal zone of the Mariana Trench. The Mariana snailfish is a small, tadpole-like fish, typically 10 to 20 centimeters long, with translucent, gelatinous skin, tiny eyes, and a body adapted to survive at pressures exceeding 800 times atmospheric pressure at sea level. How does the Mariana snailfish survive at such depths? The answer involves multiple extraordinary adaptations. The fish has no swim bladder, the gas-filled organ that most fish use to control buoyancy, because a gas-filled structure would collapse instantly at Hadal pressures. Instead, the fish is neutrally buoyant due to its high water content and gelatinous tissues. Its bones are poorly mineralized and flexible, preventing them from being crushed. Its cellular proteins are protected by high concentrations of osmolytes, small organic molecules that stabilize protein structure under extreme pressure. And its body produces specialized enzymes that remain functional at pressures that would denature the enzymes of surface organisms. The Mariana snailfish represents the current depth record for fish. No fish has been confirmed to live at greater depths. Theoretical calculations suggest that there may be a hard limit to how deep fish can exist, determined by the point at which the osmolyte concentrations required to stabilize proteins become so high that they interfere with normal cellular function. That limit is estimated to be somewhere around 8,200 to 8,400 meters, very close to the depth where the Mariana snailfish has been observed. Below that depth, the ocean may be too extreme for fish, but it is not too extreme for life. Amphipods, sea cucumbers, and other invertebrates have been found at the bottom of the Challenger Deep at nearly 11,000 meters. The Hadal zone is not empty. It is simply beyond the limits of what vertebrates can tolerate. Fact 82, the ocean contains methane seeps that burn underwater. In certain areas of the ocean floor, particularly in the Gulf of Mexico, off the coast of Norway, and in other regions where methane-rich sediments are disturbed by tectonic activity, methane gas seeps continuously from the seafloor, rising through the water column in streams of bubbles. And in a few rare and extraordinary cases, that methane is burning, producing underwater flames that flicker in the darkness of the deep sea. These underwater fires are not like fires on land. Methane cannot burn in water because there is no oxygen gas to support combustion. But at hydrothermal vent sites, where superheated water emerges from the seafloor at temperatures exceeding 400 degrees Celsius, the conditions are different. When methane seeping from nearby sediments encounters the extremely hot vent fluid, it can react with sulfate dissolved in the seawater in a high-temperature chemical reaction that releases energy and produces sulfur compounds and carbon dioxide. This reaction is not technically combustion, but it releases heat and creates glowing, flame-like plumes in the water. True combustion has also been observed in experimental settings. In 2018, researchers from China demonstrated that methane released from seafloor sediments could be ignited and would burn continuously when a pilot flame was introduced at the seep site, creating a sustained underwater flame fueled by the methane bubbling up from below. The flame was small and fragile, easily extinguished by water movement, but it demonstrated that sustained combustion is possible underwater if the fuel supply is continuous and concentrated enough. The existence of underwater methane seeps, whether burning or not, is significant because they represent a potential source of greenhouse gas emissions. Most of the methane released from seafloor seeps dissolves in seawater and is consumed by bacteria before it reaches the surface, but some fraction escapes to the atmosphere, contributing to atmospheric methane levels. And if ocean warming destabilizes methane hydrate deposits, as we discussed in Part 3, the amount of methane escaping from the seafloor could increase dramatically, with potentially serious consequences for climate. The ocean floor is not a static, lifeless expanse. It is geologically active, chemically complex, and in some places, literally on fire. Fact 83: the ocean has rivers of dense, salty water called brine channels. We have already discussed underwater rivers and lakes formed by brine in Part 4, but the phenomenon deserves deeper exploration because of its sheer strangeness. In the Mediterranean Sea, particularly in the deep basins off the coast of Egypt and Libya, the seafloor is crossed by channels, underwater rivers of brine so salty and so dense that they flow along the ocean floor like rivers on land, carving channels, forming meanders, and even creating underwater waterfalls where the brine cascades over underwater cliffs. These brine channels are fed by the dissolution of ancient salt deposits buried beneath the Mediterranean seafloor, remnants of the Messinian salinity crisis we discussed in Part 2, when the Mediterranean dried up and left behind enormous salt deposits that were later buried by sediment. When seawater seeps into these buried salt deposits, it dissolves the salt and becomes a dense brine that is up to 8 times saltier than normal seawater. This brine is so dense that it cannot mix with the overlying seawater and instead flows downslope along the seafloor, seeking the lowest point in the basin. The largest of these brine channels, discovered in the 1990s using deep-towed sonar, extends for over 60 kilometers across the Mediterranean seafloor, winding through valleys and around obstacles exactly as a river would on land. The brine in the channel is completely anoxic, containing no dissolved oxygen, and is toxic to most marine life, but it is not lifeless. The interface between the brine and the overlying seawater supports communities of specialized bacteria that metabolize the chemical gradients between the two fluids, and these bacteria in turn support small populations of mussels, tube worms, and other organisms adapted to this extreme environment. Divers and submersibles approaching these brine pools describe the surreal experience of seeing a distinct shoreline on the seafloor, a clear boundary between the transparent brine and the overlying seawater, with waves and ripples on the brine surface caused by deep-sea currents. Some divers have descended into shallow brine pools, experiencing the bizarre sensation of sinking through the dense brine as if it were a separate liquid layer, which effectively it is. The ocean contains landscapes within landscapes, rivers flowing through seas, lakes pooling on the seafloor, waterfalls cascading in the darkness. It is a world of extraordinary complexity, even in places where we assumed there was nothing but water. Fact 84: the Ostax, zombie worm, eats bones. In 2002, researchers using remotely operated vehicles to study whale fall ecosystems in Monterey Bay, California, discovered something extraordinary clinging to the bones of a dead gray whale lying on the seafloor. Small, pinkish worms, each only a few centimeters long, were attached to the whale bones, their feathery plumes waving in the water. But the worms had no mouth, no gut, and no obvious way of feeding. Further study revealed one of the most unusual organisms ever discovered. The worms, subsequently named Ostax, Latin for bone-eating, were drilling into the whale bones using root-like structures, dissolving the bone tissue with acids and absorbing the lipids and proteins inside. The worms had no digestive system of their own. Instead, they harbored symbiotic bacteria inside specialized organs in their root structures, and these bacteria digested the bone nutrients and provided them to the worm. The Ostax worms exhibit extreme sexual dimorphism. The visible pinkish worms are all females. The males are microscopic, barely a millimeter long, and live inside the female's body as parasites, doing nothing but producing sperm to fertilize the female's eggs. A single female may harbor dozens or even hundreds of dwarf males living inside her, never leaving, never feeding independently, existing only to reproduce. Since their discovery, Ostax worms have been found at whale falls around the world, and on the bones of other marine mammals, large fish, and even sea turtles. They play a critical role in the final stage of whale fall ecosystems, the stage where even the bones are consumed and recycled back into the ocean. Without Ostax and similar bone-eating organisms, the skeletons of whales and other large animals would persist on the seafloor for thousands of years. Instead, they are broken down within decades, their nutrients returned to the ecosystem. The discovery of Ostax also raises an intriguing question. How did these worms evolve? Whale falls have only existed for about 30 to 40 million years, since whales evolved and began dying in the ocean. What did Ostax eat before whales? Some researchers have proposed that Ostax originally evolved to feed on the bones of marine reptiles, the giant plesiosaurs, mosasaurs, and ichthyosaurs of the Mesozoic era, and survived the mass extinction 66 million years ago by switching to whale bones when whales became abundant. If this hypothesis is correct, Ostax is a living link to the age of marine reptiles, a worm that once fed on dinosaur bones, adapted to feed on whale bones, and persists today in the depths of the ocean. Fact 85: the ocean's loudest natural sound was heard across the entire Pacific. On August 27, 1883, the volcanic island of Krakatoa in Indonesia erupted in one of the most violent volcanic events in recorded history. The explosion was heard 3,000 kilometers away. The pressure wave from the blast circled the Earth multiple times and was detected on barometers around the world. The tsunami generated by the eruption killed over 36,000 people. And the sound of the eruption, traveling through the ocean as an acoustic wave, was detected by underwater listening stations across the entire Pacific Ocean. The Krakatoa eruption is estimated to have produced a sound intensity of approximately 310 decibels at the source, a level of sound so extreme that it exceeds the threshold of hearing and enters the realm of pressure waves that cause physical damage. For comparison, a gunshot at close range produces approximately 140 to 170 decibels. The loudest sounds humans can survive exposure to without permanent damage are around 130 to 140 decibels. At 310 decibels, the sound is not just loud, it is a physical force, a shock wave capable of rupturing eardrums and lungs. The acoustic energy from the Krakatoa eruption propagated through the ocean for thousands of kilometers, traveling through the deep sound channel, the SOFAR channel we discussed in part 3, with minimal loss. Underwater listening stations detected the sound across the Pacific, from Japan to California to Antarctica. It remains the loudest natural sound ever reliably measured and recorded. But Krakatoa was not the only extremely loud natural ocean sound. Submarine volcanic eruptions, underwater landslides, and the carving of enormous icebergs from Antarctic ice shelves all produce sounds of extraordinary intensity. In 1997, NOAA's hydrophone arrays detected a sound nicknamed bloop, which we discussed in part 4, that was loud enough to be detected across the entire Pacific. While bloop was eventually determined to be the sound of an icequake, its loudness was such that, had it been biological in origin, it would have been produced by an animal far larger than any known whale. The ocean is not silent. It is a realm of sounds that dwarf anything produced on land, sounds that travel for thousands of kilometers, sounds that shake the ocean floor, sounds that no human will ever hear in their full, terrible intensity. Fact 86: some deep-sea fish have teeth so large they can't close their mouths. In the permanent darkness of the bathypelagic zone, the midnight zone below 1,000 meters, food is extraordinarily scarce. Organisms living at these depths may go weeks or months between meals. When a predator encounters prey, it cannot afford to let it escape. This ecological pressure has driven the evolution of some of the most extraordinary and nightmarish predatory adaptations in the animal kingdom. The deep-sea viperfish Chorliotis sloani is a prime example. It is a relatively small fish, typically 20 to 30 centimeters long, but it possesses teeth that are proportionally among the largest of any fish. The viperfish's lower fangs are so long, up to half the length of the fish's head, that they cannot fit inside its mouth when the mouth is closed. Instead, the teeth curve backward and upward, extending past the fish's eyes when the mouth is shut, to accommodate these enormous teeth. The viperfish has a hinged skull that allows it to open its mouth to an angle of nearly 90 degrees, creating a gape large enough to swallow prey nearly as large as itself. The fanged dragonfish, family Stomiidae, has a similar adaptation. Its teeth are needle-like and extremely long, designed to impale prey and prevent it from escaping. The fish's jaw can unhinge to accommodate prey larger than its normal mouth opening, and its stomach can expand dramatically to contain meals that may represent a significant fraction of the fish's own body weight. These extreme adaptations make sense in the context of the deep-sea environment. If you encounter food only rarely, you need to be able to capture and consume prey of any size you encounter, even if that prey is as large as you are. The enormous teeth and expandable jaws of deep-sea predators are solutions to the problem of unpredictable food availability in an environment where every meal might be the last for weeks or months. The deep-sea fish with teeth too large to close their mouths are a reminder that evolution does not optimize for elegance or beauty. It optimizes for survival. And in the deep ocean, survival often requires adaptations that look, to our surface-dwelling eyes, like monsters from nightmares. Fact 87. The Bermuda Triangle has no more disappearances than any other ocean area. No discussion of ocean mysteries would be complete without addressing one of the most famous and most misunderstood ocean legends. The Bermuda Triangle, also known as the Devil's Triangle, a loosely defined region of the western North Atlantic, roughly bounded by Miami, Bermuda, and Puerto Rico. The legend of the Bermuda Triangle holds that ships and aircraft disappear in this region at a rate far higher than would be expected by chance, and that these disappearances are unexplained, attributed to everything from magnetic anomalies and methane gas eruptions to alien abductions and portals to other dimensions. The reality is considerably more mundane. Statistical analyses of shipping and aviation incidents show that the Bermuda Triangle has no higher rate of disappearances than any other comparably sized and comparably trafficked region of ocean. The Triangle is one of the most heavily traveled shipping lanes in the world, connecting the east coast of the United States with the Caribbean and South America, and it is heavily used by both commercial and recreational aircraft. With such high traffic volumes, incidents are inevitable, and the rate of incidents in the Bermuda Triangle is entirely consistent with the global average. Many of the famous disappearances attributed to the Bermuda Triangle have mundane explanations. Flight 19, a group of 5 US Navy torpedo bombers that disappeared in 1945, almost certainly ran out of fuel after the flight leader became disoriented and led the group far out over the Atlantic. The USS Cyclops, a Navy cargo ship that disappeared in 1918 with 309 people aboard, likely sank due to structural failure, possibly exacerbated by overloading and severe weather. The disappearance of these and other vessels, while tragic, does not require supernatural or extraordinary explanations. The Bermuda Triangle legend is a reminder of how easily patterns can be perceived in random data, how readily mysteries can be invented when explanations are not immediately available, and how persistent legends can be even when the evidence does not support them. The ocean contains genuine mysteries, but the Bermuda Triangle is not one of them. Fact 88. Coral reefs support 25% of marine life, but cover less than 1% of the ocean. Coral reefs are among the most productive and biodiverse ecosystems on Earth. Despite covering less than 1% of the ocean floor, an area of approximately 280,000 square kilometers, roughly the size of Italy, coral reefs support approximately 25% of all marine species. An estimated 1 to 2 million species, fish, invertebrates, algae, and other organisms, depend on coral reefs for food, shelter, or reproduction at some point in their life cycle. The extraordinary productivity and diversity of coral reefs is the result of the symbiotic relationship between corals and zooxanthellae, photosynthetic algae that live inside coral tissues and provide the coral with energy in exchange for nutrients and a protected environment. This symbiosis allows corals to grow rapidly in nutrient-poor tropical waters, building the massive limestone structures that form the physical foundation of the reef and support the countless organisms that live on, in, and around it. But coral reefs are in crisis. Climate change-driven ocean warming has triggered multiple mass bleaching events in recent decades, episodes in which corals expel their zooxanthellae in response to heat stress, turning white and becoming vulnerable to starvation and disease. The Great Barrier Reef has experienced 5 mass bleaching events since 1998, with the 2016 and 2017 events killing approximately half the coral in some sections of the reef. Reefs in the Caribbean have lost over 80% of their coral cover since the 1970s. Reefs in Southeast Asia and the Indian Ocean have been severely degraded by overfishing, pollution, and coastal development. Current projections suggest that if ocean temperatures continue to rise at the current rate, Most of the world's coral reefs will experience annual bleaching events by the 2040s, a frequency that will not allow time for recovery between events, leading to the collapse of reef ecosystems on a global scale. The loss of coral reefs would be an ecological catastrophe, eliminating the habitat for a quarter of all marine species, destroying the coastal protection that reefs provide to millions of people, and eliminating a source of food and income for over 500 million people who depend on reefs for their livelihoods. The coral reefs are the rainforests of the ocean, and like the rainforests, they are being destroyed faster than they can recover, in full view of a global society that understands the consequences but has not yet found the will to prevent them. Fact 89, the ocean floor has black smokers that spew water hot enough to melt lead. Hydrothermal vents, the extraordinary deep-sea ecosystems we have discussed multiple times in this series, come in several varieties, but the most dramatic and visually spectacular are the black smokers, chimney-like structures on the ocean floor from which plumes of superheated, mineral-rich water pour at temperatures that can exceed 400 degrees Celsius. Black smokers form at mid-ocean ridges and other sites of active seafloor volcanism, where cold seawater seeps down through cracks in the oceanic crust, is heated by contact with magma chambers close to the surface, and emerges back into the ocean carrying dissolved minerals, primarily sulfides of iron, copper, zinc, and other metals. When the superheated vent fluid contacts the cold seawater of the deep ocean, the dissolved minerals precipitate out of solution, forming dark clouds, these smoke, and accumulating around the vent opening to build chimney structures that can grow to heights of 10 to 20 meters or more. The temperature of the water emerging from black smokers is extraordinary. At 400 degrees Celsius, the vent fluid is hot enough to melt lead, which melts at 327 degrees Celsius. It is hot enough to cause severe burns in a fraction of a second. And yet the water does not boil, because the extreme pressure at depth, typically 200 to 400 atmospheres, raises the boiling point of water far above its surface boiling point of 100 degrees Celsius. The superheated water remains liquid, pouring from the vent in a continuous stream. The communities of life that colonize black smokers are among the most extraordinary on Earth. Tube worms up to 2 meters long, with blood-red plumes, cluster around the vent openings, their roots extending into the chimney structure to access the sulfide-rich fluid. Mats of white bacteria cover the surrounding seafloor, metabolizing hydrogen sulfide and serving as the base of the food web. Eyeless shrimp, pale crabs, and strange fish patrol the edges of the vent fields, feeding on the bacteria and on each other. Black smokers are not just biological wonders, they are also economically significant. The chimneys and surrounding seafloor accumulate high concentrations of valuable metals, copper, zinc, gold, silver, and several countries and companies have proposed mining these deposits. But deep-sea mining would destroy the vent ecosystems, communities that took thousands of years to develop, that exist nowhere else on Earth, and that we have barely begun to study. The question of whether the economic value of the metals justifies the ecological cost of extraction is one of the most contentious issues in ocean policy. Fact 90, orcas have culture and pass knowledge between generations. The orca, Orcinus orca, also known as the killer whale despite being the largest member of the dolphin family, is one of the ocean's most intelligent and socially complex animals. Orcas live in stable family groups called pods, which can persist for generations, and they exhibit behaviors that can only be described as cultural. Learned behaviors that are passed from generation to generation within specific populations, but that differ between populations, even when those populations live in similar environments and have access to the same resources. The most striking example of orca culture is hunting specialization. Orcas in different regions have developed completely different hunting techniques, which are taught by mothers to their offspring and maintained within pods over many generations. Orcas in the Antarctic have developed a technique for hunting seals resting on ice floes. The pod swims together toward the ice floe in a coordinated wave, creating a surge of water that washes the seal off the ice and into the ocean, where the orcas can catch it. This technique, called wave washing, requires precise coordination and timing, and young orcas spend years learning it by observing and practicing with experienced adults. Orcas off the coast of Argentina have developed a different technique: intentional beaching. These orcas deliberately swim onto beaches at high tide to catch seals and sea lions resting on shore, then use body movements to work themselves back into the water before the tide recedes. This is an extraordinarily dangerous behavior. A miscalculation can leave the orca stranded and vulnerable to death by overheating or dehydration, but it is highly effective, and it is taught to young orcas through patient demonstration and supervised practice. Different orca populations also have different vocal dialects, specific call patterns that are unique to individual pods and that allow orcas to identify which pod another individual belongs to just by listening to its calls. These dialects are learned, not innate, and they change over time as new calls are invented and old calls fall out of use, exactly as human languages do. The existence of culture in orcas, and in other cetaceans, including humpback whales, sperm whales, and dolphins, has profound implications for how we understand animal intelligence and for how we should treat these animals ethically. If orcas have culture, if they teach their young, if they maintain knowledge across generations, then they are not just intelligent, they are, in a meaningful sense, persons. The ocean contains minds of extraordinary depth and complexity. And we are only beginning to understand what those minds are capable of. Fact 91: the ocean is absorbing sound, and this is killing marine mammals. The ocean has become dramatically noisier over the past century. The introduction of engine-powered ships, the expansion of offshore oil and gas exploration using seismic air guns, the proliferation of naval sonar systems, and the general increase in maritime traffic have filled the ocean with noise, low-frequency rumbles from ship engines, high-intensity pulses from seismic surveys, and the powerful sonar pings of military vessels. This noise is not a minor inconvenience for marine life, it is a serious threat, particularly to marine mammals that depend on sound for communication, navigation, and hunting. Whales and dolphins use sound to locate prey, to communicate with other members of their species over distances of hundreds of kilometers, and to navigate through the ocean. For these animals, hearing is not just important, it is essential for survival. Loud noise in the ocean can cause direct physical damage to marine mammals, ruptured eardrums, damage to inner ear structures, and in extreme cases, hemorrhaging and death. But even at low intensities, noise can cause behavioral changes. Whales altering their migration routes to avoid noisy areas, dolphins ceasing to vocalize in the presence of loud noise, entire populations being displaced from critical feeding or breeding habitats. Some of the most disturbing evidence of noise impacts comes from mass strandings of beaked whales, deep-diving whales that are rarely seen at the surface and that are highly sensitive to acoustic disturbance. Multiple mass strandings of beaked whales have been directly linked to naval sonar exercises, events in which dozens of whales beach themselves and die, apparently fleeing from the intense sonar pulses in a panic that drives them into shallow water where they cannot survive. Autopsies of stranded beaked whales have found evidence of decompression sickness, a condition normally not seen in whales, who are physiologically adapted to avoid it, but which can occur if whales surface too rapidly from deep dives in an attempt to escape a perceived threat. The noise problem in the ocean is solvable. Ships can be quieter, seismic surveys can use alternative technologies, naval exercises can be conducted in ways that minimize impacts on marine mammals. But solving it requires acknowledging that the ocean is not a silent void into which we can pour unlimited noise without consequence. It is a soundscape, a three-dimensional acoustic environment in which sound is the primary sensory modality for many of the ocean's most intelligent inhabitants. And we are flooding that soundscape with noise. Fact 92: the ocean contains extremophiles that redefine the limits of life. The deep ocean has become one of the most important frontiers in the search for the limits of life on Earth. In the sediments of the abyssal plains, in the boiling water of hydrothermal vents, in the crushing pressure of Hadal trenches, and in the toxic, acidic water of brine pools, scientists have found organisms, primarily bacteria and archaea, but also some eukaryotes, that survive in conditions that were once thought to be completely incompatible with life. Some of these extremophiles survive at temperatures far beyond the boiling point of water. Methanopyrus candleri, an archaeon found near hydrothermal vents, can grow and reproduce at temperatures up to 122 degrees Celsius, well above the boiling point of water at atmospheric pressure. The proteins and cell membranes of these organisms are adapted to remain stable and functional at temperatures that would denature the proteins of most organisms within seconds. Other extremophiles survive in extremely acidic or alkaline conditions. Bacteria have been found in pH environments ranging from below 0, more acidic than battery acid, to above 12, more alkaline than bleach. Some survive in water with salt concentrations several times higher than seawater. Some survive in environments with essentially no oxygen, using alternative metabolic pathways that extract energy from sulfur, iron, or other elements. And some survive at extraordinary pressures. Bacteria have been recovered from the deepest parts of the Mariana Trench, at pressures exceeding 1,000 atmospheres, and cultured in laboratories under high-pressure conditions. These organisms possess cellular adaptations that prevent their membranes from being crushed and their proteins from being disrupted by the extreme pressure. The discovery of these extremophiles has fundamentally expanded our understanding of the conditions under which life is possible. For decades, Astrobiologists assumed that the search for life elsewhere in the solar system should focus on environments similar to Earth's surface: moderate temperatures, liquid water, near-neutral pH, atmospheric pressure. The extremophiles of Earth's deep ocean have shown that life can thrive in environments far more extreme, and that the potentially habitable zones of other planets and moons are much larger than we thought. The subsurface oceans of Europa, Enceladus, and other icy moons of the outer solar system are cold, dark, and high-pressure environments, very similar to Earth's Hadal trenches. If life exists there, it may resemble the extremophiles of Earth's deep ocean more than it resembles anything on Earth's surface. The deep ocean is not just our planet's last frontier, it may be our best analog for what life elsewhere in the solar system might look like. Fact 93. The ocean produces natural antifreeze. In the frigid waters of the polar oceans, where water temperatures can drop to -2 degrees Celsius, below the freezing point of freshwater but not of saltwater, some fish species face a lethal challenge: the formation of ice crystals inside their bodies. Even though the surrounding seawater remains liquid at these temperatures, the blood and body fluids of fish are less salty than seawater and would normally freeze at temperatures around -1 degree Celsius. Ice crystals forming in the blood or tissues would be fatal, rupturing cells and destroying organs. Antarctic fish have evolved an extraordinary solution to this problem: antifreeze glycoproteins, AFPs, specialized proteins that circulate in their blood and bind to any ice crystals that begin to form, preventing them from growing large enough to cause damage. These antifreeze proteins work not by lowering the freezing point of the blood, as chemical antifreeze does in a car engine, but by inhibiting ice crystal growth, binding to the surface of tiny ice crystals, and preventing water molecules from joining the crystal lattice, keeping the crystals small and harmless. The antifreeze proteins of Antarctic fish are so effective that some species can survive in water as cold as -2.5 degrees Celsius, colder than the normal freezing point of their blood, without freezing solid. The fish essentially live in a supercooled state, their body fluids remaining liquid at temperatures where they should freeze, protected by the antifreeze proteins circulating continuously through their blood. The discovery of biological antifreeze has had practical applications. Antifreeze proteins from fish have been studied as potential additives for human organ preservation during transplant surgery, allowing organs to be stored at lower temperatures for longer periods without ice damage. They have been investigated as additives for frozen foods to prevent ice crystal formation that causes freezer burn. And they have been studied as potential components of ice-resistant coatings for aircraft and infrastructure in cold climates. The ocean's organisms have solved problems that human engineers are still struggling with, and by studying these biological solutions, we can develop technologies that might never have been imagined without the ocean's example. Fact 94. The ocean contains forests of giant kelp. When we think of forests, we think of trees on land, redwoods, rainforests, boreal woodlands. But the ocean also contains forests, underwater forests of giant kelp, Macrocystes pyrifera, that grow along the rocky coastlines of temperate oceans and create some of the most productive and diverse ecosystems in the sea. Giant kelp is not a plant, but a brown algae, one of the fastest-growing organisms on Earth, capable of growing up to 60 centimeters per day under optimal conditions. Individual kelp plants can reach lengths of 30 to 45 meters, rising from rocky holdfasts on the seafloor to the surface, where their fronds spread across the water in dense canopies that block sunlight from reaching the seafloor below. Kelp forests support extraordinary biodiversity. Fish, including many commercially important species like rockfish and lingcod, shelter among the kelp fronds. Sea otters wrap themselves in kelp to avoid drifting while they sleep. Seals hunt in the kelp forests, using the kelp as cover. Invertebrates, sea urchins, abalone, sea stars, crabs, graze on the kelp or on the algae and sessile organisms that grow on its surface. Seabirds dive into kelp forests to catch fish. Grey whales migrate through kelp forests on their way to breeding grounds. But kelp forests are vulnerable. Sea urchins, the primary herbivore in kelp forest ecosystems, can overgraze kelp if their populations are not controlled by predators. When sea otter populations collapsed in the 20th century due to hunting, sea urchin populations exploded, and vast areas of kelp forest were grazed down to bare rock, a state called an urchin barren. The kelp forests have recovered in some areas where sea otters have been reintroduced, demonstrating the critical role that top predators play in maintaining ecosystem balance. Kelp forests are also vulnerable to ocean warming. Marine heat waves in recent years have caused massive die-offs of kelp along the Pacific coast of North America and in other regions, transforming productive kelp forests into barren seafloor almost overnight. The loss of kelp forests means the loss of the hundreds of species that depend on them, and the loss of one of the ocean's most productive and important ecosystems. Fact 95. The ocean floor is moving beneath our feet. The ocean floor is not a permanent feature of the Earth's surface. It is in constant motion, created at mid-ocean ridges by volcanic activity, moving across the ocean basins as the tectonic plates spread apart, and eventually being consumed at subduction zones where one plate dives beneath another and is recycled back into the Earth's interior. The rate of seafloor spreading varies by location, but typical rates are 2 to 10 centimeters per year, approximately the rate at which human fingernails grow. This may sound slow, but over geological time, the cumulative effect is enormous. The Atlantic Ocean is widening by approximately 2.5 centimeters per year as new oceanic crust is created at the mid-Atlantic ridge. In 100 million years, the Atlantic will be approximately 2,500 kilometers wider than it is today. The Americas will be farther from Europe and Africa than at any point in Earth's history. At the same time, the Pacific Ocean is shrinking. The oceanic crust of the Pacific is being consumed at subduction zones around the Pacific Rim, the Ring of Fire, at a faster rate than new crust is being created at the East Pacific Rise. In approximately 200 to 300 million years, the Pacific may have largely disappeared, and the Americas may have collided with Asia to form a new supercontinent. The movement of the ocean floor is not just a matter of distant geological interest, it has direct consequences for human civilization. Subduction zones are the sites of the world's largest earthquakes and most explosive volcanic eruptions. The 2004 Indian Ocean earthquake, which triggered the tsunami that killed over 230,000 people, occurred at a subduction zone where the Indo-Australian plate is diving beneath the Burma plate. The 2011 Tohoku earthquake in Japan, which triggered the tsunami that caused the Fukushima nuclear disaster, occurred where the Pacific plate is subducting beneath the Eurasian plate. The volcanic eruptions that have devastated coastal communities, Krakatoa in 1883, Mount Pinatubo in 1991, and countless others, occur at subduction zones where the descending oceanic crust melts and generates magma that rises to the surface. The ocean floor is moving, and its motion shapes the world in which we live. Fact 96. Whale songs can be heard across entire ocean basins. The songs of humpback whales, complex vocalizations that can last for 10 to 20 minutes and be repeated for hours, are among the most extraordinary acoustic phenomena in the animal kingdom. Male humpback whales sing during the breeding season, producing sequences of moans, howls, cries, and complex melodic patterns that are unique to each population and that change gradually over time. But what makes whale songs truly extraordinary is their range. The low-frequency components of humpback whale songs, typically in the range of 20 to 200 Hz, can travel enormous distances through the ocean, particularly when the sound propagates through the SOFAR channel, the deep sound channel we have discussed multiple times. Under optimal conditions, whale songs can be detected at ranges of over 1,000 kilometers from the singing whale, and possibly much farther. Before the Industrial Revolution filled the ocean with ship noise, the acoustic environment of the ocean was dominated by natural sounds, the calls of whales, the crackling of shrimp, the rumble of earthquakes and storms. In this quieter ocean, whale songs may have traveled across entire ocean basins. A whale singing in the Caribbean might have been heard by another whale near the Azores, 5,000 kilometers away. The ocean was an acoustic network, connecting whales separated by thousands of kilometers of open water. The function of whale songs is still debated. They are produced only by males, suggesting a role in attracting mates or establishing dominance. The songs change over time within a population. New phrases are introduced, old phrases drop out, and occasionally entire new songs sweep through a population, replacing the previous song within a single breeding season. This cultural transmission of song, where all males in a population conform to the current song pattern, suggests that the songs may function as a form of cultural display, with females preferring males who sing the current, fashionable song. But the modern ocean is noisier than at any point in history. Ship noise has reduced the acoustic range of whale songs by approximately 90%. A whale that could once be heard across an ocean basin can now be heard only a few hundred kilometers away. The ocean's acoustic network has been fragmented by noise, and the consequences for whale communication and social structure are unknown but potentially severe. Fact 97. The ocean is home to viruses that infect and kill bacteria. The ocean contains an estimated 1030 viruses, 10 million trillion individual viral particles, more than all other biological entities in the ocean combined. These viruses are not infectious to humans or to marine animals. They are bacteriophages, viruses that infect and kill bacteria. Marine viruses play an enormous and previously underappreciated role in ocean ecology. Every day, viruses kill approximately 20% of all the bacterial cells in the ocean. This viral mortality releases enormous quantities of organic carbon and nutrients that would otherwise be locked inside bacterial cells, making those nutrients available to other organisms and driving the marine food web in ways that scientists are only beginning to understand. Viruses also drive bacterial evolution. When a virus infects a bacterial cell, it sometimes incorporates pieces of bacterial DNA into its own genome and then transfers that DNA to the next cell it infects, a process called horizontal gene transfer. This means that viruses function as vectors for moving genetic material between bacteria, accelerating the rate of bacterial evolution and allowing bacteria to acquire new capabilities, including antibiotic resistance, far faster than would be possible through mutation alone. The diversity of marine viruses is staggering. Most have never been studied or even identified. Metagenomic studies, which sequence all the DNA in a sample of seawater, have revealed thousands of previously unknown viral genomes, representing viral families and lineages that have no known relatives and whose functions are completely mysterious. The ocean's viral community is the most diverse and least understood component of marine ecosystems, and possibly the most important in terms of its influence on the flow of energy and nutrients. Fact 98: the ocean may rise by more than a meter this century. We have discussed sea level rise in earlier parts of this series, but the projections deserve emphasis because the consequences are so significant. Current estimates, based on climate models and observations of ice sheet behavior, suggest that global sea level could rise by 60 centimeters to 1.1 meters by the year 2100 under moderate to high emissions scenarios. A rise of 1 meter would inundate coastal areas that are currently home to hundreds of millions of people. It would permanently submerge many low-lying island nations, including the Maldives, Kiribati, and Tuvalu, making them uninhabitable. It would flood coastal cities including Miami, New Orleans, Venice, Bangkok, Shanghai, and Mumbai, forcing mass relocations and causing trillions of dollars in damage. It would contaminate freshwater aquifers with saltwater, making coastal agricultural land unusable. And it would increase the frequency and severity of coastal flooding during storms, making areas that are currently habitable only occasionally flooded and areas that are occasionally flooded permanently inundated. Some recent research suggests that even these projections may be too conservative. The behavior of ice sheets, particularly the West Antarctic ice sheet and portions of the Greenland ice sheet, is less stable than previously thought, and the possibility of rapid ice sheet collapse cannot be ruled out. If portions of these ice sheets were to collapse within this century, a low probability but high consequence scenario, sea level rise could reach 2 meters or more by 2100. The ocean is rising. The consequences are predictable, severe, and in many cases irreversible on human timescales. Coastal cities can be protected with seawalls and other infrastructure, but only at enormous cost, and not all cities will be able to afford that protection. Island nations cannot be protected. They will simply disappear beneath the waves. The geography of the world is going to change within the lifetimes of people alive today. Fact 99: the deep ocean is Earth's largest habitat. Here is a fact that places everything else in perspective. The deep ocean, defined as the ocean below 200 meters depth, represents approximately 90% of the biosphere by volume. It is the largest habitat on Earth by an enormous margin, containing more living space than all terrestrial environments, all shallow seas, all freshwater environments, and all of Earth's atmosphere combined. And yet it is the least studied, least understood, and least protected environment on the planet. We have better maps of Mars than we have of the deep ocean floor. We have sent more people to the moon than to the deepest point in the ocean. The vast majority of species living in the deep ocean have never been observed or described by science. The ecology, chemistry, and geology of the deep ocean remain largely unknown. This is beginning to change. Advances in underwater technology, remotely operated vehicles, autonomous underwater vehicles, deep-sea submersibles, acoustic mapping systems, are making it possible to explore the deep ocean in ways that were impossible a generation ago. The cost of deep-sea exploration is falling. The capabilities of underwater robots are increasing, and the scientific and public interest in the deep ocean is growing. But the deep ocean is also under threat. Deep-sea fishing, particularly bottom trawling, is destroying seamount ecosystems and deep-sea coral reefs. Deep-sea mining is being proposed for polymetallic nodules on the abyssal plains and for mineral deposits at hydrothermal vents. Climate change is altering the chemistry, temperature, and circulation of the deep ocean in ways we do not fully understand, and plastic pollution has reached even the deepest trenches. The deep ocean is the largest habitat on Earth. It is the least known, and it is being changed and damaged before we have had a chance to understand what we are losing. Fact 100: we are the ocean, and the ocean is us. We end where we began, with the recognition of connection. The ocean covers 71% of Earth's surface. It produces at least half the oxygen we breathe. It regulates the climate that makes human civilization possible. It drives the water cycle that provides fresh water to the continents. It has shaped the evolution of life on Earth for 3.5 billion years, and it continues to shape our world today in ways large and small, obvious and hidden. But the connection runs deeper than ecology or climate. The water in your body, the water that makes up approximately 60% of your mass, the water in your blood and your cells and your tissues, came from the ocean. Every molecule of water you have ever drunk has cycled through the ocean countless times over Earth's history. You are, in a very literal sense, made of ocean water. The salt in your blood, sodium, potassium, chloride, and other ions, exists in concentrations that mirror the composition of seawater, a legacy of the fact that life evolved in the ocean and brought the chemistry of seawater with it when it colonized the land. Your blood is seawater, modified and concentrated, carrying oxygen and nutrients through your body, the way ocean currents carry oxygen and nutrients through the sea. The rhythms of your body, the circadian rhythms that govern sleep and waking, the tidal rhythms that influence hormone levels and biological processes, evolved in ancestors that lived in the ocean and were governed by the cycles of light and tide. You carry the ocean inside you, not just chemically but temporally. Your biology is tuned to rhythms that originated in the sea. And the future of the ocean is your future. If the ocean warms, you will experience the consequences in changed weather patterns, rising seas, disrupted food systems. If the ocean acidifies, the collapse of marine ecosystems will affect the food security of billions of people. If the ocean's circulation weakens or collapses, the climate of entire continents will change in ways that make current patterns of agriculture and habitation impossible. We are not separate from the ocean. We are part of it. We evolved from it. We depend on it. And what we do to the ocean, we do to ourselves. This has been 100 facts about the deep ocean. 100 facts about a world that is larger, stranger, more beautiful, more fragile, and more important than most people imagine. A world that covers most of our planet, and yet remains largely unexplored. A world that has shaped the history of life on Earth, and that will shape our future. The ocean is not a resource to be exploited. It is not a waste dump for our pollution. It is not an infinite reservoir that can absorb unlimited heat and carbon and plastic without consequence. The ocean is the foundation of the Earth system. It is the largest habitat on the planet. It is home to creatures of extraordinary beauty and strangeness, to ecosystems that have existed for millions of years, to mysteries we have barely begun to investigate. And it is changing, faster than at any time in hundreds of millions of years, because of what we have done and what we continue to do. The ocean has carried us through this journey, from the sunlit surface to the deepest trench, from the smallest virus to the largest whale. From the ancient shipwrecks that preserve our history to the rising seas that will shape our future. Now the question is, what will we do with what we know? The ocean is waiting, and it remembers everything. Close your eyes, remember what you have learned, and when you wake, act.